This is Qingdao. This young coastal city has now become the third largest city in northern China in terms of economic output, ranking just behind Beijing and Tianjin. It is nestled by the coast and vying for attention with an explosive twist. That's right, beneath the waves is right at the construction site of the Jiaozhou Bay second undersea tunnel, soon to be the world's lengthiest underwater highway. But Qingdao isn't new to smashing records. A dozen years back, they dropped the mic with the Jiaozhou Bay Bridge and Tunnel, stealing the spotlight as the planet's longest cross-sea bridge and China's reigning underwater tunnel champions. So, what's cooking with this new world record and Qingdao's sudden passion for sea-spanning structures? Well, let's rewind and appreciate Qingdao's cozy embrace of Jiaozhou Bay, which, believe it or not, was once just an ordinary basin. A mere 11,000 years ago, a bit of sea level drama transformed it into the spectacular Jiaozhou Bay we see today. With its deep, expansive harbor and impeccable geography, Qingdao proudly houses the world's fourth largest port, Qingdao Port, and it's not just a port, it's the heart of the city. On the bay's east side, you'll find the old city of Qingdao, while to the west coast new area, affectionately known as Huangdao, has taken shape. 3 decades ago, crossing the bay meant leisurely ferry rides, taking a whole hour to get across, not exactly a whirlwind. Things got a bit speedier with the Coastal Bay Highway, trimming the journey to a brisk 50 minutes. But the real game changer arrived in 2011 with the Jiaozhou Bay Bridge and Tunnel, slashing travel time to a jaw-dropping 6 minutes. Suddenly, Qingdao's free trade zone, economic development zone, port hubs, and the legendary Qingdao International Beer Festival all relocated to the West Coast new area. Cross-bay traffic went through the roof, with nearly 200,000 vehicles making the journey daily. To earn its title as a true bay city, Qingdao needed a fresh cross-sea passage, one that doesn't tick off Poseidon, scoffs at strong winds and fog, and keeps the travel vibes alive around the clock. Enter the Jiaozhou Bay second undersea tunnel now under construction. But it's not without its challenges. Stretching for a whopping 14.37 kilometers, it boasts 6 lanes in each direction and plummets to depths of 115 meters below sea level. Talk about tunneling into the unknown. This tunnel has to face 2 distinct rock formations. On the Huangdao side, it's all about rugged granite, while Qingdao's soft gray limestone and sandy layers add a twist. Plus, there are 22 faults lurking around, with the Big Daddy named Sanko Fault, a behemoth spanning over 200 meters. It's like a line in the sand, separating flat plains in the west from hilly terrain ruled by Laoshan Mountain in the east. Now, how do you drill through this geological maze? There's the drill and blast method, great for both hard and soft rock. Then there's the shield tunnel boring machine, TBM, method and the immersed tube method. Immersed tubes are costly and messy for the environment, so they're out. Faced with a cross-sectional diameter of 15.6 meters and water depths exceeding 100 meters, the TBM construction method carries significant risks, and therefore, it is also ruled out. So, considering the distribution of rock formations, combining drilling and blasting with shield tunneling is the most reliable construction method. Start with drill and blast, a real rock and roll show, with engineers drilling 254-meter deep holes into granite faster than you can say explosives. Speaking of which, those sausage-looking explosives fit snugly into the holes and, with precise placement, blast the rock into shape. There's more to do, as these blast holes need 3 layers of reinforcement, inner and outer concrete jackets with a waterproof layer in between. And there you have it, the tunnel in the making. Yet, the real cliffhanger isn't the rock, it's the lurking faults, waiting to crash the party. The fragile rock here demands caution, or a floodgate of groundwater or seawater could wash everything away. So, radar scouts ahead. And if conditions look dicey, holes are drilled and cement injected to fortify the fissures. This solid barrier not only blocks water but strengthens the tunnel, letting it inch forward through the colossal Tsanko Fault at a slow and steady pace of 2 to 3 meters per day. Now, for the softer limestone zones, it's time for the shield tunneling method. Behold the legendary tunnel boring machine, TBM, an 8-meter-wide juggernaut with a cutter head that eats rock for breakfast. It grinds boulders into mud and pumps them out through pipes. Simultaneously, the TBM hoists up concrete segments to create a seamless tunnel lining. It's like a giant palm holding up a 1-ton weight, a true showstopper. Afterward, this colossal machine gets disassembled, transported to a 30-meter deep pit, reassembled, and heads off to conquer the seabed. But here's the kicker, finishing the main tunnel doesn't mean the end of the adventure. What about exhaust gases? What if construction drags on, or heaven forbid, accidents occur? Enter the hero of our story, the service tunnel. It's not for regular traffic, but it's the control center for tunnel wizardry, maintenance, pipelines, and emergency escapes. It's the tunnel's hidden superhero, working side by side with the main tunnels. And the big reveal? How do those eastbound and westbound tunnels meet? Imagine an epic chamber beneath the sea, a 30-story behemoth serving as the tunnel's junction and a launching pad for the TBMs. It's not just any chamber, it doubles as a ventilation hub, a feat most undersea tunnels manage with towering ventilation buildings. But not here. They're keeping things marine-friendly by placing those towers on land. The service tunnel, free of vehicles and exhaust, acts as the air channel, splitting the 10-kilometer ventilation distance into 2 neat segments. By the end of 2027, this colossal tunnel will be ready to steal the show. And when you walk through it, don't expect flashy lights or red carpets. It's all about subtlety, hidden beneath the seabed, letting marine life and shipping carry on undisturbed. Super projects don't need to shout. They can make a powerful statement by being remarkably unobtrusive and gentle. So, there you have it. With the might of these super tunnels, Qingdao is set to become a bona fide bay city. Who knows, along China's extensive coastline, from the 20-kilometer Cheongzhou Strait to the 100-kilometer Bohai Strait and the 130-kilometer Taiwan Strait, more natural barriers may soon yield to Chinese engineering genius one by one. Cue the epic tunnel music. The Jiaozhou Bay Second Undersea Tunnel. China's mega projects are one of awe and inspiration. Firstly, let's learn about China's first large-scale engineering project, the Shantou Bay Undersea Tunnel. Once completed, this undersea tunnel holds great significance for the world. Since its groundbreaking, this mega project has garnered attention from many countries. American engineers also expressed skepticism, stating that China was merely boasting and that completing this project was fundamentally impossible. How did Chinese engineers overcome numerous challenges to construct this deep-sea high-speed rail? In recent years, China's reputation in international infrastructure has grown, earning it the title of infrastructure maniac. With the improvement of China's infrastructure technology, many countries around the world are seeking China's assistance in constructing large-scale projects. The Shantou Bay Undersea Tunnel is a crucial control project of the Shanshan Railway, with a designed total length of 9,781 meters, featuring a single-tube double-line tunnel. As a subsea high-speed rail tunnel, it is designed to reach an astonishing speed of 350 kilometers per hour. Not only is this China's first subsea high-speed rail tunnel, but it is also the world's first. It is also an undersea high-speed rail tunnel in China constructed using large-diameter tunnel boring machines. The construction of the Shantou Bay Undersea Tunnel is currently underway, officially starting on March 10, 2020. The 9.8-kilometer section is divided into sea and land segments, with the sea segment spanning 3 kilometers, and the maximum burial depth reaching 100 meters. Being the world's first subsea high-speed rail tunnel with a depth exceeding 100 meters, its construction difficulty is unimaginable. The underwater tunnels are now quite common globally. Worldwide, there are more than 20 existing underwater tunnel examples. Include the 50.5-kilometer Channel Tunnel between England and France, the 23.3-kilometer Seikan Tunnel in Japan, and the 6.7-kilometer underwater tunnel of the Hong Kong-Zhuhai-Macau Bridge. They are mainly distributed in countries and regions such as China, the United States, Japan, and Western Europe. However, only countries with strong engineering capabilities have sufficient funds and advanced technology to construct underwater tunnels. The construction of underwater tunnels is not a simple engineering project. It involves various construction methods, including the drilling and blasting method, which involves inserting explosives into boreholes for blasting, the shield tunneling method and the tunnel boring machine method, which are applicable to soft and hard rock respectively, and the immersed tube method, which involves prefabricating tunnel sections and sinking them to the seabed. The construction process should adopt different methods according to different topography and geology. Apart from the basic tunnel construction, the Shantou Bay undersea tunnel faces its greatest challenge in its geographical location. Located in an active seismic zone, the tunnel crosses 17 fault zones, making the construction highly risky. Construction at depths of over 100 meters underwater presents complex geological challenges. The tunnel also traverses Shantou Bay, where strong winds, high waves, and unfavorable construction factors converge. Most of the tunnel is in a high water pressure risk zone, with the maximum water pressure reaching 1 megapascal. Under such water pressure, unforeseeable consequences could occur in the event of an accident. Therefore, the tunnel's structure must be capable of withstanding high water pressure penetration. Moreover, the marine segment not only faces high water pressure but also highly corrosive seawater, posing a severe test for any construction materials. Any technical issues could lead to unforeseeable risks. Additionally, the use of explosives for underwater blasting is not feasible in large rock areas. Many challenges press down on the construction team like a mountain. Furthermore, laying immersed tubes is not suitable for areas with strong currents, and damage to underwater rocks during excavation poses significant obstacles. It's no wonder Western engineers believe this to be an impossible undersea tunnel project. Why is the construction of the Shantou Bay Tunnel significant for China? This tunnel is the world's first high-speed railway deep-sea tunnel to exceed 100 meters in depth. Its depth surpasses the limit achievable by immersed tube tunnel construction technology, so China must use tunnel boring machines or traditional explosive excavation methods to complete the tunnel excavation. For this purpose, China manufactured a tunnel boring machine specifically for this project. This means that China now can excavate high-speed rail tunnels in deep seas. The tunnel boring machine, measuring 130 meters in total length and weighing 4,600 tons, with a cutter head diameter exceeding 15 meters and a cutter head weight of 570 tons, plays an indispensable role in propelling the entire project forward when operating at the seabed. With a cutter head equivalent to the height of a 5-story building, the construction efficiency and operational capacity are highly effective. 2 tunnel boring machines are advancing in the east and west lines of the seabed, and during excavation, they do not disturb the original structure of the seabed, nor do they pose a danger to construction personnel. In case of fault leakage during construction, the well-designed mechanics automatically block the tunnel using the piston principle, providing valuable time for the safe evacuation of construction personnel and safeguarding against potential hazards for continuing operations. Under the immense pressure of seawater, minor seepage may occasionally occur during construction. If not addressed promptly, these minor leaks could lead to significant seawater ingress problems. Hence, the challenges faced are diverse, requiring solutions to overcome and resolve various issues. During construction, targeted solutions are employed based on the diverse geological conditions detected by advanced equipment, addressing the varying difficulty of rock layers beneath the seabed. China's tunnel boring machines play a vital role in maintaining stability during excavation. They can transport crushed stones and sediments in the rear, improving efficiency and reducing the workload for underwater operation personnel, greatly ensuring the safety of the construction team and making the progress of the entire construction smoother and more efficient. as the Shantou Bay Tunnel is not only the world's first subsea high-speed rail tunnel but also the deepest undersea tunnel globally. Its construction difficulty and associated risks are enormous. This is why American engineers consider China's Shantou Bay undersea tunnel one of the most unique and crucial modern tunnels globally. If China completes the construction of the Shantou Bay undersea tunnel, it will signify that China has mastered the capability of building cross-sea tunnels at depths exceeding 100 meters. Facing challenges such as ventilation and smoke exhaust difficulties, long construction periods, and extended evacuation and rescue times, the design team innovatively proposed a solution by setting up a service tunnel between the two main tunnels. The service tunnel serves as an emergency evacuation route during emergencies and a new air system for the main tunnels in normal situations, controlling the concentration of pollutants and solving the tunnel ventilation problem. This implies that China can build super tunnels capable of crossing large straits, similar to the Channel Tunnel. The construction of the Shantou Bay Undersea Tunnel marks a new milestone for China in undersea tunnel design and construction capabilities. This project is not only a feat in China's construction history but also a milestone in the global tunnel construction field. In Beijing, China, Chinese workers rebuilt a flyover bridge in just 43 hours. In 2015, the Sanyuan Bridge in Beijing underwent a heart-stirring rebirth. An unprecedented project to replace all beams catapulted this busy traffic artery to a historical pinnacle. In a mere 43 hours, at a seemingly magical pace, a brand new bridge emerged, rising from nothing, once again bursting with vitality. Many foreign netizens have praised the speed of construction in China. Some say that in their country, it would take at least 5 years, while others claim it would take the term of a president to complete half of the project, leaving the other half to the next president. From this perspective, China's efficiency is truly remarkable. Meanwhile, a professor from the United States, upon hearing the news that China had completed the construction and opening of the bridge in just 43 hours, exclaimed in disbelief, completely unable to understand the construction efficiency of Chinese engineering.
China has actually soared. It's meteoric. Former Czech President Václav Havel, I think, put it best. He said, all this has happened so fast, we haven't yet had time to be astonished. To remind myself how astonished I should be, I occasionally look out the window in my office in Cambridge at this bridge which goes across the Charles River between the Kennedy School and Harvard Business School. In 2012, the state of Massachusetts said they were going to renovate this bridge. It would take 2 years. In 2014, they said it wasn't finished. In 2015, they said it would take 1 more year. In 2015, they said it's not finished. We're not going to tell you when it's going to be finished. Finally, last year it was finished 3 times over budget. Now, compare this to a similar bridge that I drove across last month in Beijing. It's called the Sanyuan Bridge. In 2015, the Chinese decided they wanted to renovate that bridge. It actually has twice as many lanes of traffic. How long did it take for them to complete the project? 2015. What do you bet? Take a guess. Okay. Take a look. The answer is 43 hours. Now, of course, that couldn't happen in New York, yes.
As the first vehicles slowly drove across the new bridge, enthusiastic applause and cheers erupted at the scene. At this moment, all the hard work paid off, and all the efforts turned into this brand new bridge. It is not only a bridge connecting roads, but also a bridge connecting hearts, witnessing the glorious achievements of Beijing's urban construction. In addition, China's unique form of government organization helps concentrate efforts to accomplish great things. However, one thing that absolutely cannot be ignored among these factors is the unparalleled spirit of hard work and endurance that the Chinese people possess. Over the years, China has truly lived up to its reputation as an infrastructure maniac. Let's take a look at some astonishing figures. Among the world's 100 highest bridges, an astounding 81 are located in China, including some projects that are still under construction. The world's longest sea-crossing bridge, the Hong Kong-Zhuhai-Macau Bridge, has been opened to traffic, with a total length of 55 kilometers, hailed as one of the 7 wonders of the modern world. The world's highest bridge, the Beipan River Bridge, spans Guizhou in Yunnan, with its bridge deck reaching 564 meters above the valley floor, equivalent to the height of a 200-story building, breaking the record for the highest bridge deck in the world. The Danyang-Kunshan Grand Bridge from Nanjing to Shanghai Hongqiao is the world's longest bridge, with a total length of 164.851 kilometers, still holding the Guinness World Record to this day. In terms of infrastructure construction, China is also leading the way. The mileage of highways in operation has reached 131,000 kilometers, ranking first in the world. The total operating mileage of high-speed railways exceeds 31,000 kilometers, also ranking first in the world. China has 800,000 highway bridges, 200,000 railway bridges, totaling 1 million bridges, ranking first in the world. The number of communication base stations is as high as over 5 million, more than 20 times that of the United States. The mileage of subway lines in operation is 3,095 kilometers, far exceeding the United States' 1,100 kilometers, also ranking first in the world. As for high-rise buildings, China has 347,000, including over 6,000 super high-rise buildings over 100 meters, far surpassing other countries in quantity. These figures are not only astonishing but also a true reflection of China's infrastructure strength, demonstrating its unparalleled power and achievements in the field of infrastructure. Countless world records, countless proud achievements, behind which are countless ordinary workers, achieving extraordinary, almost pathological, limits through sacrifice. China is a country that is both ancient and young. After thousands of years, today's Chinese people are in the best stage, And this best is achieved through the efforts of all the Chinese people. The greatest characteristic of the Chinese people is their resilience. In Fujian, China, workers completed the construction of a train station in just 9 hours. Wow, this is the speed of China that attracts the world's attention. The renovation project of Longyan Railway Station on the Nansan-Long Railway in Fujian was completed in just 9 hours, thanks to the joint efforts of over 1,500 workers and more than 100 machines. This speed is astonishing and has attracted global attention.
How the Chinese do these things. They were able to build a whole new station in the space of 9 hours by flooding it, thousands of workers. We should be much more imaginative about getting infrastructure in instead of condemning people to being isolated in remote areas.
Nice.
This remarkable construction speed not only reflects the hard work and efficient collaboration of Chinese workers, but also demonstrates China's strong capabilities in infrastructure construction. Elon Musk, the Iron Man of Silicon Valley, also retweeted and praised the speed of China's construction, saying that it is 100 times faster than that of the United States. This is enough to show that the speed of China has become a hot topic worldwide. Americans have to admit that, looking at the world, no country can match China's astonishing speed. All of these prove that the Chinese people are becoming stronger and stronger in building world-class projects. Over the river in Chongqing, a heart-stirring aerial ballet is unfolding. 5 magnificent large-span bridges, resembling 5 graceful dancers, are performing a synchronized rotational movement in the same area and on the same plane. These 5 bridges have a total length of 383.5 meters and a total weight of 21,500 tons, equivalent to the total weight of 15,000 cars. As the bridges begin to slowly rotate, it seems as if the entire sky is moved by their motion. The rotation process resembles a magnificent aerial dance, with the bridges and their reflections on the river surface creating a splendid picture. At this moment, the bridges are not just channels connecting the 2 banks, but a perfect fusion of art and engineering. This aerial ballet of the 5 bridges not only sets a new world record, but also showcases the remarkable achievements of bridge construction in China. It proves our leading position in the construction of large span cluster rotational bridges and highlights our innovative spirit in the field of bridge engineering. The rotational movement of these 5 bridges is not only a technological breakthrough but also a visual feast. Their trajectories in the air, like beautiful arcs, adorn the magnificent scenery of the river in Chongqing. This aerial ballet is not only a triumph of engineering but also an artistic display that leaves us in awe. In beautiful Xiamen, a world-shocking engineering feat has been successfully staged. A passenger terminal weighing 30,000 tons seemed to gain magical powers, shifting a full 288 meters and completing a spectacular 90-degree turn, becoming what people call the most incredible relocation. Imagine such a colossal object, as if alive, changing from facing east to facing north. The magnitude of this transformation is truly astounding. However, through the ingenious design and superb craftsmanship of Chinese engineers, all of this became possible. They utilized the innovative alternating stepwise pushing and lifting technology to create a dreamlike journey for this building's relocation. They cleverly poured concrete between the columns to form trays, lifting the massive building off its original foundation. Then, according to the predetermined shifting route, they carefully excavated pits and laid tracks, allowing the building to move smoothly and steadily on these tracks. 532 walkers were installed at the bottom of the building, as if giving this massive structure feet to walk on. To ensure that the building could reach its destination smoothly and safely, engineers also installed 603 sensors at key positions on the walkers to monitor and provide real-time feedback on their movements. If the pushing force error exceeds 2 millimeters, the system immediately issues an alarm and suspends operation, ensuring the safety and accuracy of the entire relocation process. Under the precise control of the engineers, the building steadily progressed at a speed of 7.5 meters per day. After 38 days of arduous efforts, it finally successfully shifted 288 meters and reached its designated location. This feat was not only certified by the Guinness World Records as the longest arc of overall building translation, but also the world's first long-distance, large-radius building relocation, undoubtedly the most incredible move in history. In the bustling city of Wuhan, a brand new hospital, Huashinshan Hospital, rose from the ground in just 10 days, becoming a crucial fortress in the fight against the epidemic. This is not just a hospital but also a vivid demonstration of China's infrastructure speed, drawing worldwide attention. Similarly, in the following 12 days, Leishanshan Hospital was also completed rapidly, fighting alongside Huashinshan Hospital and contributing to the fight against the epidemic. The construction of these two hospitals not only showcases China's construction strength, but also embodies the tenacious spirit of the Chinese people in the face of difficulties. Faced with the sudden epidemic, the whole nation united as one, with everyone pulling together to fight against it. The rapid construction of Huashinshan and Leishanshan hospitals is a vivid embodiment of this spirit. During the construction process, countless builders worked day and night, overcoming numerous difficulties, and with their sweat and wisdom, they wrote deeply moving anthems of the anti-epidemic struggle. Their hard work has won precious time for the fight against the epidemic and brought a new hope of life to the patients. The so-called construction madmen are just a group of kind and courageous people who, burdened with responsibilities and adversity, put on armors and charge on quietly in everyone's prayers. The completion of these two hospitals not only demonstrates China's infrastructure speed, but also embodies the firm belief and strong will of the Chinese people in fighting the epidemic. They are not only important strongholds in the fight against the epidemic, but also a symbol of the unity of the Chinese people in overcoming difficulties together. They have once again shown the world the speed and strength of China, as well as the firm belief and tenacious spirit of the Chinese people in the face of difficulties. China's bridge construction is truly unparalleled globally. From record-breaking spans to lightning-fast construction speeds, Chinese bridge engineering achievements leave American engineers awestruck. When Britain engineer Jeremy Clarkson first came to China, he was amazed by the country's infrastructure.
China's road network. In 1988, China had no motorways at all. And now, 30 years later, it has 84,000 miles of them. That's more than any other country in the world. And they're only just getting into their stride. Since 2011, they've been building 6,000 miles of motorway every year. 6,000 miles a year! It beggars belief, and it's not like the terrain is easy. Here, though, there ain't no mountain high enough, and there ain't no valley low enough to stop them. This bridge, for example, is 34 miles long. And then there's this one, the Gorges-Dam Bridge. You could fit the London Shard underneath it, twice over. I'm telling you, in Britain, we're doomed.
Bridges, as the crystallization of human wisdom, have been vividly displayed in China. From the ancient Zhaozhou Bridge to the modern Kong-Zhuhai-Macau Bridge, China's bridge construction technology has been at the forefront of the world. Each bridge is an epic, recording the hard work and creative wisdom of the Chinese people. From the ancient Zhaozhou Bridge, with its unique arch structure and exquisite stone carving art, showing the wisdom and ingenuity of the ancients, to the modern Kong-Zhuhai-Macau Bridge, with its huge scale, complex technology, and innovative concept, it has become a miracle in the history of world bridges. This bridge not only connects Hong Kong, Macau, and Zhuhai, but also demonstrates China's leading position in modern bridge construction. The Hong Kong-Zhuhai-Macau Bridge travels across the sea. It gradually descends into the water, and at the terminus where it submerges, 33 giant tunnel tubes were sunk sequentially to the seabed to form a 6.7 kilometers long undersea tunnel. The tunnel not only leaves sufficient space on the sea surface, but also greatly reduces the structure's impact on sea currents. The two flanking artificial islands ensured a seamless transition between the undersea tunnel and connecting bridges. With such combination, the longest sea-crossing bridge in the world literally paves a path across the vast sea. Besides, the Shenzhen-Zhongshan Bridge under construction is also a great miracle in the history of bridge construction in China. The Shenzhen-Zhongshan Bridge connects Shenzhen and Zhongshan City in Guangdong Province, where the 270-meter-high bridge tower supports the Lingdingyang Bridge with a span of up to 1666 meters, becoming the bridge with the largest span in China's sea area. China's bridge construction technology is truly amazing, especially in complex terrain conditions, such as high mountains and deep sea currents. Chinese bridge engineers have created one miracle after another with exquisite technology and unremitting efforts. They have not only solved technical problems but also demonstrated to the world the grandeur and magnificence of Chinese bridges. So far, China has more impressive bridges than any other country. But have you ever thought that each bridge has its own unique story? The Beipan River Bridge. The Beipan River Bridge is located at the junction of Yunnan and Guizhou provinces and is one of the highest bridges in the world, with a height of 565 meters from the bridge deck to the river surface, equivalent to the height of a 200-story building. However, this bridge has been labeled as a knockoff by American media. Some American experts publicly questioned and ridiculed the construction speed of this bridge, believing that China could not have built such a spectacular project solely on its own efforts and must have copied American designs and methods. This kind of statement not only lacks understanding of China's construction level and innovation ability but also carries a sense of disdain. China's development is truly amazing. Most Americans don't have a clue what it is like over there. The USA should be inspired by China and seek to learn from them rather than demonize them and make them America's enemy. China is a great example of hard work and dedication, which used to be American values. China is also a great example of what is possible when government focuses its resources in the best interests of its people, rather than focusing resources on going to war with the rest of the world. So, is the Beipan River Bridge really like that? Does China really not have the ability to build such a bridge? Let's uncover the truth together. China has a long history and rich experience in bridge construction, achieving many independent design and technological achievements. China is the hometown of bridges, with the largest number of bridges in the world and a vast scale. Bridge construction is an important support for China's economic development and the essence of China's engineering technology. Americans were once unwilling to believe that in their eyes still backward China, they could build such amazing bridges in just 3 years. The results of the expert group's on-site inspection exceeded their imagination. China not only completed the construction of this bridge in 3 years, but also broke several world records. The Beipan River Bridge, with a total length of 1,341.1 meters and built to a dual carriageway standard, was designed for a speed of 80 kilometers per hour and cost 1 billion yuan. It was constructed using a variety of advanced technologies, giving it a strong sense of science and technology. Since its completion, the bridge has not only optimized the transportation environment between the two locations but also ended the history of no high-speed access between Shanwei and Zhuhaicheng. However, before the construction of this bridge, due to the complex terrain and harsh climate in the Beipan River area, combined with the fact that the Yunnan-Guizhou Plateau is a mountainous region with rough roads, residents on both sides could only rely on walking to travel between the two locations, leading to very backward economic development. To improve this situation, China decided to build a bridge across the canyon between the two locations. From then on, the Beipan River Bridge began to take shape. However, in the early stages of the project, it sparked many doubts and ridicule internationally. This was also due to the extremely harsh environment at the junction of the two provinces, with many caves and a high degree of construction difficulty and danger. At the same time, the distance from the bridge deck to the river surface is 565.4 meters, equivalent to the height of a 200-story building, higher than the highest Millau viaduct in France by nearly 100 meters. For China, this was undoubtedly a new challenge. Faced with these world-class challenges, how did China overcome them one by one? First, the location of the bridge is in a karst landform, and the 10 kilometers of mountains along the river are densely packed with limestone, with very poor hardness, unable to bear the weight of the bridge, so the bridge deck had to be raised. However, it is easy to have collapses of caves during construction, which greatly affects the construction. To ensure the stability of the bridge, Chinese engineers initially planned to build a suspension bridge, but transporting a large amount of materials faced difficulties. Therefore, the technical team overturned this idea and adopted a method of connecting the bridge deck by supporting steel cables through bridge piers, which is also called a cable-stayed bridge, and then pulling up the bridge deck with steel cables. The Beipan River Bridge used a total of 244 steel cables with a diameter of only 5.1 millimeters, with a tensile strength exceeding 1860 megapascals, far exceeding international standards. After solving this problem, a new challenge arose, namely the anchoring problem. Regardless of the type of suspension bridge built, it will use the core component of anchoring, which is equivalent to the main beam of the suspension bridge. If the Beipan River Bridge also uses this component, it would be necessary to fill the caves in the mountain and build a concrete anchoring area of over 10,000 square meters on both sides of the bridge, but doing so would greatly damage the balance of the mountain. To avoid damaging the mountain and still be able to build the suspension bridge, experts proposed a bold new approach, which was to let the Beipan River Bridge adopt the design of auxiliary bridge piers, with the bridge piers on both sides as the fulcrum. However, this design brought new challenges to the height of the bridge. Even with innovative design, the bridge deck is still nearly 100 meters above the ground. At 2,461 feet, the spire is taller than the two Eiffel Towers and the Statue of Liberty combined. And the bridge deck has to bear more than 52,310 tons, which is equivalent to the weight of 5 Titanic ships combined. As a result, the bridge piers not only have to play a supporting role but also have to withstand the huge frictional force generated by the horizontal movement of the steel truss, which is extremely difficult to achieve. After many discussions, Chinese engineers decided to abandon this approach and adopted the method of longitudinal splicing and conducted multiple computer simulations to ensure the safety of this plan. When connecting the steel beams with bolts, the construction team made a decision that broke with tradition, using plastic bolts. This move was also met with many doubts, but it proved to be a far-sighted decision. After many comparisons and tests, Chinese engineers found that plastic bolts were superior to iron bolts in terms of wear resistance and rust resistance, greatly improving the wind and earthquake resistance of the bridge and extending its service life. It can be said that this small piece of plastic not only solved the 300 billion project problems overseas, but also reduced the later maintenance costs. The Beipan River Bridge also used a large number of black technologies, using the latest scientific research results, conducting simulation analysis through computers, and conducting preliminary demonstration through 3D modeling. After 3 years, the Beipan River Bridge was completed in 2015 and opened to traffic smoothly. In 2018, it won the Nobel Prize at the 35th National Bridge Conference and was awarded the title of the world's tallest bridge, the Siju Bridge. The Siju Bridge is a magnificent cable-stayed bridge that has become the focus of attention worldwide due to its unique construction method. In the history of bridge construction, it was the first time that rocket technology was used to transport the lead steel cables, completing this unprecedented feat. The 2 heavy-duty steel cables of this bridge, like 2 giant dragons, lie above the gorge, woven from tens of thousands of tons of high-strength steel wires, incredibly sturdy, firmly fixed on the bridge piers on both sides. These steel cables hang down from the main cables, connecting the bridge deck like countless lifelines, carrying vehicles and pedestrians back and forth, ensuring their safe passage. However, during the construction of this bridge, engineers faced enormous challenges. Before laying the main cables, a lead steel cable had to be sent to the opposite side of the gorge. This task seemed simple but was actually extremely difficult. The span of the Siju Bridge reaches over 1,000 meters, and the gorges on both sides are steep and rugged, making ground transportation impossible. At the same time, due to the complex terrain of the gorge and the strong wind, helicopters were also unable to safely transport the lead steel cables from the air. Faced with this problem, Chinese engineers did not back down. After careful consideration, they finally came up with a bold and innovative solution, using rockets to transport the lead steel cables. This idea may sound incredible, but with the ingenious ideas and bold innovations of Chinese engineers, it became a reality. Engineers contacted nearby military units and obtained a military rocket. Then, they replaced the explosive cord with the lead steel cable, and after careful planning and preparation, the rocket successfully delivered the lead steel cable to the opposite side of the gorge. This innovative solution not only solved a major problem in the construction of the bridge, but also fully demonstrated the wisdom and innovative ability of Chinese engineers. The construction of the Subsea Bridge is the result of the ingenious ideas and bold innovations of Chinese engineers, which has had a huge impact internationally. Many international bridge experts have said that they had never thought of using rocket technology to build a bridge before. This bridge is not only a transportation hub connecting both sides, but also a symbol of the wisdom and innovation of Chinese engineers. It showcases China's leading position and strong capabilities in the field of bridge construction to the world, and provides valuable experience and insights for future bridge construction. The construction of the Subsea Bridge not only demonstrates the outstanding innovative ability of Chinese engineers, but also brings a revolutionary solution to the global bridge construction field. Although Chinese engineers have made this technology public, due to its high requirements and difficulty, no other bridge worldwide has yet been constructed using the same technology. This has allowed the Subsea Bridge to maintain its status as the only bridge in the world built using rocket technology. This achievement has not only won international reputation for Chinese engineers, but also made Western countries, which once underestimated Chinese technology, take notice. They have to admit that China's innovative strength has taken the lead in the world. As a brilliant pearl of scientific and technological innovation, the bridge has established a new image for China on the global stage, showcasing its increasingly strong national and technological capabilities. First, let's go back over 100 years to China's landscape of fragmented mountains and poor transportation. However, after more than a century of development, today's China has risen like an awakened Oriental lion. In this lengthy historical process, what transformations has China undergone? And how has it gradually accomplished unprecedented landscape changes on Chinese soil? This video will provide detailed answers to these questions. Before delving into the discussion, let's first re-examine the geographical landscape of China. You may already know that China extends greatly from north to south and is vast from east to west, covering a land area of 9.6 million square kilometers, making it one of the countries with the richest natural resources globally. However, on the flip side, China's terrain is complex, with mountains and hills occupying over 60% of the land area. More notably, after thousands of years of development, by the time of the founding of the new China, the forest coverage had fallen below 9%, and issues of land desertification and salinization were becoming increasingly severe. American experts couldn't help but marvel at the severe degradation of the natural environment in this country, facing serious challenges of transportation obstacles, uneven resource distribution, environmental deterioration, and fragmented landscapes. So, what measures should China take to change its destiny? One crucial step is to build bridges, spanning large rivers, high mountains, and straits, cleverly connecting this vast country into a unified whole. 100 years ago in China, there was only a railway spanning approximately 9.3 kilometers, a steel bridge with a main span of 62 meters, and a tunnel measuring 261 meters in length. It wasn't until 1937, with the completion of the Hangzhou-Qiantang River Bridge, that the Chinese people had their first domestically designed and built dual-use road and rail bridge. In the following less than 4 years, the construction of the Wuhan-Yangtze River Bridge allowed the Chinese to successfully traverse the Yangtze River for the first time. Despite the withdrawal of all Soviet experts, the young generation of Chinese bridge engineers overcame numerous challenges to successfully design and construct the Nanjing-Yangtze River Bridge. Thus, the railways that had faced each other across the Yangtze for decades finally merged into one, giving birth to the Jingguang and Jinghu, the two major channels. However, the single-span lengths of these bridges were still limited and couldn't adapt to more complex terrain conditions. It wasn't until 1991, with the completion of the Shanghai-Nanpu Bridge, that the Chinese people truly embarked on the pioneering path of independently constructing large-span bridges. Subsequently, China's bridges became more diverse and grandiose, not only spanning the Yangtze River with a single span but also soaring directly over gorges at an elevation of 565.4 meters above the valley floor. At the same time, China has made significant progress in tunnel engineering. It took China nearly a century to complete the construction of its first 10,000-meter tunnel. Over the subsequent 2 decades, significant breakthroughs were achieved, with tunnels extending to lengths of 20,000 meters and even 30,000 meters. Such engineering accomplishments have left American engineers profoundly astonished. The former Qinghai-Tibet Railway required a climb of 600 meters, taking 2 hours to circumvent the Guanjiao Mountains. Today, with an ultra-long tunnel stretching 32,690 meters, it only takes 20 minutes to directly traverse the Guanjiao Mountains. It is through these tens of thousands of tunnels and millions of bridges that the Chinese people can easily traverse mountains and rivers. Chinese engineers have connected railways and roads to every county and village in China, thus building the world's largest highway network and high-speed railway network. Today, China's transportation network covers the entire country, efficiently delivering 1.76 billion passenger trips and 46.2 billion tons of goods annually to every corner of the vast Chinese territory. However, behind these staggering numbers lies a massive restructuring of population and resources. A century ago, China's population was approximately 400 million, but today it exceeds 1.4 billion, surpassing the total of all developed countries worldwide. Accompanying this demographic shift, China has undergone the largest urbanization process on the planet. Currently, China has 6 urban areas with a resident population exceeding 10 million, 10 super cities with over 5 million residents, and 77 large cities with populations surpassing 1 million. These cities are poised to become representatives of future global urban civilization development. Over 2,000 years ago, this suspended plank road clinging to cliffs was one of the crucial passageways in Sichuan. However, not far away, a high-speed train with a speed of up to 250 kilometers per hour shuttles through the Qinling Mountains, connecting Xi'an and Chengdu. Heading south, the Beijing-Kunming Expressway, with the help of towering super bridges reaching a height of 100 meters, ascends to the Yungui Plateau, linking Chengdu and Kunming. Turning westward, the 2 Sichuan-Tibet highways traverse the Henduan Mountains, making the Qinghai-Tibet Plateau no longer inaccessible. The roads connecting Sichuan form a powerful modern mega-bridge network in China. So, how did China overcome numerous obstacles to create these super bridges? And what have they brought to China? To find answers to these questions, we first come to a super mountain range that separates North and South China with the strength of a mountain, Qinling. This mountain range, like a giant dragon, sprawls across the Chinese landscape. With a wide and thick body and continuous mountain ranges, it narrows to nearly 100 kilometers at its narrowest point in the north-south direction. Coupled with towering ridges, Qinling has become an insurmountable barrier between the Sichuan Basin and the Guangzhou Plain. The Baoqing Railway is the first railway that crosses the Qinling, connecting Baoji and Chengdu. However, to traverse this mountain, the train must ascend over 800 meters within a straight-line distance of 25 kilometers, and the slope will exceed the safety limit for train operation. To mitigate the slope, the railway winds in multiple layers, effectively extending the straight-line distance to over 40 kilometers, significantly reducing the difficulty of the train's ascent and forming this winding mountain railway. However, frequent curves significantly slow down the train, and the average speed here is only about 30 kilometers per hour. If faster travel is desired, the only option is to cross the Qinling Mountains. With the continuous advancement of engineering and construction technology in China, trains no longer need to detour around wide and thick mountains but can directly traverse through extremely long tunnels, thereby piercing through the mountains completely. In this way, you will see an almost perfectly straight road cutting through the mountains, allowing high-speed trains, reaching up to 250 kilometers per hour, to smoothly pass through. This is the Xiqing High-Speed Railway. However, what enables it to smoothly traverse the mountains is not just a single tunnel but a group of super tunnels consisting of a series of ultra-long tunnels. This includes 6 special tunnels, each exceeding 10 kilometers in length. In total, 20 tunnels form the Qinling Tunnel Group, covering a length of 126 kilometers. This means that 94% of the entire Qinling railway line runs through tunnels. With the assistance of this series of tunnels, the travel time from Xi'an to Chengdu has been reduced from the original 11 hours to just 3 hours. In this way, China has successfully connected the Northern Passage through the Super Tunnel, enabling Sichuan to be directly linked to the national high-speed rail network for the first time. However, breaking through in just one direction is far from enough. China needs to continue southward, heading towards the Yunnan-Guizhou Plateau with an average elevation of over 4,000 meters. Compared to the low-lying Sichuan Basin, the Yunnan-Guizhou Plateau has a higher average elevation, with a drop of up to 2,000 meters between the two regions. To enter this area, any road must continuously climb. For example, the Chengdu-Kunming Railway, completed in 1970, faced skepticism from Soviet experts who asserted that the Chinese couldn't construct a road in such harsh terrain. However, Chinese engineers, relying on talent and a spirit of hard work, successfully opened up the legendary road to the plateau within a few years. Today, another superhighway along the Chengdu-Kunming Railway requires only about 11 hours for cars to travel from Chengdu to Kunming, which is 8 hours faster than regular trains. This is the Beijing-Kunming Expressway. However, to ascend to the plateau, the Beijing-Kunming Expressway also faces the challenge of climbing, especially in the segment from Yin to Xichang, where there is a continuous ascent of 51 kilometers. As a high-speed highway designed for a speed of 80 kilometers per hour, such long and steep slopes significantly increase the risk of driving. To reduce the slope, Chinese engineers employed a method of ascending in 2 continuous spirals in place, cleverly bypassing sections with harsh geological conditions and building a pair of unique double spiral tunnels in the mountains. However, between these 2 tunnels is not flat ground but a deep mountain valley, meaning the power of bridges is needed. Thus, towering bridges come into play, with the highest bridge deck towering over 100 meters above the ground, making driving on it feel like flying in the air. This is the Yashi Expressway before us, resembling a thrilling roller coaster. The towering bridge piers use a specially designed steel tube concrete structure, not only reducing weight but also exhibiting excellent seismic performance. On this unique mountain road composed of bridges and tunnels, cars can climb over 1,000 meters in less than 20 minutes, with a gentle slope throughout the journey, almost feeling like driving on flat ground. With the completion of projects such as the Labajan Bridge, Nabashan Tunnel, and Guanyin-Dada River Bridge, the most challenging section of the Beijing-Kunming Expressway is finally finished. From now on, The mountains in the Sichuan Basin have become a passage connecting the north and south. However, on the other side, the land appears barren. To this day, there is no railroad passing through, and this is the essential route to the Qinghai Tibet Plateau. Here, people must face towering mountains and deep valleys, and layer upon layer of the Henduan Mountains. However, constructing a road from Sichuan to Tibet poses a hellish challenge. Arriving in this mystical land requires crossing not ordinary mountain ranges but the world's most densely packed Henduan mountain region, formed by 7 mountain ranges and 6 major rivers. Moreover, the plateau to traverse is not an ordinary one but the Qinghai Tibet Plateau with an average elevation exceeding 4,000 meters. This implies that to build this road, a combination of more powerful super tunnels and mega bridges is necessary. This is a 13.4-kilometer long highway tunnel. During its construction, the tunnel needed to cross 13 fault zones. As a result, construction workers could only advance 3.6 meters per day on average, taking 5 years to complete. In comparison, the longest tunnel in the high-speed railway tunnel group in the Qinling Mountains averages a daily progress of 13 meters. After the tunnel was completed, Chinese engineers faced the barrier of a surging river, the Dada River. Today, a new bridge has been erected upstream of the Luting Bridge. To connect the road and bridge deck, engineers must construct a span of 1,100 meters at a height of over 200 meters above the river surface. This span, 11 times longer than that of the Luting Bridge, is known as the Luting Dada River Bridge. As a suspension bridge, the Luting Dada River Bridge primarily relies on the 2 main cables on the left and right to bear the weight of the entire structure. How did engineers achieve this feat? The answer becomes apparent when we turn our gaze to the shore. On the side of the bridge, the main cables are anchored by a massive concrete structure, known as the gravity anchor, weighing as much as 230,000 tons, firmly securing the main cables. However, on the other side, where the mountain is steep, there is not enough space to accommodate such a massive gravity anchor. Therefore, engineers had to choose to excavate a tunnel inside the mountain, measuring 159 meters in length, turning the anchor into a giant expanding screw, and securing the main cables firmly within the mountain. This is now the world's longest tunnel anchor. With the support of a special structure, including a central buckle, the Luting Dada River Bridge is not only capable of withstanding crosswinds equivalent to a Category 12 typhoon in the valley, but also remains intact even during a powerful earthquake measuring up to magnitude 6. The clever integration of super tunnels and mega bridges continually upgrades the road to Tibet. Simultaneously, the travel time from Chengdu to Kongding has been reduced from 2 days to just over 3 hours. However, this is only the first challenge on the journey. Continuing westward, one faces mountain ranges with altitudes exceeding 5,000 meters. The terrain is rugged, and the environment harsh, with nearly vertical river cliffs. Building roads in such conditions is unbelievably challenging. The ongoing construction of the Sichuan-Tibet Railway is expected to take over a decade to fully traverse the Henduan Mountains. However, once completed, it will become an engineering marvel that will astonish the world. Additionally, as the Shanghai-Chongqing High-Speed Railway, Chengdu-Chongqing Expressway, and other passageways connect the eastern regions of the Yangtze River, Sichuan's links with the middle and lower reaches of the Yangtze River have become unimpeded. Nowadays, China has mega bridges, and the continuous mountain ranges are no longer insurmountable obstacles. The basins are no longer isolated islands separated by numerous barriers. China's capability to construct mega bridges in such challenging environments signals its readiness to embark on future endeavors, spanning across more mountain ranges, plateaus, and every location in need of connectivity for the development of additional expressways. This could imply the construction of more super tunnels and bridges, connecting every city, village, and corner of this land. On the map of China, bridges are scattered across the country like veins. Currently, there are over 960,000 various types of road bridges in China, and nearly half of the extensive 40,000-kilometer high-speed rail network consists of concrete bridges. These bridges span high mountains and rivers, connecting towns and villages, making China the bridge capital of the world. China's remarkable strength in bridge construction has led many to believe that China is now a developed country. That's right. When it comes to modern bridges in China today, both in terms of quantity and quality, they are at the forefront of the world. However, do you know why China is building so many mega bridges? In the upcoming video, we will take you on a journey to trace the history of bridge construction in China. First, we will begin with the most classic type of bridge. This is an ancient bridge design, where two piers support one beam, considered a beam bridge. The horizontal distance between the centers of adjacent supports represents the span, reflecting the bridging capacity of a bridge. What you see before you is the first modern bridge independently designed and constructed by China in 1937, the Hangzhou-Qiantang River Bridge. It has a maximum span of approximately 66 meters and adopts the structure of a simply supported beam bridge, supporting a box girder between adjacent piers. Extending the girder to form a multiple tons supporting one beam constitutes a continuous beam bridge. Due to the continuous and uninterrupted nature of the girder, it can mutually constrain, providing higher load-bearing capacity and achieving larger bridge spans. For example, the Wuhan Yangtze River Bridge has a maximum span of 128 meters. This design enabled the Chinese to successfully cross the natural barrier of the Yangtze River for the first time. In China at that time, these steel bridges were not only technologically advanced but also expensive, mainly applicable to railway construction. With the introduction of a new bridge construction technology, Chinese engineers could easily span bridges across the Yangtze River. The principle of this technology is quite ingenious. Pre-stressing steel bars are embedded in the concrete, utilizing the shrinkage of the steel bars to balance external forces. This allows the bridge structure to withstand larger loads and support greater spans. This technology is known as pre-stressed concrete technology and is more cost-effective compared to traditional steel-reinforced concrete technology. Therefore, propelled by pre-stressed technology, a large number of highway bridges were constructed by Chinese engineers. Until today, the application of beam bridges has become very extensive, forming standard components that can be manufactured in factories and assembled on site. While there are limitations to single-span lengths, by connecting hundreds or thousands of spans, it's possible to span rivers, lakes, seas, and even reach lengths of up to 165 kilometers, completely surpassing road surfaces, making them the world's longest bridges. However, to further increase spans, beam bridges inevitably need to undergo a technological revolution. The appearance of this bridge is very similar to a beam bridge, but its girder and piers are fixed as a whole, allowing them to jointly resist girder bending. This means that with the support of piers, girders can achieve greater spans or choose a more lightweight bridge deck, which is the rigid frame bridge. However, this type of bridge is very sensitive to thermal expansion and contraction, making it prone to bridge deformation or even collapse. To address this challenge, Chinese engineers designed higher piers for cable-stayed bridges, making them more flexible and reducing the risk of pier deformation. In mountainous and canyon areas, this design with tall piers is particularly suitable. So, a towering bridge soared into the sky. This large bridge is called the Hejang Mega Bridge, with its piers plunging straight into the valley, reaching an astonishing height of 190 meters, equivalent to more than 60 stories. It is the tallest bridge pier in Asia. However, on the plains, there is no need to construct towering piers. To reduce the height of the bridge while ensuring the flexibility of the piers, a special pier form is required. However, the piers need to be slender, the bridge needs to be stable, and the cost needs to be low. These three factors constrain each other, making cable-stayed bridges with spans exceeding 300 meters rare. The Qishui River Bridge, completed in 2006 with a maximum span of 330 meters, became the world's largest pre-stressed concrete continuous steel truss bridge. But when facing steep cliffs, deep valleys, or the need for traffic clearance under the bridge, a bridge form that can span the entire distance with a single span is required, such as an arch bridge. This arch structure requires both ends to not only lift the bridge upward but also provide powerful horizontal thrust. This thrust firmly resists the deformation of the arch, thereby increasing the arch bridge's spanning ability. For example, the truss arch bridge, pioneered by China, has slender concrete arches, making the bridge more lightweight, with a maximum span of 330 meters. As ordinary concrete arch bridges approach their span limits, more and more innovative arch bridges are emerging. For instance, filling concrete in steel tubes adds an extra protective layer, making it more robust than regular concrete. Additionally, steel tubes can serve as the construction framework, significantly reducing the construction difficulty of arch bridges. With the increase in China's steel production, steel arch bridges are also on the rise. Combined with trusses, steel structures, and other designs, they have created one engineering marvel after another. Nowadays, the arch bridges constructed by Chinese engineers have achieved astonishing spans of over 600 meters. What's more, China also plans to build an extra-large bridge with a span exceeding 1,000 meters shortly. Now, you are looking at the Wufingshan Yangtze River Bridge. Let us marvel together at its grandeur. The main cables of this bridge are made of high-strength steel wires with a diameter of 5.5 millimeters, forming bundles of 127 wires each, and 352 bundles create a design with dual parallel cables. These main cables not only serve as the support for the bridge but also represent a colossal engineering marvel. They bear the weight of steel beams exceeding 70,000 tons, equivalent to 1,000 fully loaded Boeing 747 airplanes. Faced with such an enormous load-bearing capacity, the flow of traffic on the bridge appears insignificant in the face of this colossal engineering feat. Let's go back to the ongoing construction of the world's longest cross-sea bridge in China, the Shenzhen-Zhongshan Channel. This large-scale project, following the Hong Kong-Zhuhai-Macau Bridge, is another world-shocking cross-sea cluster engineering feat. From the initiation of construction, it has faced one global challenge after another. Here, we will focus on the underwater tunnel formed by 32 sections of bidirectional 8-lane steel shell concrete caissons, and the length of this underwater tunnel is an astounding 6.8 kilometers. Its construction difficulty is considered unparalleled in the world. However, Chinese engineers always find ingenious solutions using their intelligence. The enormous transport ship you see now is the Yihang Jinan 1, an integrated installation ship designed and manufactured by Chinese engineers. The main body of Yihang Jinan 1 adopts a catamaran ship design, integrating functions such as caisson floating, positioning, sinking, and installation. With a length of 190.4 meters, width of 75 meters, and depth of 14.7 meters, it is the world's most advanced underwater tunnel caisson construction vessel with the largest installation capacity, highest precision in sinking, most efficient construction operations, and cutting-edge performance. Now it will depart from Guoliang Island, transporting caissons weighing up to 80,000 tons to the construction site of the Caisson Tunnel 50 kilometers away. This will be an epic construction operation, and the Caisson transport and installation ship will carry out mooring, hoisting, positioning, and other tasks. At a depth of over 30 meters underwater, achieving millimeter-level precision docking for the 80,000-ton caisson is as challenging as the docking of crewed spacecraft and the Tiangong space station. The caisson transport and installation ship Hang Jinan 1 acts like a massive rectangular steel clamp, firmly holding the final section of the caisson and the ultimate joint at the bottom of the ship. Controlled by the intelligent system installed on the ship, the final joint is precisely pushed out, achieving the precise docking of the last caisson with the E-24 section on the east side. From this point on, the world's longest and widest steel shell concrete caisson tunnel, the Shenzhen-Zhongshan Channel Underwater Tunnel, is officially connected. The construction of the Shenzhen-Zhongshan Channel Caisson Tunnel embodies the collective wisdom of the Chinese engineering team, showcasing a leap in China's overall industrial technological capabilities. When you think of the world's most famous bridges, images of San Francisco's Golden Gate Bridge, St. Petersburg's Sunshine Skyway Bridge, and London's Tower Bridge might come to mind. However, countless other massive bridges surpass these in scale, innovation, and ambition, many of which are in China, an Asian superpower renowned for large-scale engineering. What makes these bridges iconic and record-breaking structures? How much does it cost to build these gigantic bridges? How do they connect people and impact China's economy? In this video, we'll take you on a tour of China's most iconic and breathtaking engineering marvels that leave American engineers in awe. We'll also show you the numerous innovations that made these grand projects possible in record time. Additionally, you'll learn about the actual costs of constructing these bridges. Bridges are structures that help us cross valleys, bodies of water, and rugged terrains. Since ancient civilizations, humans have been building bridges using simple, readily available materials like stone, wood, and mud. However, as our knowledge of materials and structures grew, we invented mortar to build stronger, more powerful, and more flexible bridges. In fact, ancient Roman engineers ground volcanic rock to use as material for making mortar. As bridge engineering evolved, the Romans discovered ways to use arches in construction, enabling bridges to bear double the weight. They also built aqueducts that reached astonishing heights. Using this discovery, the Romans constructed cheaper, stronger, and faster bridges that spanned rivers, facilitating transportation for city dwellers. The Arcadian Bridge in the Peloponnese of Greece is said to be the oldest surviving arch bridge, once serving as a military road between two cities and capable of bearing the weight of chariots. Built between 1300 and 1190 BCE from meticulously arranged stones, this bridge remains intact and passable to this day. Fast forward to modern times, and you will see a variety of materials used in bridge construction, such as concrete, iron, and steel cables, allowing bridges to span unimaginable lengths. Today, we have various types of bridges, including suspension bridges, cable-stayed bridges, and underwater tunnels, things ancient engineers couldn't have imagined. Undoubtedly, the United States has some of the world's most impressive architectural feats, including bridges that span oceans, lands, and rugged terrains, setting records and showcasing the growth of the U.S. materials and infrastructure research industry. However, recently, China seems to have stolen the spotlight. Infrastructure investment is a key priority for China, making it the go-to infrastructure partner in developing African countries. Besides bridges, China excels at creating engineering marvels, from the ancient Great Wall to the Donghai Bridge in Shanghai, and the uniquely designed CCTV headquarters in Beijing. Although designed by Dutch architect Rem Koolhaas, the unique ring structure of the CCTV building connects horizontal and vertical sections in a continuous loop. This building, costing $735 million, stands as one of Beijing's iconic structures. Other magnificent Chinese buildings and engineering projects include Beijing Daxing International Airport, designed by Zaha Hadid, with its streamlined design, natural light, and arched roofs. As China prepares to surpass the US as the world's largest aviation market, Beijing Daxing Airport stands as a symbolic gateway. Another iconic project showcasing China's engineering prowess is the Liang Museum in Jiangsu Province, which integrates local culture with modern structural methods to create an organic building. The Harbin Opera House, opened in 2015, appears to be sculpted by wind and water, designed to house the city's 100-year-old symphony orchestra and featuring 2 theaters accommodating up to 2,000 people. The exterior is iconic white, echoing the spirit of the northern cold climate, with an asymmetric design that impresses with its curves, use of materials, and integration with the surroundings. Beginning with the Deng Xiaoping era in the late 1970s, China has invested heavily in highways, railways, ports, airports, communication, and energy systems, driving rapid industrialization, urbanization, and economic growth in the 1980s and 1990s. China has invested billions domestically and internationally, enabling it to establish connections with neighboring allies and spur national economic growth. This drive has allowed China, with its 1.4 billion population, to invest in complex engineering marvels that astonish the world. The first Chinese megabridge we study is the Qishui River Bridge. This bridge, towering 350 meters, spans the Qishui River and is a double-tower, single-span steel girder suspension bridge connecting the highways of Jiangxi in Guizhou and Sichuan. Estimated to cost over $250 million, the construction process was extremely challenging, with a total length of 2,009 meters. The Qishui River Bridge uses a tunnel anchoring system on the Sichuan side and a gravity anchoring system on the Guizhou side, making it the highest mountain bridge tower and the second longest span suspension bridge in the world. Due to the harsh mountainous conditions, heavy equipment couldn't be used, so the team had to build the main bridge deck off-site and then transport it to the location. The main bridge deck is fixed with 158 cables, ensuring it withstands wind and other load factors. Despite the extreme construction conditions, the Qishui River Bridge was completed 19 months ahead of schedule and saved over $2 million on the budget. The designers significantly reduced overall costs by reducing the bridge tower foundation by 30% and related earthworks, showcasing China's leading position in optimizing processes, resource allocation, and material innovation. Next, we introduce the Hejiang Bridge, located in northwest Guizhou Province. This bridge, with a central pile 195 meters high from the base camp, is the 4th highest bridge in the world, second only to the Millau Viaduct in France and the San Marcos Bridge in Mexico. Next, we introduce the Wufingshan Yangtze River Bridge, the world's first high-speed railway suspension bridge. This double-deck suspension bridge supports a high-speed railway and the Yangtze River Highway, with a total length of 6,409 meters and a main span of 1,992 meters, sharing the record for the world's longest high-speed railway bridge with the Hedong Yangtze River Bridge, also in China. The Chinese government initiated this project in the 1960s to provide ultra-fast and ultra-efficient transportation. However, construction technology at that time was not mature. Nevertheless, construction began in 2015, and it opened to traffic in December 2020. This high-speed railway reduces travel time between Shanghai and Lianyungang from 11 hours to 3 hours, making it one of the most efficient high-speed railways in the world. This is China's first suspension bridge combining railways and highways, revolutionizing the possibilities of bridge engineering. To achieve this, engineers used a new type of steel truss girder and adopted a full penetration welding method to connect the U-shaped girders and the upper bridge deck. The upper deck of the Wufingshan Yangtze River Bridge has 8 lanes, and the lower deck has 4 lanes of railway, with speeds up to 155 kilometers per hour. The bridge, designed by the China Railway Major Bridge Reconnaissance and Design Institute, is the highest load, longest span, and fastest bridge of its kind. The bridge is equipped with dampers and cables to reduce wind-induced deformation. The anchoring system of the bridge is one of the largest ever built, with each main cable containing about 352 steel wires, with a total diameter of 51 inches. This bridge demonstrates Chinese engineers' ability to continuously break records. Another stunning bridge is the Liujiang Bridge, located in the treacherous mountainous area of Yunnan Province. The Liujiang Bridge is the world's first single-span, single-tower suspension bridge, which opened in April 2022. This bridge spans 798 meters, and despite being in a remote province of China, the government still built an engineering marvel that defies gravity. This bridge is supported by a tower on one side and anchored by cables at both ends, making for a spectacular sight. The bridge has received praise for providing a scenic travel experience. This two-lane bridge plays an important role in maximizing tourism and economic growth. These are just some examples. China has many similar engineering marvels. Undeniably, China continuously pushes the boundaries of engineering, building breathtaking infrastructure in the most challenging terrains. The Chinese bridge engineering we see today not only showcases its technological innovation, design, and construction efficiency, but also demonstrates its economic and social benefits. These bridges connect cities and communities, promoting economic development and improving people's lives. Many people found it hard to believe that China could achieve such a feat. So, just how strong is China's infrastructure capability? Let's dive into some examples. China is the only country in the world that provides electricity to every household among its 1.4 billion population. It has the largest coverage of power grids in the world, with 9.96 million communication base stations, ranking first globally. China also has over 1 million highway and railway bridges, ranking first in the world. Its high-speed rail network spans a total of 31,000 kilometers, ranking first globally, while its expressway network covers 131,000 kilometers, also ranking first in the world. It's worth mentioning that China's first expressway, the Shenyang-Dalian Expressway, was officially opened in 1988. Can you believe that within just over 30 years, China went from zero to becoming the global leader? It's like they hit the fast-forward button on development. Here's a fun fact. China consumed as much cement in 3 years as the United States did in nearly a century. That's how rapid changes have become the norm in China. However, if we want to talk about China's ability as an infrastructure maniac, we have to thank the United States for teaching China a valuable lesson. Back in the early days of China's founding, infrastructure wasn't exactly a top priority. After all, they had just emerged from a century of humiliation and were focused on overcoming poverty and weakness, making sure people had enough to eat. Meanwhile, the United States was flexing its infrastructure muscles with 400,000 kilometers of railways, 124,000 kilometers of highways, and engineering marvels like the Empire State Building and the Hoover Dam. In 1950, the US produced a staggering 87.85 million tons of steel, while China managed only 610,000 tons. But then, China's predecessors in the volunteer army faced off against the mighty United States. Picture this: during the Battle of Chosin Reservoir on December 5, 1950, the US 1st Marine Division was on the run, desperately trying to escape. The Xuemen Bridge in Qatari was a crucial escape route, but guess what? The Chinese volunteer army had already blown it up. And every time the US military engineers repaired the bridge, the Chinese soldiers would destroy it again. It was a battle of wills. But the US, with its powerful industrial capacity, managed to transport 8 sets of 8.8 tons of bridges from Japan within 2 days. And just like that, they swiftly constructed a massive all-steel 50-ton bridge. And then they swiftly withdrew. That scene left an indelible mark on our predecessors in the volunteer army. Since then, China realized that it must become stronger, or else it would be subjected to aggression. In 1953, with the end of the Korean War, China officially embarked on its first 5-year plan. From that moment on, China put in all its effort to catch up with the United States. If there was no money, they would eat one less meal. If there was no technology, they study hard and try their best to change. If there were no machines, the hands of Chinese workers became excavators, and their shoulders became cranes. In 1958, construction officially began on the Qinghai-Tibet Railway, the world's highest altitude and longest railway on a plateau. It traversed the Tanggula Mountains, reaching a maximum elevation of 5,072 meters. Most of the route was located in a zone of extreme conditions, spanning 550 kilometers of frozen soil. Once the frozen soil thawed, the roadbed would undoubtedly be damaged. To solve this problem, Chinese scientists employed methods such as building bridges to support the road, ventilating the roadbed, and using insulation panels. However, compared to frozen soil, the lack of oxygen, low temperatures, and ultraviolet radiation posed even greater challenges. For this purpose, China invested nearly 200 million yuan and established 115 medical support points along the railway, with over 600 resident medical personnel. Through their tireless efforts, since the start of the Qinghai-Tibet Railway, they have treated a total of 453,000 patients without a single death. This miraculous sky road took 26 years to complete and open for operation, opening up the previously isolated Qinghai-Tibet Plateau. It stands as a significant milestone in China's history of infrastructure development. While China every day is making amazing progress, achieving real results for technology, infrastructure, improving the nation building and working hard to improve the standard of living for the people, China's next-door neighbor India on the west border is always busy with their ton of boastful hypes, self-praise on their leadership, chanting superpower, dreaming of replacing China as world manufacturing country, but with not much real achievement, progress, and result. For instance, India plans to construct a railway bridge taller than the Eiffel Tower, named the Chenab Railway Bridge, located in the Jammu and Kashmir region. The bridge is designed with a lifespan of 120 years and a height of 359 meters, surpassing the Eiffel Tower by 35 meters. Construction on this bridge began as early as 2002, with the original completion target set for 2009. However, it was abruptly halted in 2008. The project remained at a standstill. In 2010, construction resumed, with Indian media claiming it would be finished by 2016. However, reality proved astonishing. By 2016, only the Bach Bridge pier of the Chenab Railway Bridge had been completed. Full construction resumed in 2017, and due to various reasons, the planned completion was further delayed to 2019. This series of setbacks has led to a prolonged delay in the completion of the Chenab Railway Bridge. The primary reasons include India's weak overall capacity, coupled with the high cost of construction materials, exacerbating India's already challenging economic situation. Furthermore, India lacked experience and technical expertise in the construction process, resulting in frequent issues and a decline in construction speed. Ultimately, the Grand Bridge took 21 years to complete, and it is expected to be operational by 2024. In summary, although India's Chenab Bridge incorporates high-tech materials and advanced construction techniques, surpassing China's infrastructure prowess remains a formidable challenge. In comparison, China's construction of the Three Gorges Dam, a hydraulic project, has attracted widespread attention and is hailed as an unparalleled feat in hydraulic engineering. Besides, they still have the gut and not ashamed to belittle and criticizing China infrastructures are built like tofu. China's success must have made them very upset, jealous and frustrating that many of their media channels know a day we don't see negative news, fake news and propaganda reports bashing and mocking China like a dog barking at the neighbor daily. But the China just ignored the dog barking noises and keep moving forward to get their business done to achieve what they aim for. Without further ado, let's get straight to the point. Firstly, let's take a look at the super bridge built in China at a cost of nearly 800 million, the Yachi Bridge. This grand bridge stands atop a cliff at an impressive elevation of 434 meters, with a total length of 1,200 meters. So, what was the level of difficulty in constructing this bridge? With a magnificent main span of 436 meters and a total length of 971 meters, the Yachi Bridge is not only the world's largest continuous rigid frame bridge with a steel concrete composite deck and a cable-stayed basket handle arch, but also the longest span high-speed railway bridge of its kind. The construction of the main tower's reinforcing steel used a groundbreaking method where steel was bound and formed into shape on the ground before being lifted and installed on the tower columns. The hydraulic climbing formwork employed a system with fewer pole rods, enhancing the appearance and quality of the tower columns' concrete. The connection of the bridge's steel truss arches involved precision welding and bolting, demanding extremely high machining and assembly accuracy, controlled to within millimeters. Any deviation exceeding 2 millimeters could result in misalignment of the bolted joints. The entire bridge required approximately 130,000 cubic meters of concrete, and the steel used in the truss beams amounted to over 16,000 tons. In the gorge where the bridge is situated, instantaneous wind speeds can reach up to force 10. The cable tower's top is 110 floors above the Yachi River surface, posing extremely high construction safety risks. American engineers boldly claimed that China couldn't complete such a project due to its complexity. However, Chinese engineers overcame numerous challenges, successfully completing the Yachi Bridge, showcasing the dominance of Chinese bridge construction technology and marking a significant milestone in the development of the Chengdu-Guiyang high-speed railway. Next, we arrived at the construction site of the Huajiang Canyon Bridge. This bridge spans the Huajiang Grand Canyon, famously known as the world's Great Rift. The bridge piers are strategically positioned at both ends of the mountain range, and the central section of the bridge is entirely suspended in mid-air. It is a single-span steel truss cable-stayed bridge. The Huajiang Grand Canyon stretches approximately 80 kilometers, making it the longest canyon in China. Within the canyon, towering peaks and deep river valleys create a nearly 1 kilometer relative height difference, earning it the title of the Earth's crevice. Constructing a bridge in such challenging terrain comes with numerous difficulties. The highest tower of the bridge, the design tower, reaches a height of 262 meters, equivalent to the height of more than 80 floors of a building. With a main bridge span of 1420 meters and a height of 625 meters from the bridge deck to the water surface, this colossal steel truss cable-stayed bridge is set to break world records. Upon completion, the bridge is expected to surpass the Beipanjiang Bridge and become the world's tallest bridge. The bridge is anticipated to be completed in 2025. In the southeastern coast of China, a grand project is in full swing. Over 20,000 builders, sweating profusely, meticulously planning, or working meticulously, have jointly created a marvel that attracts the world's attention, the Kong-Zhuhai-Macau Bridge. This bridge, stretching 55 kilometers, spans the turbulent sea, connecting Hong Kong, Zhuhai, and Macau, and has become the world's longest sea-crossing bridge. This bridge is not just a bridge, but also a pinnacle of national engineering technology and a crystallization of national wisdom. It stands on the southeastern coast like a rainbow spanning the sky, connecting people's hearts and dreams. Every nightfall, the lights on the bridge flicker like a giant dragon winding above the sea, illuminating the darkness and lighting the way forward. During the construction of this bridge, the builders overcame countless difficulties and challenges. Facing the complex marine environment, they continuously innovated and broke through technically, eventually completing this great project. With their sweat and wisdom, they have written an immortal legend and set a new benchmark for China's engineering technology. Today, the Hong Kong-Zhuhai-Macau Bridge has become a calling card for China, attracting countless domestic and foreign tourists to visit. Standing on the bridge, overlooking the turbulent sea, they feel the shock and pride brought by the bridge. This bridge is not just a bridge, but also a bridge connecting people's hearts. It brings Hong Kong, Zhuhai, and Macau closer together, jointly scripting a new chapter in history. In Wolong, Chongqing, the Chongqing-Huaihua Railway wins its way, with the mountain towering hundreds of meters above seeming like a massive scroll, tightly wrapped in scaffolding. Here, a struggle between man and nature is unfolding, a symphony of fearlessness and resilience. Countless builders, dressed in safety gear and helmets, move deftly on the vertical cliffs like rock climbing masters. Their tools, like brushes, outline exquisite patterns on the cliffs. These are protective facilities added to the dangerous rock mass, acting as sturdy shields, guarding the mountain and the safety of passing trains. Below is a bottomless abyss, like an impassable chasm, evoking fear. The roaring wind rushes past, sometimes gentle, sometimes violent, like nature's roar, impossible to ignore. However, these builders show no fear. With extraordinary courage and unwavering belief, they work for 5 or 6 hours suspended, battling the cliffs, the winds, and the dangers. Their figures appear particularly tall in the twilight. Their sweat leaves deep marks on the cliffs. Their dedication brings endless peace and hope to this land. They are the most lovable people in this land and the most beautiful scenery of this era. Here, there are no gorgeous words, no exaggerated embellishments, only genuine emotions and deep respect for the laborers. Let us salute these silently dedicated builders and applaud their courage and resilience. Similarly, in Wuhan, China, in the quiet of the early morning, an extraordinary engineering miracle quietly unfolds. 6 sturdy and massive high-speed overpasses, each weighing an average of 200 tons, are accurately dismantled and cleared in less than 5 hours. This magnificent achievement not only demonstrates the excellence of human engineering technology but also highlights the efficiency and excellence of modern urban construction. From closed construction to reopening to traffic, the entire process is like magic. Under the cover of night, engineers use precision mechanical equipment to silently begin this race against time. Like dancers, they manipulate every dismantling process flexibly and precisely, ensuring that each bridge is safely dismantled in the shortest time possible. When the first rays of sunlight reach the earth, the dismantling of the 6 overpasses is successfully completed. The highway reopens, traffic flows smoothly. Many drivers driving on this familiar road are surprised to find that the 6 bridges they once knew are now gone without a trace. They are amazed at this silent engineering miracle and deeply admire the wisdom and efficiency of the city builders. This feat not only demonstrates the efficiency and excellence of urban construction, but also showcases the infinite possibilities of human engineering technology. In the future, we look forward to more engineering miracles shining on this land, injecting continuous vitality and hope into the development of human society. China's bridge construction offers valuable lessons to the international community and inspires other nations to strive for excellence in infrastructure development. Chinese engineers continue to push boundaries, constructing large transportation bridges, especially high-speed railway bridges. These bridges are integral to China's extensive railway network, enabling fast and efficient transportation. It's worth noting that many of the world's most challenging and record-breaking bridges have been proudly built by Chinese engineers. The commitment to infrastructure development in this country has created miracles that impact the lives of over 1 billion Chinese citizens and drive economic growth. These examples clearly illustrate China's impressive achievements in bridge construction in recent years, garnering global attention and setting a positive example. The Green Passage in the Desert Xinjiang-Hotan Railway. In the remote northwest desert, a great feat is unfolding. In just over 3 years, The Hotan-Ruoqiang Railway has risen from this barren land like a giant dragon, spanning the Taklamakan Desert and shortening the journey for the people of Hotan by more than 1,000 kilometers. Imagine the construction site of the Darin Desert Highway in Xinjiang, where more than 30 large bulldozers traverse the sand hills, flattening the towering sand dunes into roadbeds. The roaring sound of the machines, like a war song in the desert, is awe-inspiring. This under-construction Darin Desert Highway is 151.764 kilometers long, not only an important part of the main channel in southern Xinjiang, but also a lifeline connecting southern Xinjiang with the northwest and southwest regions. The Taklamakan Desert, known as the Sea of Death, is a forbidden land with perennial high temperatures and sandstorms. However, the workers of the Hotan-Ruoqiang Railway, with their perseverance and resilience, have pierced through this desert that has been isolated for thousands of years. From Hotan City in the northwest corner of the Taklamakan Desert to Ruoqiang County in the southeast corner, there are 22 railway stations along the route, with a length of 825.476 kilometers. Among them, 524 kilometers of railway traverse extremely harsh desert areas, accounting for 65% of the entire route. The hardships during construction are indescribable. Railway workers not only face challenges such as supply shortages and hot weather, but also the constant threat of life-threatening situations. In the Taklamakan Desert, 7 months of the year are spent in sandstorms. When the sandstorm strikes, the workers can only lie on the ground, tying themselves and the railway equipment together with ropes to prevent being swept away by the sand. Such scenes have become part of the daily life of railway workers. The ingenuity of Chinese railway workers is also astonishing. To overcome the severe water shortage for concrete curing in the area, more than 400 bridge piers along the entire railway line are assembled using prefabricated pier body assembly technology. These giant bridge sections are not built on-site but are prefabricated in distant factories and then transported to the construction site for installation. This flexible and ingenious method not only reduces the work steps at the construction site but also ensures the quality of the bridge piers. What is even more admirable is that the railway workers proposed an advanced concept of building railways in the desert, controlling sand first. They have built nearly 50 million square meters of grass grids along the railway lines and planted nearly 13 million shrubs and trees. These green barriers not only beautify the desert landscape but also serve as windbreaks and sand fixers. As the world's first railway to pass through a desert, the Hotan-Ruoqiang Railway not only proves that China's railway construction technology has reached the world's top level but also demonstrates the spirit of the Chinese people who are not afraid of difficulties and are courageous in exploration. This green passage is not only a transportation artery connecting southern Xinjiang with the northwest and southwest regions, but also a road of hope forged with life. The Forbidden Zone Bridge, Pingtan Straight Road Rail Dual-Use Bridge. The Pingtan Straight Road Rail Dual-Use Bridge, a marvel in the history of bridges in China and even the world, finally opened to traffic in December 2020. After 7 years of arduous construction, it spans the strait like a giant dragon, connecting the prosperity and hope of both sides. As China's first cross-sea road rail dual-use bridge in history, and also the world's largest road rail dual-use bridge, its completion not only demonstrates China's strength in bridge construction but also serves as a powerful proof of Made in China. The main structure of this bridge is ingeniously divided into 2 levels. The lower level is a busy 2-way railway, with trains shuttling through at a speed of 200 kilometers per hour, like a flowing landscape. The upper level is a spacious 2-way expressway with a speed limit of 100 kilometers per hour, featuring 6 lanes, providing a safe and smooth passage for vehicles. This unique design not only realizes the parallel transportation of railways and roads, but also demonstrates China's innovative spirit in bridge design. However, the harsh natural environment of the Pingtan Strait posed unprecedented challenges to the construction of the bridge. It is not only one of the world's 3 major wind corridors, but also experiences over 300 days of wind above level 6 every year, making it extremely difficult even for ships to pass through. The deep water and high waves and winds have made this area a forbidden zone for bridge construction. However, it is precisely this forbidden zone that has inspired the Chinese workers' determination and determination. More than 5,000 builders have silently dedicated 7 years of their time here. They have worked day and night, overcoming countless difficulties and technical problems. They have used sweat and wisdom to write a brilliant chapter in Made in China, proving to the world China's top strength in bridge construction. The opening of the Pingtan Straight Road Rail Dual-Use Bridge is not only a milestone in the history of China's bridge construction, but also a vivid portrayal of the spirit of Chinese workers. Today, this bridge has become an important transportation hub connecting both sides, injecting new vitality into the economic and social development of the Pingtan region. It stands tall like a monumental monument, witnessing the indomitable spirit of Chinese workers in overcoming difficulties and demonstrating to the world the infinite possibilities of Made in China. In the days to come, the Pingtan Straight Road Rail Dual-Use Bridge will continue to carry people's hopes and dreams, bridging the gap across the strait and connecting to a better future. What you're seeing now is the Huajiang Gorge Bridge under construction in China, a structure so spectacular it takes your breath away. Once completed, it will set a new world record, proudly becoming the highest bridge in the world. From any angle, the bridge appears grand and magnificent. Workers toiling under the scorching sun at dizzying heights create a scene that leaves you breathless, almost feeling the terrifying abyss beneath their feet. This bridge is located at the border of Anshun City and Qiangsanan Prefecture in Guizhou, spanning a rugged mountain gorge. The total length of the bridge is 2,890 meters, with the main bridge deck towering 625 meters above the valley floor, equivalent to the height of over 200 floors. It surpasses the current highest bridge in the world, the Beipanjiang Bridge, by 60 meters. Even more astonishing, the main cables of the bridge weigh 9,331 tons each, composed of 217 strands, each 2,378 meters long and weighing about 43.4 tons. Each strand is made up of 91 wires of 5.7 millimeters galvanized aluminum magnesium steel, with a total length of 93,000 kilometers, enough to circle the equator more than twice. Once completed, this bridge will not only establish its position as the highest in the world, but also serve as a milestone in mountain bridge engineering, destined to become a monumental achievement in the history of Chinese bridge construction. This is the Zhangjiang Bridge, a monumental structure rising amid the majestic landscapes of the Wuling Mountain National Geopark, spanning the breathtaking Zhangke River. The bridge is 1,849 meters long, with a main span of 1,080 meters, making it the 11th highest bridge in the world with a distance of 380 meters from the deck to the river below. Construction workers, with incredible perseverance and skill, have lifted 73 steel beams piece by piece to heights of over 300 meters, with the total weight of the beam segments exceeding 16,000 tons, and the heaviest piece weighing 231.3 tons. The bridge is expected to be completed by July 2025, at which time the travel time between the two banks will be reduced from an hour to just 1 minute. This is not just an engineering marvel, but a bridge that connects the hearts of people on both sides. Now, let's revisit this engineering wonder that has captivated the world. The construction journey of the bridge began on March 6, 2021, with the foundation work on Tower 5. Subsequently, the construction of the gravity anchor on June 8, 2021, and the pier columns on October 20, 2021, laid the foundation for the bridge's stability. The successful completion of the beam construction on May 4, 2022, further strengthened the bridge's structure. On December 29, 2022, the topping out of Tower 5 marked a new milestone in the bridge's construction. The erection of the catwalk on May 4, 2023, provided a safe working environment for the construction crew. Following that, on June 25, 2023, the simultaneous installation of the main cables and the pushing construction of the steel beams on the Qinglong Bank highlighted the efficiency of the bridge's construction. The first segment of the main bridge truss was lifted on September 18, 2023, taking the bridge's construction to new heights. From September 2023 to April 2024, the continuous lifting of the standard truss sections of the main bridge ensured the smooth progress of the construction. Finally, on April 28, 2024, the lifting of the closing segment of the steel truss was completed, marking the successful completion of the bridge's main structure. What you're now seeing is the Yanjiao Yangtze River Bridge under construction, a miracle that transcends time and space, and the world's largest span 4 main cable suspension bridge. It not only represents the pinnacle of engineering, but also symbolizes the ingenuity of humanity. As the world's first 4 main cable dual-layer steel truss suspension bridge with varying sag, it stretches an impressive 26 kilometers across the Yangtze River, with a main span of 1,860 meters, turning a natural barrier into a thoroughfare. The upper level is a highway where cars speed at 100 kilometers per hour, while the lower level is an urban expressway allowing for a smooth commute at 80 kilometers per hour. On this bridge, speed and passion coexist, and dreams blend with reality. The 184-meter-tall main tower, constrained by aviation height limits, challenges the extremes of engineering. The tower walls are 4 meters thick, twice the thickness of a typical Yangtze River bridge tower. This not only tests the limits of materials and design, but is also a testament to the boundless creativity of humanity. The Yanjiao Yangtze River Bridge is not just a bridge, it is a link between the past and the future, an immortal monument to humanity's conquest of nature. It's hard to imagine how generation after generation of builders overcame numerous challenges such as topography, geology, hydrology, meteorology, materials, structures, and navigation. Even in economically challenging times, China continued to create new technologies, repeatedly achieving breakthroughs. The nearly 1 million bridges bear witness to the arduous journey China has traveled. Success in bridge construction not only plays a crucial role in domestic development but also has a positive impact on global bridge construction, providing valuable insights and experiences. Human intelligence is an evolutionary process. They get just a tiny bit smarter from their previous experience, whether a success or a failure. This is called learning. Yes, China has a lot to learn and catch up on after it gained full sovereignty a few decades ago. China is like a sponge, absorbing and improving technology, and to its credit, surpassing those it learned from. Many of the mega projects are not done for shows, but to improve what is already acceptable. China is a maritime power with a coastline spanning 32,000 kilometers, and it has constructed many cross-sea bridges. However, building bridges across the seas is quite challenging. The one you see now, called the Zhaihongmen Bridge, became China's largest span bridge from its completion, a record that has been held for a whole decade. In China's waters, there are over a dozen bridges with lengths exceeding 10 kilometers. For example, the Kong-Zhuhai-Macau Bridge is 55 kilometers long, the Zhoushan Cross-Sea Bridge is 50 kilometers long, and the Jiaozhou Bay Cross-Sea Bridge is 42 kilometers long, among others. These bridges showcase China's remarkable prowess in engineering and construction. So, foreigners praise China as the infrastructure maniac, and China undoubtedly deserves this title. This is the Tsingang Bridge, which was completed and opened to traffic in 2001. The bridge is constructed from reinforced concrete, with its beams embedded with pre-stressed steel strands and concrete, jointly bearing the load of the bridge deck, providing the bridge with greater spanning capacity. The single span reaches an impressive 50 meters. However, such a span is still insufficient because, as a cross-sea bridge, it faces a crucial challenge, which is navigation. The single-span 150-meter span Hongjiamen Bridge can only accommodate vessels of up to 500 tons for passage. However, facing the world's largest cargo throughput port, Ningbo Zhoushan Port, the cross-sea bridge that connects the Zhoushan archipelago and the mainland must provide ample space for passing vessels in the busy waterways, making it an inevitable necessity to construct bridges with larger spans and higher bridge decks. The Jintang Bridge, with its 620-meter-long main span, crosses over a vital maritime route, allowing cargo ships of up to 50,000 tons to pass underneath. The secret to achieving such a large span lies in the two towering bridge towers, equivalent to 70 stories high, and 168 inclined steel cables. These cables securely hold the bridge deck and cleverly transfer the weight of the bridge to the sturdy towers. Its distinctive design offers strong resistance to wind, and it can be seen on most cross-sea bridges. Of course, this design is not always suitable. When faced with more complex underwater terrain, with currents and whirlpools that even span several hundred meters cannot overcome, a different type of bridge is needed: a suspension bridge. The previously mentioned Zhaihongmen Bridge is one such suspension bridge, with two main cables with a diameter of about 0.86 meters connecting a massive deck, allowing it to cross turbulent and hazardous waters with its 1,650-meter span in a single span. The Tsingang Bridge, Zhangjiaomen Bridge, Taoyuan Bridge, Zhaihongmen Bridge, and Jingtang Bridge, and their connecting sections together form the Zhoushan Cross Sea Bridge. It is these bridges that connect the cities of Ningbo and Zhoushan via a sea highway. However, to truly bridge the gap across the sea, one bridge is not enough. We need a mega combination. This combination is bridged along with underwater tunnels. The Kong-Zhuhai-Macau Bridge, completed and opened to traffic in 2018, spans 55 kilometers and serves as the world's longest cross-sea bridge, connecting Hong Kong, Zhuhai, and Macau. The bridge wins its way and gradually descends beneath the sea. At the near end of the bridge, 33 giant pipes are submerged, forming a 6.7-kilometer underwater tunnel. These not only provide ample space for navigation but also reduce the impact of the entire project on the water flow. The artificial islands on both sides ingeniously transition the underwater tunnel to the cross-sea bridge. With such a combination, the longest cross-sea bridge in the world literally paves a path across the vast sea. Today, this mega combination is set to create a new marvel once again, which is the Shenzhen-Zhongshan link that also traverses Lingdingyang to connect the two cities in Guangdong province. The 270-meter-tall bridge tower you are currently seeing will together form the new city skyline with Shenzhen's towering skyscrapers. Simultaneously, the bridge tower supports the Lingdingyang Bridge with a span of 1,666 meters, making it the largest span bridge in Chinese waters. Given the project's total length of 55 kilometers, with the underwater tunnel accounting for nearly 7 kilometers of that length, the use of immersed tubes is the most suitable approach overall. However, employing this method comes with significant technical demands, particularly involving extensive calculations to ensure that there are no gaps between each tube, achieving perfect alignment. This is essential to prevent water pressure from causing leakage or seepage. These are the widest giant immersed tubes in the world, with each section weighing up to 80,000 tons, and their displacement even surpasses that of fully loaded aircraft carriers. They are transported to their designated locations by a unique vessel for submersion, forming a one-of-a-kind bidirectional 8-lane underwater tunnel. With the assistance of the Beidou satellite navigation system, these enormous immersed tubes, about 165 meters long, ensure millimeter-level installation accuracy. However, whether dealing with massive and majestic super bridges or large-scale underwater tunnels, the real challenge of crossing the sea lies in addressing the challenges posed by the ocean itself. In the southeastern coastal regions of China, there are over 300 days of strong winds at or above force 6 each year, making it one of the world's 3 major wind-prone sea areas. The intense sea winds bring large waves, making this area seem like a no-go zone for bridge construction. However, it is now the location of China's first and currently the world's longest cross-sea bridge that accommodates both road and rail traffic, the Pingtan-Haixia Cross-Sea Bridge. How does it overcome the strong winds and waves at sea? Firstly, it must have a bridge deck with sufficient weight and height. The total amount of concrete used in the entire bridge is enough to build 4 national theaters. Faced with such a massive bridge deck, ordinary winds and waves pose no threat to the bridge. Furthermore, dampers distributed throughout the bridge provide cushioning, absorbing, and dissipating impacts from natural disasters like typhoons and tsunamis. But to avoid windy weather, certain bridge components are prefabricated in factories and then transported to the construction site for assembly, significantly reducing the time needed for offshore construction. For example, the massive steel truss components, with a maximum weight of 3,400 tons, are lifted into place by large floating cranes that are almost 40 stories tall, equivalent to lifting over 2,000 cars in a single operation. The anti-collision boxes used to deflect ship impacts have also been cleverly utilized as temporary construction platforms, increasing the efficiency of bridge construction. Of course, the challenges from the ocean also come from below the surface. The seabed here is extremely firm and almost devoid of sediment, which presents unique challenges. To secure the bridge firmly in this hard seabed, Chinese engineers developed giant drilling machines weighing up to 344 tons. These machines bore massive holes with diameters of up to 5 meters in the solid rock. Subsequently, 18 giant piles with diameters of 4.5 meters and lengths of 60 meters are driven into the holes, forming a solid foundation for the bridge towers. With such a massive foundation, the bridge piers and towers can anchor securely, allowing the bridge to stand firm amidst wind and waves. The challenges from the ocean encompass not only strong winds, waves, complex geological conditions, water depth, currents, tides, and ship collisions, but also high salinity and humidity in the air, all of which can affect the lifespan of a bridge. This is also why building the 16-kilometer-long Pingtan-Haixia cross-sea bridge took more than 5,000 builders 7 years to complete. Chinese engineers, with their intelligence and diligent work ethic, have created numerous engineering wonders in the land of China. For example, the Shenzhen-Zhongshan Bridge, with a total length of 24 kilometers, involved over 10,000 builders in China, with a planned duration of 8 years to complete this mega project. As for the 55-kilometer-long Hong Kong-Zhuhai-Macau Bridge, from initial planning to opening for traffic, it took more than 20,000 builders a whopping 15 years to complete this colossal project. So, with the construction of cross-sea bridges being so challenging and time-consuming, why does China keep finding ways to cross the sea again and again? The answer is quite simple. It's for the convenience of the people. In the future, the Shanghai-Zhoushan-Ningbo cross-sea passage will directly connect Shanghai and Zhoushan, forming a closed loop with the cross-sea bridges, uniting the entire Hangzhou Bay. Meanwhile, in Fujian, starting with the Pingtan-Haixia cross-sea bridge, a cross-sea passage stretching 120 kilometers will extend. This means that in the future, high-speed trains departing from Beijing will pass through the Taiwan Strait, arriving directly in Taipei, connecting Taiwan and the mainland as one. China's infrastructure construction prowess is not only evident in the construction of cross-sea bridges, but also the construction of megadams. Next, we will take you through how Chinese engineers construct megadams above rushing rivers. Baihetan Dam, a colossal project with an investment of $9.2 billion that spanned 12 years, stands as a super engineering achievement where Chinese engineers overcame numerous technical challenges. This dam is a comprehensive hydraulic project that serves various purposes, including flood control, irrigation, power generation, and navigation. Its immense scale and high technical complexity make it a global standout. The completion of this project is undoubtedly a source of pride for Chinese engineering professionals and a testament to human achievement as a whole. The construction of the Baihetan Hydropower Station commenced in 2007, and after 12 years of relentless effort, it was fully completed in 2019. Baihetan Dam has a height of 300 meters and a length of 2,300 meters, capable of withstanding a once-in-a-millennium superflood, ensuring the safety of downstream areas. Moreover, the dam boasts the world's largest underground power plant, housing 16 sets of 1 million kilowatt hydroelectric generator units, with a total installed capacity of 16 million kilowatts. It produces an annual electricity output of approximately 60 billion kilowatt hours. This project provides robust energy support for China's economic development while reducing carbon dioxide emissions, contributing to China's and the world's environmental conservation efforts. Next, let's share another mega dam in China. The Lianghekou Dam, a colossal dam built on the world's rooftop, is taller than the Eiffel Tower. It is located in a high-altitude plateau region, with an elevation exceeding 3,000 meters. The project is situated in an extremely harsh geographical environment characterized by diverse climatic changes and frequent geological hazards, posing significant challenges and dangers to the construction process. Even more unbelievably, for the construction of such a massive engineering project, Chinese engineers chose not to use reinforced concrete but instead employed earth and rock as the primary construction materials for the hydropower station. The dam of the Lianghekou Hydropower Station is one of China's tallest earth and rock-filled dams. with a total fill volume of approximately 43 million cubic meters. This is equivalent to the volume of earth and rock from nearly 9,000 football fields. To ensure the stability and seismic resistance of the dam, the Lianghekou Hydropower Station employs various innovative design and construction methods, such as layered filling and zone compaction. These construction techniques optimize the compactness and strength of the Lianghekou Dam, enabling it to easily withstand the impact of earthquakes and floods. The Three Gorges Dam. It's a concrete gravity dam located in the middle reaches of the Yangtze River, not only the world's largest hydraulic engineering project, but also the world's largest hydroelectric power station. It spans the majestic Yangtze River, creating a reservoir that covers more than 600 kilometers, exceeding the land area of the entire country of Singapore. Its scale is so vast that it has even slightly altered the Earth's rotation. It's an inspiring endeavor, but also a challenging one. While it provides power to hundreds of millions, it has also faced criticism due to concerns about potential collapse. But what's the truth behind it? Is the dam really at risk? Let's explore the story of this mega project together. The construction of the Three Gorges Dam was an enormous challenge. It took nearly 80 years, from the initial planning in 1932 to the official commencement in 1994, and finally, comprehensive completion in 2006. Throughout this process, engineers had to overcome various difficulties and risks, such as diverting the flow of the upper reaches of the Yangtze River while ensuring sufficient water continues to flow downstream. They also had to build such a massive project on a major river, using over 16 million cubic meters of concrete, and do so in a seismically active area, requiring considerations of geological stability and earthquake resistance. The construction of the Three Gorges Dam is a magnificent feat of the Chinese people and a model in the world of hydraulic engineering. While the Three Gorges Dam has brought significant benefits, it also faces challenges and problems. The most prominent issue is the resettlement of people from the reservoir area. With thousands of cities, towns, and villages submerged by the reservoir, around 1.4 million people were forced to relocate. Despite government compensation and assistance, many of these resettled individuals still face difficulties and dissatisfaction related to housing, employment, education, and healthcare. Another crucial issue is the environmental impact. Reservoir impoundment has led to bank collapses, geological disasters, water pollution, and a reduction in biodiversity. Especially rare species like the Chinese river dolphin and the Chinese paddlefish have become extinct or are on the brink of extinction. There is also a serious issue of collapse risk. If the dam were to suffer damage or breach, it would have catastrophic consequences, endangering the lives and property of hundreds of millions downstream. Hence, the Three Gorges Dam requires constant scientific assessment, monitoring, and maintenance to ensure its structural integrity and operational safety. One of the primary functions of the Three Gorges Dam is power generation. It has 32 units with 700,000 kilowatt and 2 units with 500,000 kilowatt hydroelectric generators, giving it a total installed capacity of 22.5 million kilowatts, with an annual power output exceeding 100 billion kilowatt hours. This is equivalent to saving 31 million tons of standard coal each year and reducing carbon dioxide emissions by 86 million tons. The Three Gorges Dam is the world's largest power station by capacity, far surpassing any other hydroelectric or nuclear power station. For comparison, the largest U.S. hydroelectric station, the Hoover Dam, is only a tenth of the capacity of the Three Gorges Dam.
Oh God, please, no! No!
The Three Gorges Hydropower Station supplies stable clean energy to the Yangtze River Basin and the eastern coastal regions, underpinning China's economic and social development. Another vital function of the Three Gorges Dam is flood control. The Yangtze River is one of China's longest and most important rivers but is prone to flooding. In the 1930s and 1950s, two massive floods caused millions of deaths and extensive property damage. To protect cities and rural areas along the Yangtze River from flooding, the Chinese government decided to build the Three Gorges Dam in the middle reaches of the river. The dam can store 39.3 billion cubic meters of floodwater, significantly reducing the flood risk for the lower reaches of the Yangtze. It is estimated that the Three Gorges Dam can reduce a once-in-a-century flood to an event that occurs once every 1,000 years. The dam provides security for the Yangtze River basin and downstream cities, reducing casualties and economic losses. The Three Gorges Dam also serves as a vital transportation link. The Yangtze River is one of China's most important inland waterways, but navigation has been restricted due to meandering river channels, water level fluctuations, and treacherous rapids and shoals. The Three Gorges Dam has addressed these challenges by constructing ship locks and a ship lift, facilitating vessel passage between the upper and lower reaches of the Yangtze. The ship locks at the Three Gorges Dam are the largest in the world and can accommodate either one 10,000-ton cargo vessel or 6 1,000-ton cargo vessels simultaneously. The dam's ship lift is the most advanced in the world, capable of lifting vessels weighing up to 3,000 tons from the downstream to the upstream or vice versa in just 40 minutes. The Three Gorges Dam provides efficient and convenient waterway transportation for the Yangtze River basin and countries along the Belt and Road, promoting trade and cooperation. In conclusion, the Three Gorges Dam is a super project with both pros and cons, achievements and challenges. It embodies the spirit of the Chinese people who fear no difficulties, dare to innovate and strive for excellence, as well as the complex relationship between China's socio-economic development and environmental protection. The Three Gorges Dam is an engineering marvel that deserves our respect, study, and reflection. While the dam undergoes regular inspections, there have been satellite images circulating online that appear to show slight deformations in the shape of the Three Gorges Dam. Still, the Chinese government quickly dismissed these rumors, attributing these distorted images to algorithm errors in Google Maps. They explain that while some deformation may indeed exist, it is not as severe as depicted in the images. So, the claims that have circulated in recent years, suggesting that the Three Gorges Dam has deformed and is at imminent risk of failure, are unfounded. These claims aim to undermine the safety and reliability of the Three Gorges project, create panic, and sow discord. Firstly, the design and construction of the Three Gorges Dam have undergone rigorous scientific scrutiny and technical testing, meeting international standards and regulations for hydraulic engineering. The dam utilizes a concrete gravity structure, ensuring strong stability and earthquake resistance. Advanced construction technologies and equipment were employed during the dam's construction to guarantee the quality of the concrete and the compactness of the dam body. During operation, the dam is equipped with an extensive safety monitoring system and emergency response plans, continuously monitoring and analyzing various indicators to detect and address any abnormalities in real time. According to officially disclosed data, as of April 2019, all indicators of the dam were within design allowances. Secondly, it's essential to understand that some degree of deformation is normal and does not imply danger. This deformation is periodic, reversible, and controllable, and it does not affect the structural integrity or operational safety of the dam. The Three Gorges Dam considered these factors during the design phase and has maintained a margin of safety. Monitoring data indicates that the deformation of the Three Gorges Dam is within the elastic range, with no irreversible or excessive deformation. Finally, it's crucial to recognize that the use of photos from platforms like Google Maps as evidence of the Three Gorges Dam's deformation is scientifically unsound and unreliable. These photos are often generated through stitching, compression, and processing and do not accurately reflect the actual situation. Additionally, the photos may have been taken or obtained at different times, angles, and resolutions, making them unsuitable for effective comparison. Even if some changes appear in the photos, these could result from factors like lighting, perspective, and scale, creating visual errors without necessarily representing actual changes. In summary, the controversy surrounding the deformation of the Three Gorges Dam is an unfounded rumor created and spread by some individuals with ulterior motives. We should approach this issue with a scientific and rational mindset and have faith in the safety measures and capabilities of the Three Gorges project. We should view this project with pride and confidence. It is a great achievement for the Chinese people and a model in the world of hydraulic engineering. So, what are your thoughts on the Three Gorges Dam project? Do you believe the dam has truly deformed and is at imminent risk of collapse? Baihetan Dam, a name that has been resounding in recent years, is not only a milestone in China's hydroelectric engineering but also a marvel in the history of global hydropower construction. Its maximum height of 289 meters makes it as tall as a 100-story skyscraper, yet the narrowest at its crest is only 14 meters wide. Despite the extremely slim body, this dam is able to withstand 16.5 million tons of thrust, which is enough to send more than 15,000 Long March 5 rockets to the sky. How is this possible? Perhaps a change in perspective is all we need to know the answer. Looking from above, the Baihetan Dam adopts an arch structure, commonly known as arch dam. This structure can transfer the thrust of the water flow to the mountainous sides. With mountains sharing the load, arch dams do not need to be as massive as gravity dams to remain stable. As a statically indeterminate structure, arch dams exhibit extremely high levels of safety that their overload capacity can be up to more than 10 times the design load. The Baihetan Dam, located in the lower reaches of the Jinsha River, it is the world's largest under-construction hydropower project with the highest technical difficulty. Its completion will have profound effects on China's energy structure, Yangtze River flood control, and navigation. However, today we won't discuss these high-level topics. Instead, let's talk about the awe-inspiring process of pouring concrete. The pouring process of the Baihetan Dam is an engineering marvel. Just imagine, to build this dam, the total amount of concrete required is enough to construct 25 Shanghai World Financial Centers, a scale that is truly astounding. The pouring method is even more jaw-dropping, with 7 huge cable cranes working in concert, lifting containers filled with 30 tons of concrete, and precisely pouring them across the hundreds of meters of the gorge. This not only tests the excellence of the technology but also showcases the wisdom and courage of the engineers. To ensure the integrity of the dam structure, engineers decided to use a one-time pouring method, which meant that for 1,500 days, workers had to work day and night without stopping. To meet the dam's demand for stone materials, engineers mined the rock using explosives equivalent to the power of a light atomic bomb. Up to 200 dump trucks shuttle back and forth on the construction site every day, continuously delivering these stone materials to the stone processing plant. However, during the concrete pouring process, Chinese engineers demonstrated their innovative spirit by using a type of low-heat cement and strictly selecting stones, greatly enhancing the anti-cracking performance of the concrete. During the mixing process, engineers also added crushed ice to ensure that the concrete could maintain a low temperature of 6 degrees Celsius. Moreover, vehicles responsible for transporting concrete were all equipped with thermal insulation layers to ensure that the temperature of the concrete could be controlled at 12 degrees Celsius when it arrived at the pouring site. To better control the temperature of the dam, engineers divided the dam into sections for pouring and installed temperature sensors, with on-site workers continuously measuring the temperature of each area and uploading the measurement data to the central control system in real time. This control system acts like the nervous system of the dam, responsible for collecting and analyzing various information, including excavation, grouting, concrete pouring, etc. Once any abnormal temperature is detected in a construction area, the central control system will immediately activate the embedded water pipes for automatic cooling, ensuring that the pouring work of the dam can proceed smoothly. At the other end of the deep dam construction, we see Chinese engineers working on a spectacular project, excavating massive cavern groups to install the world's largest generator units. Faced with the challenge of embedding 16 huge million-kilowatt level generator units into an unstable mountain, they have shown remarkable professionalism and wisdom. Engineers first created a massive space on both sides of the mountain, measuring 438 meters long, 34 meters wide, and 89 meters high, a scale large enough to accommodate an aircraft carrier. The amount of sand and gravel excavated is enough to fill 2 West Lakes in Hangzhou. However, excavating such a huge space in the mountains with 2 fault zones and ensuring its stability is undoubtedly a daunting task. To ensure safety, engineers decided to pre-grout the mountain before excavation, as if using glue to bond loose mountain materials into a strong hole. At the same time, they installed more than 4,000 sets of detectors on the front and back mountains, which act as sensitive sentinels, monitoring any slight changes in the mountain at all times. Once an anomaly is detected, the Safety Monitoring Center immediately issues a warning. With safety ensured, engineers began excavation of the caverns. They cleverly divided the excavation of the caverns into 10 layers, excavating layer by layer from top to bottom, and grouting the rock walls with anchors after each layer was excavated. This way, the constructed caverns are like a fortress, impregnable. When they reached the 4th layer, according to the design requirements, a huge gantry crane needed to be installed. This gantry crane's role is to facilitate the installation of the water turbine generator units that would follow. The water turbine generator unit consists of a water turbine and a generator. Its working principle is to draw water from the dam's 200-meter high intake hole, guide it through the huge pipes on both sides of the dam into the spiral-shaped volute, drive the water turbine to rotate, convert the impact force of the water into mechanical energy, and then drive the generator to generate electricity. To withstand the tremendous water pressure, the volute is made of special steel. The rotation of the 1 million kilowatt generator requires a huge rotor, the manufacturing of which is considered the most difficult in the world. This 350-ton water turbine is the core component of the Baihetan Dam generator unit. According to safety standards, the dynamic balance of the water turbine is extremely strict, with deviations per kilogram not exceeding 1.5 grams per millimeter. Despite the enormous manufacturing difficulty, Chinese engineers did not back down. They spent a full 5 years to finally produce the world's largest rotor. The rotor is welded together with an upper crown, a lower ring, and 15 blades weighing 11 tons each, requiring the use of tens of tons of welding wire. Moreover, the welding process requires heating the rotor to 120 degrees Celsius before welding can begin, which is undoubtedly a huge challenge for the welders. After welding, the rotor undergoes a series of rigorous tests to ensure its performance reaches optimal condition. Afterwards, it will be sent to the cavern of the dam for installation. Inside the cavern, a gantry crane capable of lifting 1,300 tons will play a crucial role. It will lift the rotor steadily and install it inside the water turbine generator. After the water turbine is installed, the next step is to install the generator rotor, which has a diameter of 16.2 meters, a height of 4 meters, and a weight of 2,100 tons. These installation works require extremely high precision and rigorous operating procedures to ensure the safe and stable operation of the generator unit. When it comes to the gantry crane that can only lift 1,300 tons, you might have some doubts about how it could handle lifting this massive 2,100-ton object. But engineers' ingenuity always surpasses our imagination. They cleverly combined two gantry cranes to form a powerful force. What's even more surprising is that they decided to let a female operator control this combined crane. Such an arrangement may confuse many people. Why choose a woman to operate such a large lifting equipment? Is it because women have unique advantages in certain aspects? Perhaps they are more careful, patient, and able to remain calm and stable in complex operations. Or maybe it's just to break gender barriers and show more people the strength and charm of women in the engineering field. Regardless, this female operator demonstrated amazing skills. She had to lift the 2,100-ton rotor to a height of 6 meters and move it steadily to the installation position over a distance of more than 300 meters. This requires extremely high precision and stability, but she did it, and the entire process took nearly an hour. However, this was just the beginning of the challenge. The distance between the generator stator and rotor was only 5 centimeters, which was a huge test for the crane operator. Any slight mistake could lead to the failure of the entire project. Fortunately, she had 12 years of driving experience, and with her rich experience and close cooperation with ground personnel, successfully installed the rotor in the designated position. It is these Chinese engineers who dare to innovate and challenge themselves, using their wisdom and courage, who have created engineering miracles that amaze the world. They have not only demonstrated the excellent level of Chinese engineering technology, but also shown the courage and responsibility of Chinese engineers to the world. China's bridges and dams are the shining jewels of Chinese engineering technology, as well as the crystallization of the wisdom of the Chinese people. They witnessed the brilliant achievements of China's engineering construction and showcased the charm of Chinese engineering technology to the world. In the future, we have every reason to believe that China will continue to create more miracles in the field of bridge and dam construction. The mega project involves building man-made canals, aqueducts, and tunnels to transport fresh water to industrial areas in China's north. In this video, we'll be taking a closer look at China's controversial south-to-north water diversion project, how much it costs, why they're doing it, its effects on the environment, and how exactly benefits China's people. Before we begin showcasing this project to you, we sincerely request your support for our video by subscribing and enabling notifications so that you don't miss any of our exciting updates. We highly value your thoughts and invite you to share your views on the remarkable engineering feats in the comments below. In the long history of humankind, China's south-to-north water diversion project stands out as one of the largest water diversion initiatives, often referred to as a colossal endeavor. Despite taking decades for planning and construction, costing $250 billion, and requiring 20 years to complete, the project has exerted a profound and far-reaching impact on the development of Chinese society. This project effectively addresses the challenge of uneven water resource distribution between the northern and southern regions of China, delivering benefits for generations to come. China boasts vast territory and complex terrain, resulting in a stark imbalance between water resource distribution and demand. The southern region possesses nearly 70% of the country's water resources, which are abundant year-round and even prone to flooding. However, the southern cultivated land accounts for only 40% of the total national land area. Conversely, regions encompassing the Yellow River, Huaihe, and Haihe River basins, constituting 40% of the nation's cultivated land, possess only 8% of the country's water resources. This stark disparity has led to perennial water scarcity in the northern region. Extensive irrigation and industrial water usage have severely depleted the Yellow River's water resources. Remarkably, China's per capita domestic water consumption is only 70% of the lowest levels observed in developed countries, with Beijing and Tianjin exhibiting water efficiencies surpassing the United States average. Hence, China has devoted considerable manpower, material, and financial resources to execute this monumental engineering project. China's ambitious project stands as a testament to human engineering's audacity in challenging nature itself. Stretching across thousands of kilometers with artificial canals, aqueducts, and tunnels that surmount formidable mountains, This endeavor aims to supply water to the arid industrial hubs in the northern regions. The roots of this project extend back millennia, with the construction of the Grand Canal, an enduring testament to ancient Chinese ingenuity. This historic water conservancy achievement not only stands as the world's longest canal, but also its earliest and most extensive. In an era devoid of modern transportation, river transport emerged as the most convenient, labor-efficient, and cost-effective means of connectivity. The Grand Canal's sprawling network, spanning over 684 miles, with a maximum elevation of 138 feet above its lowest point. For millennia, the Yellow River region grappled with devastating floods, a concern shared with other parts of the world, such as the United States. Understanding geographical dynamics is essential, especially in light of significant snowfall events, like those in 2019 in Texas. The construction of water reservoirs and channels emerges as a vital solution. The intrinsic value of water for human survival is paramount, underscoring the importance of undertaking even costly projects like this. In many cases, these are initiatives that the current generation invests in for the benefit of future generations. The central role of the South-North Water Diversion Project is to channel surplus water from the southern regions to the provinces of Hebei, Hunan, Shandong, and Beijing-Tianjin area, total length 1432 kilometers. With a combined population of 350 million and contributing 40% of China's agricultural output, the significance of this project cannot be overstated. Remarkably, this feat of engineering has consistently astounded American engineers, who recognize that such an achievement is within the unique capacity of China on a global scale. China's geography has played a dual role throughout its history, offering both advantages and hurdles. The presence of the Yangtze and Yellow River systems, flowing from the west to the east, has sustained thriving civilizations in eastern China for millennia. The region's fertile floodplains have continuously supported a burgeoning Chinese population. China's Yellow River Valley stands out as one of the world's largest and most consistently cultivated arable regions. Conversely, northern and far western territories are characterized by aridity and rugged terrain. From the formidable expanses of the Taklamakan and Gobi deserts in the north to the imposing landscapes of the Himalayas and the Tibetan Plateau, much of China's northwest remains sparsely inhabited and unsuitable for agriculture. Eastern China is home to 95% of the Chinese population. Historically, northern cities, including China's capital, Beijing, have served as focal points for population, agriculture, and trade. However, as China's population and wealth witnessed unprecedented growth in the mid-20th century, access to critical resources, particularly water, became increasingly challenging for the northern region. Cities like Beijing have long depended on groundwater reserves to sustain their inhabitants. Rapid urbanization and industrial expansion placed immense strain on the finite freshwater resources in the region. Compounding this issue was the relentless expansion of the Gobi Desert in China's Inner Mongolia Autonomous Region, marked by increasingly frequent dust and sandstorms. The desert encroaches upon approximately 3,600 square kilometers each year, roughly twice the size of Luxembourg, through the process of desertification, primarily driven by human activities like deforestation and the changing climate. Notably, the depletion of underground water sources aggravated this ecological challenge. By the early 1950s, it became glaringly evident that northern China was on the brink of a water supply crisis. With the continuous growth of northern cities and a dwindling water supply, China faced the daunting task of finding a sustainable solution to support the livelihoods of hundreds of millions in a historically arid region. China's first-generation leader, Mao Zedong, proposed in 1952 the idea of simply transferring water from the south of the country to its dry northern regions. He was quoted saying, "Water in the south is abundant, water in the north scarce. If possible, it would be fine to borrow a little." 50 years later and today, Mao's vision was finally approved by the country's state council after years of extensive planning and research. The mega project would officially be called the South-North Water Transfer Project. An ambitious plan was to create a series of connected aqueducts, tunnels, reservoirs, and dams that would transfer fresh water from the water-abundant south to the water-starved north. The mega project would consist of 3 major canal systems that would be called the Eastern, Central, and Western routes. The Eastern route begins near the city of Yangzhou through a major branch of the Yangtze River. The Eastern route massive but old pumping station is responsible for pumping the water from the Yangtze onto the Jing-Hang Grand Canal, the world's longest fully constructed artificial waterway. From there, the water passes through an underground tunnel bringing it across the Yellow River. Finally, a series of aqueducts transfers the water towards the coastal city of Tianjin, which borders the capital Beijing to the northwest. In total, the entire stretch of the project's eastern route is over 1,100 kilometers long. However, due to multiple delays in the construction, this was pushed back over several years. By 2017, the delivery of fresh water to Tianjin, amounting to approximately 1 billion cubic meters per year, had finally materialized, benefiting up to 10 million residents in the city. In contrast to the eastern route, which leveraged existing infrastructure, the central route encountered unique complexities. Its journey commences at the Danjiankou Reservoir, necessitating a remarkable elevation of the Danjiankou Dam by 50 feet to facilitate the unimpeded flow of water northward through canals and aqueducts, obviating the need for pumping stations. This transformative alteration, however, mandated the relocation of over 300,000 individuals from Hubei and Hunan. The remainder of the central route comprises an intricate network of man-made canals and aqueducts, resembling a water highway, traversing the Chinese Central Plain. Notably, the Shay Aqueduct extends over 12 kilometers above the Xiao River. Ultimately, the central route culminates in Beijing, China's capital, with its construction completed in 2014, spanning over 1,200 kilometers. This extensive water diversion, diverting approximately 1/3 of the Han River's flow, posed significant challenges for the millions reliant on the Han for fresh water. In response, the Chinese government announced in July 2022 a visionary plan to construct a vast underground tunnel, connecting the Three Gorges Dam to the Han River, and subsequently to the central route leading to Beijing. This pioneering tunnel, extending 1 kilometer below the Earth's surface, will be the longest and deepest artificial waterway ever built in human history. By 2030, the central route is anticipated to convey an impressive 12 cubic kilometers of water annually, equivalent to 1/3 of the Three Gorges Reservoir's capacity. In contrast to the operational eastern and central routes, the western route remains in the planning stage, representing the most formidable construction challenge of the three. The western route's ambitious blueprint envisions a network of waterways and tunnels, navigating the arduous Qinghai-Tibet Plateau, situated 3 to 5 kilometers above sea level. The region's daunting topography and climate further compound the project's complexities. Engineers will need to sculpt passages through mountains to surmount this challenging terrain. Projections set the completion date for the western route at 2050, and when finished, it is expected to deliver a substantial 17 cubic kilometers of fresh water annually to northern Chinese provinces. This extensive infrastructure could potentially benefit nearly 100 million people residing along its path.
Nice.
While unofficial speculations have arisen regarding the diversion of water from transboundary rivers like the Brahmaputra and Mekong, originating in China and passing through India and Southeast Asia respectively, such intentions have never been part of the official project's scope. Nevertheless, concerns from India have been raised, particularly regarding China's capacity to manipulate river flow, causing apprehension within the Indian government. For China, the South-North Water Transfer Project, although not fully completed, is already demonstrating significant success. According to Chinese state media, this colossal undertaking extends vital water resources to around 140 million Chinese citizens in regions suffering from water scarcity. However, the project garners divergent opinions from local and provincial Chinese governments. Southern upstream provinces like Sichuan and Hubei vehemently opposed the redirection of the Yangtze's flow northward, fearing adverse impacts on their water security and hydropower sector. In contrast, western provinces such as Gansu and Qinghai anticipate that the construction of the western route will bring much-needed socio-economic and agricultural stability to their regions. While the project has proven beneficial for some northern Chinese cities, it has elicited significant concern among local and international environmentalists. The project's reliance on artificial waterways disrupts the natural west-to-east flow of China's rivers, causing hundreds of natural rivers to be interrupted and some to entirely dry up due to artificial diversion. In fact, the sheer size and water volume transported by the project have led to the disappearance of 600 rivers during its construction. Additionally, the South-North Water Transfer Project faces the unintended consequence of industrial waste and sewage infiltrating these artificial waterways. For instance, the Central Route, originating at the Danjiangke Reservoir, encounters pollution from industrial cities like Shenzhen, which discharge their waste into the Han River, subsequently feeding into the reservoir and eventually the Central Route leading to Beijing. Since a large portion of these artificial rivers goes through hundreds of cities and villages across the country, many people, businesses, and industries dump their trash into these man-made waterways. The absence of adequate water treatment facilities along the project's entire course further exacerbates this issue. With the diversion of the Yangtze River's natural flow reduced by up to 36% upon the opening of the Central Route, experts raised concerns about potential seawater backflow from the Yellow Sea, jeopardizing the local water supplies of coastal Chinese cities. The continued decrease in the Yangtze's flow, driven by the diversion into artificial rivers, could exacerbate this issue, potentially causing salt water from the Yellow Sea to infiltrate the man-made canals. Such an event could precipitate a nationwide water crisis. The Western Route, currently stuck in the planning stage, presents another major environmental worry. The official plan involves the construction of tunnels through a rugged and mountainous Chinese region, with the potential for landslides and ecological disruption to the local flora and fauna. Moreover, the Qinghai Tibet Plateau, where the Western Route is proposed, is seismically active, raising concerns about the project's vulnerability to significant earthquakes, which could entail substantial financial consequences for the Chinese government. Presently, 2 of the 3 planned routes of the South-North Water Transfer Project have been completed. However, this progress has come at a considerable cost to the Chinese government and its citizens, encompassing financial, environmental, social, and economic dimensions. The project's estimated total cost hovers around $62 billion, excluding the ongoing expenses required to maintain over 3,000 kilometers of canals, aqueducts, dams, tunnels, and reservoirs. Despite this substantial financial investment, the project's primary objective of providing clean water to China has yet to be fully realized. China's infrastructure development in this country has created miracles that impact the lives of over 1 billion Chinese citizens and drive economic growth. The South-North Water Transfer Project clearly illustrates China's impressive achievements in infrastructure construction in recent years, garnering global attention and setting a positive example. A massive project benefiting both the nation and its people, such as the South-North Water Diversion, is something that, looking at the world today, only China has the determination to pursue, with successive governments taking the baton. If it were in the hands of Western governments, it would probably still be mired in disputes today. The South-North Water Diversion Project is a vital initiative to address water scarcity in China's northern regions. It will impact 1/3 of China's population, making it the world's largest hydraulic project. As part of our nationwide strategy, the South-North Water Diversion Project is a crucial endeavor, indispensable in the grand rejuvenation of the Chinese nation, and a remarkable achievement that benefits millions. Currently, China is experiencing a massive boom in the construction industry, boasting the world's largest construction market, accounting for 20% of global construction investment. Moreover, these figures continue to rise steadily. It's projected that by 2030, China will invest nearly $13 trillion in construction. Allow me to take you through the complex process of constructing highways in desert areas, exemplified by the recent opening of a new highway in China's Taklamakan Desert. This endeavor began in October 2017 and involved multiple stages, from surveying the challenging terrain to designing a road that can withstand harsh desert conditions, including sandstorms. In a similar vein, the construction of railways in desert regions, like the new South Xinjiang Railway, showcases the importance of land preparation, track laying, and specialized techniques to cope with extreme temperatures and environmental challenges. China's dedication to combating desertification is evident in its use of grass grids and green barriers in construction projects. These measures effectively prevent sand movement and erosion, contributing to the reclamation of desert land. Thanks to these efforts, China has restored over half of its manageable desertified land in the past decade, drastically reducing the desertified area. Moreover, China's commitment to renewable energy is evident in the inauguration of the Al-Kharsa solar power plant, one of the largest in the Middle East. This plant signifies a step toward clean energy adoption and carbon emission reduction in Qatar, highlighting the country's shift away from fossil fuels. China's advancements and achievements in combating desertification are exemplary and have even earned global recognition. Through green initiatives, successful projects, and the utilization of clean energy, China is actively working to address desertification and promote environmental sustainability. Step into the awe-inspiring world of China's remarkable construction capabilities, where monumental achievements redefine the boundaries of possibility. Embark on a journey through the heart of a nation that stands as a testament to innovation, dedication, and the relentless pursuit of progress. With a rich history of rapid growth, China has evolved into the world's second-largest economy, a feat that is inseparable from its sophisticated transport networks that traverse its vast landscape. At the core of this remarkable feat lies the world's largest highway network, a web of roads that carry a staggering 80 million tons of freight daily, crisscrossing the nation with efficiency and precision. The sheer scale of this network is paralleled only by the world's largest high-speed rail system, a testament to China's commitment to connectivity. This intricate rail network links hundreds of cities and enables swift, seamless travel for millions. But the story doesn't end there. China's aerial prowess is equally awe-inspiring, with a sprawling air transport system that boasts a whopping 227 airports. And when it comes to maritime supremacy, 7 out of 10 of the globe's largest ports are nestled along China's coastline, underscoring the nation's strategic maritime importance. This intricate transportation network doesn't just serve as a lifeline for the economy, it's a lifeline for progress itself. The relentless drive for advancement has ensured that night and day, the network evolves both quantitatively and qualitatively, meeting the ceaseless challenge of efficiently moving people and goods across the nation. Yet even in the face of such rich tradition, progress is unyielding. Tackling the towering Chola Mountains, which for centuries acted as a barrier between China's heartland and its Tibetan region, is a project of unparalleled ambition. For 5 years, a Herculean effort has been underway to create the world's longest and highest road tunnel. Once complete, this engineering marvel will obliterate the need for the hazardous dirt road that has been traversed for over half a century. It's a struggle that embodies the nation's spirit, where thousands of workers brave the harshest of environments to carve out a safer, more efficient passage. Their dedication is nearing fruition, with the tunnel set to open in just a month, transforming a perilous journey into a 10-minute drive under the shelter of solid rock. It's a testament to China's relentless pursuit of progress and its capacity to overcome even the most imposing challenges. At the heart of this transformation stands Huang Qi-Tin, an engineer who is poised to become the first to drive through the tunnel. Armed with cutting-edge technology, his car is equipped with a 360-degree laser radar, a continuous image-capturing camera, and a positioning data acquisition system. He captures real-time road information as he navigates the tunnel's interior, contributing to a comprehensive mapping effort that has never before been undertaken. These monumental feats of infrastructure are a testament to China's unparalleled commitment to connectivity, growth, and progress. With over 200 million vehicles coursing through the planet's largest highway network, carrying an astonishing 15 billion passengers and over 33.6 billion tons of cargo annually, China's highways are the lifeblood of its economy. But as China propels itself forward, it faces the challenge of maximizing efficiency and reducing waste. Nearly 40% of China's trucks run empty, leading to higher freight costs and unnecessary energy expenditure. This inefficiency undermines the very purpose of its robust highway system. Chengdu, a crucial transport hub, is taking steps to revolutionize the industry. By employing advanced technology, Chengdu's logistics port is streamlining trucking operations. Trucks are matched with cargo requirements, reducing empty runs and optimizing freight transportation. This digital innovation is not only changing the way goods are moved, but also paving the way for a more energy-efficient future. However, highways aren't the only backbone of China's transport prowess. The Yangtze River, the longest in China, has long played a vital role in its communications. The Three Gorges Dam, a monumental feat of engineering, stands as both a flood control mechanism and a significant energy generator, providing power to 9 provinces and 2 cities. With the dam's completion, the Yangtze River has evolved into the world's busiest inland waterway, allowing ships to navigate its once treacherous waters with ease. As China embraces its role as a global player, its demands for energy are substantial. Vast coal reserves in its arid west must be transported thousands of kilometers to meet the energy needs of its thriving eastern cities. The Shuohuang Railway stands as a testament to this logistical marvel, an artery through which 226 trains run daily, carrying essential coal supplies that fuel the nation's growth. The railway is a feat of engineering brilliance, navigating treacherous terrain and overcoming steep descents to ensure the safe and efficient transport of vital resources. Amidst this vast network of connectivity, the heart of Beijing is witnessing the rise of another marvel, a new super airport. This terminal, a marvel in glass and steel, stands as a testament to China's unrelenting commitment to innovation. With a design that optimizes space and maximizes convenience, passengers will be able to traverse this sprawling hub without ever traveling more than 600 meters to reach their gate. But the marvels don't end with the terminal. Beneath its surface lies an even greater innovation. The integration of a high-speed railway station beneath the airport terminal allows for seamless transfers among multiple modes of transportation. This innovation, fueled by cutting-edge technology, ensures that China's new airport doesn't merely serve as a hub but transforms the way people move within a city. As China reaches for the skies, its ambitions extend beyond its own borders. The C919, China's independently developed large passenger aircraft, is undergoing rigorous testing to ensure it meets the highest international standards. Designed to reduce fuel consumption by 15%, the C919 is not only a symbol of China's growing aerospace capabilities but also a testament to its commitment to sustainability and efficiency. If you want to spend your time admiring bridges, don't worry. China has an abundance of tall bridges scattered all over, enough to keep you on bridges for a lifetime. As China's urban development transitions from rapid expansion to a focus on reinforcement, structural engineering plays a crucial role in improving the quality of urban life. These bridges symbolize China's national strength and the Chinese government's commitment to providing its citizens with a high-quality life. China's bridge construction technology has evolved from followers in the 1980s to leaders in the 21st century, gradually taking center stage on the international platform. China is not only the largest recipient of overseas infrastructure project orders, but has also held the top spot for over a decade, as if creating orders in the field of bridge construction is their destiny. China now boasts over 1 million modern bridges, including the world's tallest and longest sea-crossing bridges. It is known that China has built approximately 14,000 bridges on railways with a total length exceeding 5,500 miles, of which about 4,000 miles are dedicated to high-speed rail. Out of the 100 tallest bridges built in this century, 90 of them are in China. So, the title of Father of World Bridges is well deserved by China. In this video, we will delve into the extraordinary challenges of building gigantic bridges in China. Constructing such bridges in these rugged terrains is undoubtedly a daunting and exhilarating endeavor, but in China, it seems to have become commonplace. In China, we have witnessed numerous ambitious and innovative bridge projects that are seldom seen in other countries. The sheer scale of China's gigantic bridges leaves Western nations in awe. China has achieved remarkable feats in bridge construction, earning titles such as the world's tallest bridge, the world's longest bridge, and the highest number of major bridge construction projects. So, do you know which bridge holds the title of the world's tallest? Many may already know it. It's the Shantou River Bridge. This extraordinary achievement was accomplished by Chinese engineers. When American engineers first heard about China's plans to build this bridge, they initially thought it would take thousands of years to complete. They conducted various analyses, believing that the local terrain was unsuitable for such a bridge. However, the construction of this innovative project was completed in just 3 years, with a staggering cost of $147 million, and the massive investment ultimately led to its successful completion. Upon hearing this news, American engineers could only maintain silence. In their country, constructing a bridge of such magnitude is exceedingly challenging, not only owing to technical complexities but also due to differing intentions between China and the United States in this matter. China builds bridges for the convenience and happiness of its people, while the primary motive for bridge construction in the United States is profit.
Oh God, please, no! No!
Constructing such a bridge in the United States would undoubtedly be a loss-making venture, so America is not inclined to invest heavily in this area. The Shantou River Bridge allows most vehicles to access previously unreachable areas. You can drive nearly 2,000 feet above ground as if you were riding in a flying car. The construction of this engineering marvel required meticulous planning and extensive research. The gorge crossed by the Shantou River Bridge is incredibly deep, necessitating a structure that can withstand the strong winds generated in the valley below. To address this challenge, engineers opted for sturdy steel truss cable-stayed spans, ensuring the necessary flexibility and strength to keep the bridge as solid as a rock. The bridge's final height exceeded the initial design by hundreds of feet because it had to be raised to avoid cracks and caves on the mountainsides on either side of the valley. Despite a budget increase of around $40 million, this iterative process ultimately made the bridge exceptionally tall. The Shantou River Bridge has transformed the commuting habits of the Chinese people, turning previously unreachable areas into easily accessible ones, reducing travel time, and changing the travel habits of people in the mountainous, highland, river, and gorge-laden regions of Guizhou. The bridge is part of the G65 Hangzhou-Ruijin Expressway, spanning approximately 1,825 miles. It has reduced travel time from hours to minutes, promoting economic growth and regional integration. It symbolizes China's financial strength, engineering prowess, and global standing. The Shantou River Bridge's status and influence in terms of both height and cost are unparalleled in the history of world bridge construction. Guizhou's rocky terrain and valleys make it a hub for high bridges, with over 250 bridges exceeding 100 meters, a concentration that surpasses any other country in the world, making China the capital of high bridges. In summary, while the Shantou River Bridge is the tallest in the world, it is just one example of China's dedication to infrastructure development, economic growth, and the creation of astonishing architectural marvels. For perspective, the Empire State Building could easily fit beneath it. This bridge is like a gateway between heaven and earth, and its construction is more akin to building a ladder to the stars. Now, let's explore the Defangsu Bridge in Guizhou Province, which connects Renhuai and Junyi, bringing convenience to countless travelers. This bridge stands out with its tubular arch design, supporting a 6-lane commuter highway. This architectural style harks back to ancient China, where wooden arch bridges were often used to span waterways, although none matched the scale of the Defangsu Bridge, spanning 410 meters and towering 280 meters high. The Defangsu Bridge showcases the strength of modern engineering technology in China, turning impassable mountainous terrain into accessible roadways. Guizhou's bridges are pushing the limits as if challenging the constraints of gravity. For those who don't believe bridges can float in the sky, it's a visual and spiritual marvel. Get ready to be amazed by one of China's tallest bridges, the Pingtang Bridge, a marvel of engineering in Guizhou province. This cable-stayed viaduct stretches for 2 kilometers, spanning steep valleys and significantly reducing travel time between Pingtang and Luodian. Its 3 towers, each towering like skyscrapers, reach heights of over 300 meters, equivalent to a 110-story tall building. Driving on this massive bridge is both thrilling and awe-inspiring. Now, let's head to Guizhou province to explore the remarkable Yangbeishi Bridge, a high bridge marvel that facilitates efficient travel in the rugged mountainous terrain of the region. Guizhou province boasts nearly 1,000 bridges with deck heights exceeding 100 meters, an achievement unmatched by any other country. For example, the Yangbeishi Suspension Bridge has significantly reduced travel time between Guoliang City and Huangping County, cutting it from 3.5 hours to just 1 hour. Often referred to as the Stilt Bridge, the Yangbeishi Bridge's pier lengths reach an astounding 110 meters, nearly twice as long as San Francisco's famous Golden Gate Bridge. As for the bridge deck, it soars over 300 meters above the turbulent waters of the Qinghai River, making the crossing an exhilarating and at times terrifying experience. The Kong-Zhuhai-Macau Bridge is nothing short of a pinnacle achievement in sea crossing bridge construction worldwide. The world's longest sea crossing bridge, spanning 55 kilometers, it's objectively 20 times the length of San Francisco's Golden Gate Bridge. This marvel has reduced travel time from Hong Kong to Zhuhai and Macau from 3 hours to just 45 minutes, reshaping transportation and making significant contributions to the economy. However, the journey of constructing this bridge was filled with controversies. During its construction, nearly 20 workers lost their lives due to hazardous conditions. In 2017, a corruption scandal rocked the project, revealing that a Chinese company had manipulated concrete test results instead of conducting proper safety checks. Some international civil engineers also raised concerns about the bridge's resilience to strong waves and typhoons. Although the government disputed these claims, American engineers remained adamant about the bridge's potential dangers. Nevertheless, the completion of the Kong-Zhuhai-Macau Bridge marks a new milestone in Chinese bridge construction, showcasing the extraordinary prowess of Chinese engineering technology while reminding us of the importance of safety and transparency in large-scale projects. The Longjiang Suspension Bridge, entering the earthquake-prone region of Yunnan Province, connects Baoshan and Tingchong through a series of roads, tunnels, and the towering Longjiang Suspension Bridge. This bridge is perched at a daunting height of 300 meters above ground and is equipped with advanced movable joints designed to withstand powerful earthquakes. Yunnan's history of seismic activity has caused significant destruction in the past, making the safety features of this bridge critically important. Imagine experiencing an earthquake at such a height. It's nerve-wracking for anyone, but the Longjiang Suspension Bridge is just the beginning. So, what about bridges that have collapsed before? The Longjiang Suspension Bridge showcases the pinnacle of technology, leveraging engineering expertise to overcome nature's challenges and setting a solid example for future bridge construction. Zhangjiajie Glass Bridge is one of the world's most spine-chilling tourist attractions. Experience an adrenaline rush on this bridge, which stretches over 430 meters and hovers 300 meters above the ground. Carefully cleaned glass panels offer a clear view of the scenery below, providing an unforgettable photo opportunity for thrill seekers. Those with daring spirits will want to visit this terrifying glass-bottom bridge in China, as it promises an exciting adventure. Standing on this bridge, you can overlook breathtaking natural landscapes, but for those with a fear of heights, it may be a significant test. When you step onto this bridge, you'll embark on an unprecedented adventure, one that will be etched in your memory. Don't forget to bring your camera because the scenery here is breathtaking. Then you must be very curious about how such a thrilling bridge was built, right? Please watch the video. Hangzhou Bay Cross-Sea Bridge, a colossal project spanning 36 kilometers, connects Ningbo and Shanghai, significantly reducing travel distances and providing convenience to millions of people. The sheer scale of this bridge is astonishing. It shortens the journey between Ningbo and Shanghai from 400 kilometers to 280 kilometers and reduces travel time from 4 hours to 2.5 hours with a 6-lane, two-way designs, boasting one of the world's highest travel speeds. The Hangzhou Bay Cross-Sea Bridge is one of China's most important bridges, not only transforming regional transportation but also driving economic growth. It is a masterpiece of Chinese bridge engineering and a testament to technology and innovation. Finally, let's take a look at one of China's most famous sea-crossing bridges, the Bohai Bay Bridge. This bridge is one of the world's longest sea-crossing bridges, spanning 36.48 kilometers and connecting China's Liaoning Province and Shandong Province. It serves as a crucial transportation hub in northern China, significantly reducing distances between coastal cities and enhancing regional economic connectivity. This bridge presents not only technical challenges but also the need to withstand harsh weather conditions, including ice, freezing temperatures, and strong winds. The construction of the Bohai Bay Cross-Sea Bridge signifies China's remarkable achievements in bridge engineering, setting an example for the rest of the world and emphasizing the importance of safety and transparency in large-scale projects. In summary, China's bridge engineering is among the most awe-inspiring and breathtaking in the world. These bridges have not only transformed transportation and economic landscapes within China but have also showcased China's formidable strength in engineering technology and innovation. These bridges are not just feats of transportation engineering but also symbols of the Chinese people's hard work and spirit of innovation. Now, let's continue. First, let's introduce a bridge that the United States couldn't solve. The Hamilton Bridge in New York City, spanning the Harlem River, is a crucial transportation artery for the area. However, due to its age, safety concerns arose, prompting the United States to invite international bids from engineering teams. Naturally, China won the bid, But could the United States accept this? Constructing this bridge posed numerous challenges. The United States kept throwing obstacles, demanding stringent conditions to ensure existing traffic wouldn't be affected during construction. Why build a new bridge? Because the old one was damaged. Who would continue using something that's broken? Any other country's engineers would have given up facing such difficulties. But China is different. Not only did China help the United States repair the bridge, but the engineering quality also fully met American standards. Trying to trouble Chinese engineers is simply wishful thinking. Let's move on to the world's longest dam, built by Chinese engineers in Sudan. The Sudanese Merowe Dam, located about 350 kilometers north of the capital, Khartoum, spans 1.1 miles, making it the world's longest dam. Considering that China's Three Gorges Dam is only 2,000 kilometers long, the Merowe Dam is practically the second Three Gorges Dam. When Sudan first issued a global tender, hardly any country, including the United States, dared to respond because the budget for this project was too low to be profitable. China stepped up and took on the project. After reaching an agreement, a team of Chinese experts was sent to assist in the construction. Initially, the construction faced difficulties as Sudan lacked the industrial and economic strength to use advanced materials. This forced China to devise a simple earth and stone plan. However, Sudan's engineers lacked sufficient technical expertise, so Chinese engineers had to be hands-on, simultaneously building the dam and teaching the Sudanese engineers. Soon, skilled Sudanese engineers emerged, and together with China, they overcame numerous challenges to complete the project. After the dam was completed, Sudan experienced a significant leap in its national strength. However, as American experts had predicted, the project's budget was severely insufficient, leaving China with little profit. So why did China help Sudan build the dam? The reason is simple. China aimed to expand cooperation with African countries. Upon completion, Sudan placed great trust in China, leading to numerous collaborations between the two nations. China has now become one of the most welcomed countries in Africa. Behind China's title of construction magician, few know that China encountered tremendous challenges while constructing an ultra-long tunnel, digging 14 kilometers and only managing a little over 2 kilometers per year. This is certainly not fitting for the title of China's construction magician. The tunnel, the longest in North Africa, was deemed a disaster by French engineers due to its complex geological conditions. China's engineers spent nearly 7 years conquering this challenge. The tunnel's success highlighted China's construction capabilities, leading many countries to entrust their infrastructure projects to China. Today, China's influence in Africa has gradually surpassed that of France, moving on to large-scale projects within China's borders. Before the project was even completed, it drew worldwide attention. Electricity construction has always been a focal point of China's future, as its vast population demands increasing energy year by year. With many economic facilities relying on water transport in inland China, hydraulic engineering is indispensable. Although the construction of the Three Gorges Dam significantly improved China's power supply, it still couldn't meet the country's current electricity demands. China is known for its advanced hydraulic engineering, and the West-East Electricity Transmission Project is a result of this background. The project's centerpiece is the Baihetan Hydropower Station, which has already become one of the world's largest arch dams under construction. The Baihetan Hydropower Station stands in a geographically challenging location, completed on the main course of the Jinsha River. It is the second largest hydropower station downstream of the Jinsha River among 4 large hydropower stations. In just 4 years, the hydropower station was completed and started storing water. In the following 7 months, it underwent electricity testing and grid commissioning before all units were officially put into operation. This project broke numerous world records and was as challenging as the Three Gorges Dam. The Baihetan Hydropower Station's success showcased China's formidable engineering capabilities, especially in power generation. Currently, there is no other hydroelectric power plant in Western China as powerful as this one, making it unique. However, constructing such large units was not a straightforward task for China, especially given its location in an earthquake-prone area. The basic requirements were for it to be earthquake-resistant, robust, reliable, and durable. To complete the dam's casting, construction personnel had to dig and deliver materials simultaneously. Geologically, the natural dam foundation of the Jinja River area is not solid, mostly composed of basalt, which is prone to cracks due to its many fractures. To mitigate this, China's engineering team used low-heat cement during casting, ensuring minimal heat release to prevent cracking. Additionally, they invented seamless construction joint technology to make the spillway tunnel appear mirror smooth. Ultimately, the spillway tunnel completed the flood discharge test, releasing water at a speed of 48 kilometers per second, becoming the world's largest group of unpressurized spillway tunnels. Undoubtedly, the Baihetan Hydropower Station is an essential project in China's water management plan. It will provide ample electricity to eastern China while contributing significantly to global green, low-carbon, and environmental protection efforts. In just one day, the power generated by the Baihetan Hydropower Station can meet the annual electricity consumption of over 500,000 households. With the sturdy underground cavity, these large generators can now be safely placed for operation. Despite differing opinions on environmental concerns, this marks China's future energy direction, transitioning from traditional to clean energy. With the advancement of new water management plans, China is set to go further on the path to clean energy. In recent years, China has continuously constructed large-scale engineering projects, increasing investment in new projects and establishing a high-level technological innovation pattern in infrastructure. China's new infrastructure is facing unprecedented development opportunities. With its massive market, complete industrial system, and the original intention of China's development foundation, implementing new infrastructure has all the necessary conditions. In terms of technology maturity, the deep integration of digital technology in the real economy gives China an advantage with a wealth of data and diverse application scenarios, conducive to accomplishing new infrastructure tasks with existing technology. China's infrastructure not only brings convenience to its citizens, but has also started to extend beyond its borders, helping other countries improve their infrastructure. China's infrastructure endeavors have not only helped other countries achieve modernization, but have also brought numerous benefits to China. It's a win-win situation. China's remarkable engineering and construction strength has left many foreigners believing that China is already a developed country. What comes to mind when you think of American cities? Bustling streets, well-maintained roads? The reality might disappoint you. In fact, most American streets are far from tidy, trash is abundant, and the roads themselves are in a sorry state. Pakistani Prime Minister Imran Khan once openly criticized the condition of New York's roads, describing the experience of driving on them as excessively bumpy.
The Chinese were developing first world infrastructure, and you'll just have to go to China to see the way their infrastructure is. And I'm in New York, and I'm watching the car bumping around here.
Okay.
That money was wasted.
You know, you do not sound right now like a prime minister from Pakistan.
Contrasting this with major Chinese cities reveals a stark difference. Why hasn't the United States improved its infrastructure? Before discussing this question, let's examine the current state of American infrastructure. From a statistical perspective, the United States has a commendable level of infrastructure. In terms of highways, it boasts a total length of 6.85 million kilometers, over 1 million kilometers more than China, perfectly befitting its status as a global superpower. However, a significant portion of these highways were constructed a century ago, while many others were built between the 1950s and 1980s. Very few new roads have been built. It's not difficult to imagine the poor condition of American highways, with potholes being a common occurrence.
What the fuck?
Even major cities like New York cannot escape the fate of a bumpy ride. let alone more remote areas that will make you question your life choices. Moving on to the subway system. How terrible is the subway in the United States? Former Secretary of State Hillary Clinton once visited a New York subway station and struggled to enter the turnstile, swiping her card 5 times in front of a crowd. Besides outdated turnstiles, the trains and tracks are equally outdated. Every time a train arrives at a station, it produces a thunderous noise. Listen, the thunderous roar emitted by the US subway when it arrives at the station is like an airplane taking off, and the noise it produces is highly discomforting. Now, let's take a look at China's subway system, and I believe that with this comparison, you'll see just how outdated the subway system in the United States really is. So, with a subway system as outdated as the one in the United States, do you still expect it to excel in other aspects? It's slow, often delayed, and gives people the constant feeling that the train could break down at any moment. Moreover, the subway systems lack various user-friendly designs. Firstly, many subway stations don't have elevators, making it difficult for passengers carrying large luggage or with disabilities to use the subway. Secondly, there are no safety barriers between platforms and tracks, increasing the risk for passengers. In New York alone, there are over 100 safety incidents each year due to these issues. In addition, the New York subway also offers a unique sightseeing experience: trash and rats. You can see these two things almost everywhere in the station, on the tracks, and even inside the train cars. If you don't believe me, watch this short video. As the saying goes, no pain, no gain. Let's take a look at China's subway system. The waiting halls are spacious and brightly lit, with smooth and clean floors that reflect people's images clearly. Even a casual photo captures a sense of modernity. However, the New York subway, with its dim lighting, deteriorated walls with peeling paint, and the accumulated dirt seen everywhere on the floors and ceilings, makes it hard to imagine that beneath the glamorous New York City lies such a historically rich side. It's safe to say that New York City has one of the worst subway systems in the world. The poor state of the subway system extends to trains and airports as well. Remember the recent train derailment in Ohio? Well, the U.S. Secretary of Transportation, Pete Buttigieg, wasn't surprised at all. Why? Because there are around 1,000 train derailments in the United States every year, but the one in Ohio received the most attention. The situation is similar for airports and train stations, which are plagued by issues of dirt, outdated facilities, and aging infrastructure. However, these issues aren't the most severe problems in the United States. More severe issues are found in bridges, power grids, and dams. In early 2021, Texas experienced widespread water and power outages due to extreme cold weather. In June of the same year, an apartment collapse in Miami claimed the lives of 94 people. In 2020, 2 dams in Michigan burst. Tragedies caused by aging infrastructure are countless in the United States. In 2017, the American Society of Civil Engineers reported that over 200,000 bridges in the United States were over 50 years old, with an additional 56,000 bridges having structural deficiencies. It is perplexing why the United States, knowing the extent of its outdated and deteriorating infrastructure, has not taken swift action to improve it. Actually, it's not that the United States doesn't want to improve, it's just that they lack the means to do so. This might come as a shock to many. How could the mighty world superpower that spends so much money creating havoc around the globe not have enough funds for infrastructure? But unfortunately, that's the case for the United States. From Obama to Trump, and now Biden, all of them have made efforts to address infrastructure issues. For instance, when Obama took office in 2009, he vowed to have 80% of Americans riding high-speed trains within 25 years. Yet, what has been achieved to date? 14 years have passed, with 2 presidential terms, and high-speed rail is still a distant dream within the United States. The only project that was initiated, the California high-speed rail, turned into a massive failure. It was approved in 2008, construction began in 2015, and in 2019, they announced a significant reduction in the project, cutting the original 826.8-kilometer route down to a mere 190 kilometers. With a travel time of only 2 hours, is there really a need for a high-speed rail? Apparently, even the California government had doubts, resulting in delays and ultimately a complete failure to complete the project. As for the existing high-speed rail, the Acela Express, it has an average speed of 110 kilometers per hour and a maximum speed of 240 kilometers per hour. It can be considered a long-distance train rather than a high-speed rail system. In stark contrast, China's C500 high-speed trains can reach a maximum speed of 505 kilometers per hour, demonstrating a vast difference. The Acela Express has been in operation since 1993, and after 30 years, it's no wonder it's been left behind by the times. Even Trump couldn't ignore the dire state of infrastructure in the United States. He planned to spend $1.5 trillion to rebuild the country's infrastructure, including roads, dams, bridges, power grids, and more. Unfortunately, the proposal failed, and the first step of the infrastructure plan was abandoned. And what about Biden? As soon as he took office, he introduced the Reconstruction for a Better Future Act, which not only incorporated the infrastructure plan from the Trump era, but also included the field of renewable energy, with a budget of $2 trillion.
In fact, it's the largest American jobs investment since World War II. It will create millions of jobs, good-paying jobs. It will grow the economy, make us more competitive around the world, promote our national security interest, and put us in a position to win the global competition with China in the upcoming years. It's big, yes. It's bold, yes. And we can get it done.
However, like his predecessors, Biden faced a significant challenge. There was no money. Despite the wealth of the United States, where did all the money go? Military spending, scientific research projects, provoking other countries, the list goes on. As for infrastructure and welfare, these initiatives are continuously delayed because they are not considered priority projects in the United States. So Biden came up with a solution, increasing corporate taxes. This didn't sit well with Trump.
Are our leaders. How stupid are these politicians to allow this to happen? How stupid are they?
After working tirelessly for 4 years to reduce corporate taxes from 35% to 21%, he couldn't believe that as soon as he stepped down, Biden planned to raise them to 28%. It felt like a robbery. Moreover, Biden's infrastructure plan was touted as a means to compete with China, but with increased corporate taxes, it's unlikely that anything substantial will be accomplished. Consequently, Biden's bill initially upset entrepreneurs, and some even suggested that whoever uses roads and power grids should foot the bill. The Republican Party, to which Trump belongs, was largely opposed to the bill. On one hand, its implementation would escalate the U.S. fiscal deficit, worsening the country's situation. On the other hand, it simply became a matter of party rivalry, opposing any policy proposed by the opponents. Additionally, some members of Biden's Democratic Party staunchly opposed the Reconstruction for a Better Future Act, fearing it would lead to severe inflation in the United States. While their reasons may sound valid, it's clear that personal interests play a significant role in their opposition. Despite the convoluted process, the infrastructure bill was eventually passed due to popular demand. The only downside was that the bill's budget plummeted to $1.2 trillion. Though it may sound like a substantial amount, when used for infrastructure, it's merely a drop in the bucket. Just take a look at the allocation of funds in the United States, when $650 billion was initially allocated for infrastructure and maintenance. After deducting those costs, the remaining new funds amount to only $550 billion. Out of that, $110 billion is designated for major road and bridge projects, $66 billion for railway construction, $73 billion for power grid expansion and updates, and so on. Let's not forget the railway construction project. Back in 2008, the budget for the California high-speed rail was $33 billion, and it took 7 years to commence construction after the project's approval. But guess what? By 2018, halfway through the project, only 191 kilometers had been completed, and the cost had skyrocketed to $77.3 billion. And now, a mere $66 billion is allocated for railway projects. Is that enough? We haven't even considered the severe inflation the United States has been facing in recent years, along with rising labor costs. On the other hand, China's Beijing-Shanghai high-speed rail, approximately the same length as the California high-speed rail, started construction in 2008 and opened for traffic in June 2011. In just 3 years, China accomplished what the United States failed to do in over a decade. Moreover, when the California high-speed rail was abandoned in 2019, it was reduced to a mere 191 kilometers, costing a staggering $93.73 million per kilometer. In contrast, China's Beijing-Shanghai high-speed railway had a total investment of 220.9 billion yuan, with a construction cost of approximately 167 million yuan per kilometer. In terms of cost, the United States spent 4 times more than China but failed to complete the project. The gap in infrastructure between China and the United States is vividly apparent. China's infrastructure level is not only reflected in this aspect. For example, in January 2018, the Longyan railway station in Fujian underwent a major renovation in just one night without disrupting travel the next day. In 2017, more than 200 excavators in Nanshan worked together to dismantle the Longlangmiao overpass, a 589-meter-long structure, in just 8 hours. It was an extraordinary feat. Let's not forget the Leishanshan Hospital in Wuhan, built in 12 days, or the even faster construction of Huashanshan Hospital in 10 days. And who can forget the 30,000-ton passenger station that was moved 288 meters without being demolished, a remarkable display of engineering prowess. Out of the 10 tallest buildings in the world, China claims 6. Particularly in recent years, China has made extensive efforts in infrastructure construction, spending over 10 trillion yuan each year. It's both wealthy and efficient, earning China the title of an infrastructure maniac. Even Elon Musk marvels at how China's infrastructure progress is over 100 times faster than that of the United States. Can you believe that more than 100 years ago, the United States was once the pioneer of infrastructure development? In 1840, while China was suffering from foreign aggression, the United States had already built 2,818 miles of railways, making it the country with the longest railway mileage at the time. By 1910, American railways spanned 410,000 kilometers, accounting for half of the world's total. And what about China's railway mileage today? It stands at a mere 155,000 kilometers, highlighting the disparity in infrastructure between the two countries. The Empire State Building, completed in 1931, took 410 days to construct and stood as the world's tallest building for 41 years. It was considered one of the 7 engineering wonders of the modern world. The Hoover Dam and Golden Gate Bridge, both iconic American engineering marvels, were also built before World War II. In addition, roads, power grids, subways, all were completed in the 1960s and 1970s, decades ahead of China. However, with such a remarkable history of infrastructure development, why has the United States fallen behind? Let's not forget how the American railroads were built. In 1849, a large number of Chinese laborers went to the United States to construct the Pacific Railway. The working conditions for the Chinese laborers were horrendous. Wage deductions were the least of their worries. The worst part was that they were treated as less than human. Regardless of freezing temperatures or scorching heat of 50 degrees, white overseers would drive them to work. Refuse to work? Well, they'd whip and starve you until you complied. Just during the construction of the Pacific Railway, thousands of Chinese laborers lost their lives. The Chinese workers faced immense hardships, but the Native Americans suffered even more. They built railways, dug canals, and constructed cities wherever roads were needed, nearly driving the indigenous population to extinction. It's clear to see now, isn't it? The title of American infrastructure maniac was not earned by white people themselves. It was the result of enslaving other nations. Now, with no one else left to enslave, they can only rely on themselves. But with high wages and excellent benefits in the United States, who would dare to complain? No work on scorching hot days, off on rainy days, and staying home during windy and snowy weather, plus the 8-hour work system on various holidays. How can infrastructure costs not skyrocket? After all, even if workers don't work, wages cannot be reduced. Attempt to pay less, and the unions will make sure to give you trouble. The high cost of infrastructure, coupled with a lack of willingness to invest, compounds the problem. Back in the day, when the United States had an abundance of land, they could afford to give it away to attract investors. But what about now? 58% of the land is privately owned. How can the United States foot the bill? Even to undertake infrastructure construction and use other people's land, they have to pay for land acquisition. Therefore, the United States' dream of competing with China in infrastructure is simply a fantasy. Even if the infrastructure bill is passed, the future remains bleak. Just take the California high-speed rail project as an example. Clearly, it's a shining illustration of the challenges the United States faces. So what do you think about the fact that the United States can't compete with China in terms of infrastructure? Let's start by looking at the tremendous achievements China has made in bridge construction. Among global bridge construction, there is a widely circulated saying: before the 1970s, look to Europe and the US. In the 1990s, look to Japan. In the 21st century, look to China. This saying fully expresses China's outstanding performance in bridge construction. At present, the 5 highest bridges in the world are all in China. Among the top 20 bridges under construction or already completed globally, 15 are built in China. Behind China's frenzy in bridge construction lies advanced science and technology and a robust pool of talent. Without sufficiently advanced equipment and tools and the research abilities of Chinese engineers, achieving such accomplishments would be a far-fetched dream. For instance, the Kunlun No. 1, a 1,000-ton bridge erection integrated machine, represents a significant breakthrough in the construction of high-speed rail bridges. It is the world's first 1,000-ton bridge erection integrated machine with versatile uses and high levels of intelligence, saving significant time and resources in the construction of China's high-speed rail bridges. Let's take another look at an engineering feat in China's bridge construction, the Longyan Bridge Rotation Project in Fujian. The main tower and main beam of the Longyan Bridge weigh a total of 23,600 tons. Chinese engineers needed to rotate them counterclockwise by 21 degrees to reach the designated position as per the design. The construction method involving 2 rotations during the bridge's construction is a pioneering achievement in the field of bridge rotation worldwide. The rotating system can withstand a weight of 25,000 tons, equivalent to 2.5 Eiffel Towers. With the diligent efforts of Chinese engineers, the main tower and beam, weighing 23,600 tons, were precisely rotated counterclockwise by 21 degrees, achieving the world's first double rotation construction in the bridge construction field and showcasing China's exceptionally high standard in infrastructure development. Next, let's delve into China's railway construction. As of the end of 2020, China's high-speed rail network had reached an impressive length of 37,900 kilometers, ranking first globally. Just 5 years earlier, in 2015, the total length of China's high-speed rail was only 24,130 kilometers. As of February 2023, the high-speed railway mileage in China has reached an astonishing 44,345 kilometers. This rate of development is unparalleled in the world, with no other country achieving such progress. The success of China's high-speed rail can be attributed to its extraordinary technological capabilities. High-speed rail is an immensely complex mega-project that demands robust technological support across various aspects, including construction, vehicle manufacturing, operation maintenance, and signal control. China's train control technology is at the forefront globally. As early as 2004, China established a complete train operation control system capable of supporting trains running at speeds over 300 kilometers per hour. Additionally, China boasts the world's largest high-speed rail monitoring and control system and traction power supply data acquisition system, fully equipped to facilitate train coupling in large group operations. These cutting-edge technologies enable trains running at around 350 kilometers per hour to have a continuous power supply, an unparalleled feat. The successful operation of China's high-speed rail is closely linked to the support of China's robust power grid. Let's now explore China's state grid. While many may view it as a financially powerful state-owned enterprise, it goes beyond that. Indeed, the state grid's financial strength is undeniable. For instance, in 2016, its revenue reached a staggering $320 billion, with profits totaling $10 billion, making it the top company among China's Fortune 500 and second globally. However, these achievements are not solely due to their monopoly status, but are strongly underpinned by advanced scientific and technological capabilities. An excellent example of this is the ultra-high voltage transmission technology, in which China leads the world. As early as 2019, China completed the world's first UHV alternating current power line, providing a stable power supply to billions of people. Even in the challenging and remote regions of the West, where construction faces high costs and scarce labor, the state grid is dedicated to providing stable electricity, benefiting countless people nationwide. Furthermore, the state grid has been expanding its energy network overseas, with foreign investments exceeding $10 billion. Backbone energy networks invested in and operated by China's state grid can be found in 7 countries and regions, including Portugal, the Philippines, Brazil, and Australia. Moreover, the state grid has invested in power transmission projects in many countries and regions worldwide. It is worth mentioning that all these overseas investment projects have been profitable, with no recorded losses. Such technological prowess and service level are unparalleled worldwide. In addition to railways, China's road construction is equally astonishing. In just over a decade, from 2005 to 2017, China's expressway length surged to over 70,000 kilometers, with a total mileage of 123,000 kilometers, firmly securing its position at the top of global rankings. In comparison, the United States, following China, has a total mileage of only 103,000 kilometers. The development of China's expressways has significantly facilitated information exchange and trade, providing robust support for the booming express delivery industry. China's express delivery industry is highly developed, boasting efficient logistics and affordable prices, an achievement that is challenging to replicate in other countries. In China's rapid development of infrastructure in recent years, basic materials such as steel and cement have also played a crucial role. In 1949, China's steel production was a mere 150,000 tons, less than a pound per person on average, which was quite scarce. Today, China's steel and cement production has reached astonishing levels. For example, in 2015 alone, China's crude steel production reached 800 million tons, an increase of 450 million tons or 125.9% from 2005's 360 million tons. At the same time, China's cement production also ranked among the top 10 globally. Even in 2015, the rapid development of China's cement industry has left even the former world's richest person, Bill Gates, amazed, calling China the cement king of the world. These examples clearly illustrate China's impressive achievements in infrastructure in recent years. In the year 1978, China's railway tracks extended a mere 50,000 kilometers, an unassuming start to what would become a sprawling web of connectivity. Fast forward to 2018, and this modest network had burgeoned into an astonishing 130,000 kilometers, ushering in an era of unparalleled mobility and accessibility. Equally impressive is the growth of China's expansive highway system, a testament to the nation's unwavering dedication to connectivity and accessibility. The roads that spanned 120,000 kilometers in 1978 have now burgeoned into a staggering 4.05 million kilometers by 2018, weaving the fabric of the nation's progress through every corner of its vast expanse. But what lies behind this seemingly magical metamorphosis? What propels China's prowess in erecting colossal infrastructure projects that seemingly defy the bounds of possibility? The answer is a confluence of factors, each contributing its own unique force to this narrative of advancement. Central to China's achievement is the resolute support and visionary planning by its government. The nation's centralized decision-making structure has enabled swift resource allocation, ensuring that infrastructure projects receive the focus they deserve. Each of China's meticulously crafted 5-year plans serves as a roadmap, guiding investment and development toward a brighter future. This dedication to a long-term vision is the bedrock upon which China's infrastructure edifice stands. A commitment to projects with extended payback periods demonstrates a profound understanding that true progress is not bound by the confines of a single generation. This visionary approach, a rarity in today's world of short-term gains, has enabled China to turn ambitious dreams into tangible reality. The financial might behind China's infrastructure expansion cannot be underestimated. A booming economy and a high savings rate have furnished the nation with the financial muscle to pour into these ventures. Moreover, a shrewd utilization of domestic and international financing mechanisms, including dynamic public-private partnerships, has ensured that these endeavors transcend monetary barriers. China's labor force, a reservoir of skilled engineers, construction workers, and technical wizards, forms another linchpin in this narrative. The swift execution of intricate projects hinges on the shoulders of these experts, who marshal their expertise to turn blueprints into tangible infrastructure. Additionally, substantial investments in research and development empower China to leverage cutting-edge technologies, propelling it to the forefront of global construction and project management practices. Strategically, China has harnessed the power of infrastructure to drive economic growth and bridge regional disparities. By focusing on less developed regions, China has effectively turned its infrastructure web into a tapestry that weaves disparate corners into a cohesive whole. This orchestrated approach exemplifies the nation's resolve to create an economy that thrives on inclusivity and harmonious growth. The government's prowess in fast-tracking approvals and streamlining regulatory processes further underscores China's distinctive approach to development. In a realm where bureaucratic hurdles often impede progress, China's deftness in navigating these challenges ensures that infrastructure initiatives are not bogged down in red tape. It is imperative to acknowledge that China's infrastructure prowess is not without concerns. Environmental implications, debt sustainability, and community displacement warrant careful consideration in this grand narrative. Yet, as China forges ahead, it does so with the recognition that a magical transformation also demands meticulous care and mindful stewardship. In the heart of this evolution stands the Beijing-Daxing International Airport, a gleaming monument to China's transport infrastructure supremacy. With a sprawling terminal encompassing 1.4 million square meters, this airport is a convergence of modernity, innovation, and comprehensive connectivity. A marvel of design, it transcends the conventional boundaries of an airport, incorporating the vitality of an urban hub within its walls. The ambitious interplay between transport hubs, city clusters, and transport networks weaves a tapestry of seamless connectivity that fuels economic growth. This synergy aligns with the nation's strategic vision, as laid out in the 13th Five-Year Plan, resulting in a dynamic that amplifies China's economic vibrancy manifold. But what lies beyond these architectural marvels? How does the common individual navigate this web of transformation? The answer lies in the intricate calculus of travel choices. Standing at the precipice of progress, individuals are presented with a trio of choices: air travel, high-speed rail, and traditional railways. Delving into the realm of numbers, the calculation takes on a life of its own. The allure of flight, swift and efficient, promises a journey of 1.5 hours from Daxing. Conversely, the charm of the high-speed rail beckons, offering a 5-hour route to Beijing. Nestled in the heart of these options lies the allure of the traditional railway, a journey that embraces the tranquil passage of time, spanning 5.50 hours. In a world where convenience is king, high-speed rail emerges as the epitome of comfort and economy. Its siren call is irresistible, for it not only ensures swiftness but also affordability and serenity, melding seamlessly into the modern rhythm of life. This dynamic growth narrative is more than mere infrastructure expansion. It is a paradigm shift in societal mindset. The adage, "if you want to be rich, build a road first," encapsulates the ethos of a nation that once embraced an agrarian identity. Roads and railways, once utilitarian arteries, have transformed into conduits of prosperity, beckoning an era of connectivity-driven economic growth. China's infrastructure prowess has unveiled a deeper symbiosis between development and mobility. This transformation is more than just a matter of concrete and steel. It is a symphony of networks, a harmonious dance between technology, economy, and human aspiration. The ripple effects of integrated transport networks amplify the passage of goods and the fluidity of trade, creating a symphony of prosperity that resonates throughout the nation's economic landscape. Yet, as with any grand narrative, challenges abound. Amidst the rapid expansion of transport arteries, China grapples with the task of harmonizing density, efficiency, and planning. The disparity between urban and rural connectivity remains a poignant reminder that the journey to comprehensive development is ongoing and that every road must lead to progress, irrespective of where it begins. In the bucolic embrace of rural China, the narrative takes a turn, peering into the uncharted realms of rural infrastructure. The vast investments and improvements that have reshaped the urban expanse are paralleled by the challenges that persist in rural landscapes. It is a dichotomy that underscores the complexity of building a harmonious nation, where each corner basks in the warmth of progress. The road to rural prosperity is paved not only with asphalt but also with visionary planning. A roadmap emerges, one that prioritizes not only road construction but also the sustenance of vibrant communities. A road once constructed forms a bridge between dreams and reality, a conduit that empowers individuals to transcend the confines of their birthplaces and embark on journeys that lead to empowerment. At the heart of this narrative is the inimitable question of balance. As China's infrastructure web extends its reach, the harmony between progress and sustainability must be preserved. The ephemeral footprint of roads must be matched by the lasting echoes of development, echoing across the years in a testament to mindful stewardship. China's story of infrastructure expansion is not confined to its own borders. It is a global tapestry of ambition, ingenuity, and progress. It is an ode to the challenging questions that modern society grapples with, an endeavor that the world watches with bated breath as it unfolds. As the narrative unfolds, a distinct motif emerges, the theme of connectivity, of weaving disparate elements into a coherent whole. China's transport infrastructure symphony, with its pulsating highways, soaring airports, and tranquil railways, serves as a testament to the unifying power of development. In this grand narrative, China takes its place at the crossroads of past and future, of tradition and innovation. The orchestra of infrastructure rings in harmony, a reminder that progress is not a solitary endeavor but a collective symphony that resonates through the tapestry of time. With each new highway and each expansive railway track, China's melody of development reverberates, a testament to the harmonious dance between aspiration and reality. As China's journey of development continues, one thing remains clear: the story of its infrastructure transformation is far from over. may already be familiar with China's reputation for colossal infrastructure endeavors, encompassing not only remarkable buildings and transportation systems, but also groundbreaking technology and energy initiatives. The first mega project we want to introduce is the Chinese International Space Station. This is China's very own space laboratory and the second operational space station in orbit after the Russian Soyuz. The Chinese International Space Station consists of 3 modules with a total mass of approximately 90 tons and a design lifespan of 10 years. It will conduct various scientific research and technological experiments across multiple fields and invite astronauts from around the world to explore the mysteries of space together. Currently, 5 of its components have been launched, and 6 astronauts have conducted long-term stays and work on board. By the end of 2022, it's expected to complete all module launches and dockings and officially begin its operations. This project not only solidifies China as a space superpower, but also enhances our understanding of the universe. Would you like to visit the Chinese International Space Station? I certainly would, but I need to shed some weight first, or I won't make it onto the spaceship. The second mega project we'd like to introduce is the Hong Kong-Zhuhai-Macau Bridge. This is a colossal sea-crossing bridge connecting Hong Kong, Zhuhai, and Macau, stretching over 55 kilometers, equivalent to 13 Manhattan Islands put together. It cost 126.9 billion renminbi to build, which is like buying 1,269 luxury mansions. The bridge employed advanced bridge building techniques, including land reclamation, an ultra-long underwater tunnel, complex tower structures, high-performance steel, and concrete, among others. Among them, steel consumption reached an astonishing 420,000 tons, which is equivalent to building 60 Eiffel Towers. From an overall perspective, the Hong Kong-Zhuhai-Macau Bridge is primarily composed of 3 parts: a bridge, a tunnel, and artificial islands. It starts from the Hong Kong port, stretches westward across the Lingdingyang Sea, and connects Zhuhai and Macau. The total length is 55 kilometers, with the sea crossing section covering 42 kilometers, including both sea bridges and underwater tunnels. Artificial islands connect the bridge and tunnel segments in the middle of the sea. How are these artificial islands constructed? The foundation of the artificial islands was formed using 120 steel cylindrical structures, each with a diameter of 22 meters, a height of 39 meters, and a weight of 600 tons. These cylinders were prefabricated on the shore, transported to the sea by ships, and then sunk in the construction area of the artificial islands. The sand was filled inside them, creating a reclaimed land in the middle of the sea, forming the land base of the artificial islands. In simple terms, it's like building a massive retaining wall. Once completed, the area of the artificial islands reached 100,000 square meters, larger than 10 standard football fields. After crossing the sea bridge, vehicles can drive into the underwater tunnel. The underwater tunnel of the Hong Kong-Zhuhai-Macau Bridge is 6.7 kilometers long, making it the longest submerged tube tunnel in the world. How was the underwater tunnel of the Hong Kong-Zhuhai-Macau Bridge constructed? In the 6.7-kilometer underwater tunnel, the deeply buried section is 5,664 meters long and is constructed by connecting 33 sections of reinforced concrete structures known as caissons. These caissons are 180 meters long, 37.95 meters wide, 11.4 meters high, and weigh approximately 80,000 tons, equivalent to the weight of an aircraft carrier. They were sequentially lowered into grooves on the seabed, over 40 meters deep, and then seamlessly connected with an error control of within 2 centimeters. The connected caissons had to ensure they would not leak water for 120 years of use, illustrating the high construction difficulty of this project. During its construction, it faced numerous challenges such as strong winds, tides, earthquakes, navigation protection, and environmental preservation. However, the Chinese didn't give up, and after 10 years of hard work, it was completed in 2018 and was hailed as one of the 7 wonders of the modern world by The Guardian. This bridge not only reduces travel time between the 3 regions, but also promotes economic and cultural exchanges. This project is truly remarkable. turning the three regions into an integrated market and making it more convenient for us to travel and shop. Would you like to visit the Kong-Zhuhai-Macau Bridge? I certainly would, but I need to save up some money first, or I won't be able to afford anything there. The third mega project we'd like to introduce is the Matua Hydropower Station. Located upstream of the Yarlung-Zangbo River in Tibet, it is the second largest hydropower station in the world, only surpassed by the Grand Inga Dam in the Congo River's Inga Falls. The Matua Hydropower Station has an installed capacity of 16 million kilowatts, double that of the Three Gorges Dam, and an annual electricity generation of 74 billion kilowatt hours, equivalent to 10% of the national hydropower output. The construction of this hydropower station will greatly improve energy supply in Tibet and support the national goals of carbon neutrality and peak carbon emissions. Currently, the project has completed its survey phase and is expected to commence construction in 2022, with operations beginning in 2028. This project is truly eco-friendly, transforming Tibet into an energy-rich region and helping us better protect the environment and combat climate change. Would you like to visit the Matua Hydropower Station? I certainly would, but I need to learn some Tibetan, or I won't be able to communicate when I get there. The fourth mega project we'd like to introduce is the Qiongjou Strait Cross Sea Tunnel. This tunnel will connect the Lijiu Peninsula in Guangdong Province with Hainan Island, making it the third largest strait in China after the Taiwan Strait and the Bohai Strait. The Qiongjou Strait Cross Sea Tunnel will accommodate both passenger and freight rail lines and will be dug 150 meters below sea level without disrupting maritime traffic. The project was approved and construction began in 2019, with a total planned investment of 150 billion renminbi. Once completed, it will link the high-speed rail networks of Guangdong and Hainan, reducing travel time between the two regions and facilitating the development of Hainan's free trade port. This project is truly marvelous, turning Guangdong and Hainan into a one-hour living circle and allowing us to enjoy the sunshine and beaches more quickly. Would you like to visit the Qiongjou Strait Cross Sea Tunnel? I certainly would, but I need to buy a high-speed rail ticket, or I won't be able to catch a ride there. The fifth mega project we'd like to introduce is the Hongqi River Project. This is an ecological project that will divert water from the Yarlung-Zangbo River and Nujiang River to turn 30 to 80 million mu of desert into arable land, effectively solving the problem of aridity. This project will transport water from high-altitude areas in Tibet to the dry regions of Xinjiang without the need for electrical pumping. It will be entirely gravity-fed. The project requires significant investment, 10 times that of the Three Gorges Dam, and is a monumental project of our time with long-term benefits. Currently, it's in the planning stage and has not yet officially started. This project is truly magnificent, turning Xinjiang into an oasis and helping us better protect the environment while increasing food and water resources, satisfying the electricity demands of its staggering 1.4 billion population. China has orchestrated a multifaceted approach that blends innovation, diverse energy sources, and strategic infrastructure development. This complex strategy revolves around harnessing conventional fuels, pioneering renewable options, and advancing cutting-edge technologies to power a rapidly evolving nation. In the Gobi Desert in northwest China, a group of engineers is searching for the enormous energy buried beneath the desert. A blasting engineer with 37 years of experience, along with his team, will use 1,418 tons of explosives to blow to smithereens a 38-meter thick layer of rock in an area the size of 5 football fields. At the same time, they must ensure that what goes up comes down in all the right places. The charges cannot be set off simultaneously, which would result in destructive seismic waves. Engineers choose to detonate the explosives in batches. There are 781 blasting holes divided into 12 groups. Each group will be detonated less than 1/100th of a second after the previous group. To make this work, the blasting team needs electronic detonators with an encoder. The operator must accurately control the ignition of thousands of electronic detonators in milliseconds. The Chinese have invested billions of dollars to build facilities in this arid inland area beside the desert to produce coal. The coal found here is of superior quality and has a very high heat value. It contains less sulfur and is therefore less damaging to the environment. Today, coal is still the main energy source that drives more than half of China's economy. This is one of the open-cast mines operating in China. The coal is of high quality, and the seams are very thick. Coal seams of over 15 meters in thickness are regarded as super high seams across the world, and the seams here are up to 30 meters thick. Of course, to mine this precious coal, the upper layer of rock needs to be removed beforehand. After removing the gravel, a new coal seam reveals itself. The daily output of coal from this canyon is over 100,000 tons. It could generate enough power to supply one modern family for 10,000 years, but it's just 1% of China's daily coal output. Coal holds a primary position in China's energy structure. Because of that, it is particularly important to use coal efficiently. One of the most efficient ways is to build large power plants near the coal fields. This reduces transportation costs and keeps pollution away from populated areas, far from the cities. The west of China has substantial coal reserves, but it is very short of water, and that is a significant issue. Building a thermal power plant in a desert was impossible in the past because a traditional thermal power plant requires so much water for cooling. The boiler cannot operate without it. China has begun to construct large thermal power plants in the desert because it has found a solution. The secret lies in these passive cooling towers, which do not use water. As the hot air rises from the top of the tower, cooler air is drawn in at its base over an array of radiators. The 132 radiators are distributed in a V-shape. As this type of passive cooling tower doesn't require large quantities of water directly, it's possible to build them in the desert. The eastern part of China is home to just under 70% of the country's population and over 80% of its economy. However, most of the new energy resources are located in the west, thousands of kilometers away. Energy transportation has been a persistent problem for the country. China plans to construct more large power plants around the coal fields of western China, converting coal into electricity, and then transmitting the power through the grid to the east. This project constitutes the largest energy transmission project in human history. This power transmission line boasts the world's longest and highest voltage. It originates in the Yungar Basin in the far west of China and spans a distance of 3,324 kilometers, crossing deserts, mountains, and canyons to reach the densely populated east. This ambitious endeavor is projected to be completed in 8 years. China has built more than 30,000 kilometers of high-voltage lines to establish the world's largest energy transmission network. To increase the system's efficiency, the voltage needs to be raised. The 1.1 megavolt high-voltage line is currently the highest in the world. It can transmit the energy generated by 80,000 tons of coal over a distance of 3,000 kilometers in a day. To ensure smooth and efficient transmission, the 20,000 conductor joints must be perfectly connected. The cables are connected through intense pressure. First, the outer aluminum wires are stripped back to expose the steel core. Then, the two ends of the steel core are inserted into a metal sleeve. A hydraulic clamp presses firmly on the sleeve to hold the two sections of the steel cable together. After the steel core is joined, a larger sleeve is used to connect the outer aluminum wires. The workers need to hold the two ends of the cables carefully and avoid damaging the conductors while dealing with the 5-ton tensile drag on the cable. To manage this, they must use a special cable that combines strength and flexibility. The job not only requires concentration, but also a head for heights. It will take 6 months to complete the new 3,324-kilometer line, and this is just the beginning. Historically, it has been very difficult for China to develop deep-sea oil and natural gas resources. The energy stored in the deep sea is beyond imagination. As the sea becomes turbulent, the test commences. The key requirement for accurate underwater operations is equipment stability, even in rough seas. In order to achieve this, the engineering ship must maintain a fixed geographical position against the flowing currents and heavy waves. This is achieved through the approach power compensator system. When waves push the ship off its position, the compensator system instantly activates the corresponding thruster to counteract the force of the sea. This keeps the ship steady. However, When the ship rolls or is lifted by the waves, the thrusters alone are not sufficient. But this new ship comes equipped with another special piece of equipment, the world's largest crane with an automatic height compensation system. The high-power crane is capable of lifting up to 400 tons. As the ship rises and falls with the swell, the crane automatically detects the speed and direction of the movement. It then reacts instantly by adjusting its cable lines or turning its lifting arm to compensate for the motion. To fully utilize these favorable conditions, the test must continue well into the night. Images from the underwater camera show that despite the surging waves, the 400-ton test box only moves slightly and remains well within the control range. Everyone is very pleased with the result. With the advancement of deep-sea engineering technology, humanity has taken another step in harnessing resources from the oceans. China has become the first country to successfully mine fire ice from beneath the seafloor. Fire ice, also known as combustible ice, is a common name for methane hydrate. It exists as a flammable solid in which methane is trapped in a crystal structure of water. Originally assumed to only exist in the outer reaches of space, it has been found to exist in extraordinary quantities on Earth, below the seabed. It forms the largest reserve of fossil fuel on the planet. However, extracting it is no simple matter. To date, reliable mining techniques have yet to be developed. China is making conscious efforts to increase the proportion of clean energy in its energy mix. The west of China faces water scarcity but enjoys ample sunshine. The power of sunlight and the duration of sunlit hours make it an ideal site for solar arrays. The key components of the array are these mirrors. When the sun rises over the Gobi Desert at 7 o'clock in the morning, more than 20,000 mirrors precisely reflect the light to the top of a tower. The generated heat is absorbed by molten salt, which carries the heat down into the plant where water is heated into steam to drive turbines for electricity generation. This method of generating electricity neither consumes fuel nor releases emissions, making it an ideal way to utilize solar energy. China has developed a precise sunlight tracking system for this tower-type photothermal power plant. Controlled by a computer, the 20,000 mirrors reflect sunlight to the top of the tower when aligned accurately. The regional conditions favor solar power, but there's more than one way to convert sunlight into energy. Not far away, another solar power plant 10 times the size is under construction. It is a trough-type photothermal power plant. Unlike the tower type, this plant collects sunlight heat through curved mirrors. Both systems, however, rely on precise solar tracking. After installation is completed, the mirrors will be aligned to within less than 1 millimeter. This plant will feature 9,120 solar troughs generating 50,000 kilowatts per hour. China's currently installed solar power capacity exceeds 70 million kilowatts, accounting for 1/5 of the world's solar generation capacity. The increasing ways to utilize solar energy will revolutionize China's supply of clean energy. Its rapid development showcases China's genuine determination to transform its energy structure. However, other emission-free energy sources remain untapped. China is one of the nations taking the lead in seeking renewable energy from wind. Giant turbines have become a common sight in various landscapes. While wind energy is often harvested more reliably at sea, the harsh environment presents significant challenges for turbine installation and maintenance. Previously, turbine generators were assembled on land and then transported to their operating sites by semi-submersible vessels for final erection. This process was costly, slow, and resource-intensive. Today, offshore wind power appears to be the future of wind energy, as breakthroughs in installation technology significantly reduce costs. On the eastern coast of China, a new installation method is being trialed. This newly developed tool can accurately set the blade's angle at a height of nearly 100 meters, aligning it perfectly with the rotor hub. If the machine functions as intended, the cost of offshore wind turbine installation will be significantly reduced. The progress of science and technology drives energy development, resulting in a mixed-source energy policy. On a remote peninsula in eastern China, the world's most advanced nuclear power unit is being prepared for operation. The nuclear reaction generates immense heat, which is used to convert water into high-pressure steam. driving generators to produce electricity. The core of a nuclear power plant is the reactor unit, constructed to the world's highest safety standards. Before commencing operations, numerous and repeated safety inspections must be completed. The engineers test a 3-story high safety door made of special metals and manufactured using aerospace technologies. Like the safety door, nearly 1/3 of the plant's components are designed with the ultimate goal of safety in mind. At the business end of things lie this 10-meter deep pool and the adjacent reaction chamber. The pool will eventually be filled with pure desalinated water. The installation and replacement of fuel rods will take place here. This area has seen countless hours of meticulous preparation, ensuring everything runs seamlessly. The last round of inspections is nearing completion. The nuclear fuel, ready in the fuel bin, is securely stored at the highest level of security. Over 100 fuel units, sufficient to power the plant, are ready for use. Below this floor lies a stockpile of the most powerful energy source humanity has harnessed. Its energy density is 2.5 million times that of coal. A mechanical arm delicately handles the nuclear fuel assembly, each composed of 264 metal tubes filled with nuclear fuel. Prior to startup, they were not radioactive. For 4 hours each day, the engineers' operations are rehearsed repeatedly to ensure a flawless startup when the plant goes into full operation. Nuclear plants operate on nuclear fission, releasing energy through splitting atomic particles. While immensely powerful, this process generates hazardous radioactive waste. By contrast, the sun generates energy through nuclear fusion, producing no radioactive waste. On July 5, 2017, Chinese scientists astonished the world's scientific community by achieving a temperature of 50 million degrees, a critical milestone in fusion research. However, no known material on Earth can withstand such extreme temperatures. A magnetic field provides the answer. The coil enters a superconducting state at low temperatures, generating the Earth's strongest magnetic field. Suspended within this field are the materials for a fusion reaction. Nuclear power, though controversial, remains a great hope for an endless, reliable, and clean energy source in its various forms. Natural renewables will also play a crucial role in meeting tomorrow's demands, while ingenious solutions continue to be sought for today's challenges. In the sparsely populated deserts of the West, the search for a better future, where needs are met and waste is eliminated, persists. The Three Gorges Project, a colossal undertaking that resides in the hearts of many, stands tall as the world's largest hydroelectric power station. Its average electricity production in just 1 second can power a Chinese person's life for more than 4 years. But did you know that upstream, over 1,000 kilometers away, 4 other hydroelectric power stations can rival the Three Gorges in scale? On the Jinsha River, 4 superpower stations have been constructed: Zhangjiaba, Ziluodu, Baihetan, and Wudong. Together, their total installed capacity is 3 times that of the Three Gorges. In China, these colossal hydroelectric power stations are countless, dotting the landscape, nestled between the mountains, forming a massive tribe of hydroelectric giants that provide over half of China's hydropower. Now, you might be wondering, why on earth is China splurging on all these superpower stations? How do Chinese engineers manage to build these mammoth structures in such terrain? And what do they bring to the lives of the Chinese people? Well, today, let's embark on a journey together to find these answers amid these mountains and rivers. The grand cliffs of the Jinsha River's Great Canyon stand tall and mighty, with the river's ceaseless torrents flowing day and night. Over millions of years, these rushing waters have carved narrow and treacherous gorges, reshaping the Earth's surface. Such landscapes are scattered all across southwest China. Tectonic movements over eons have contorted the land here, giving birth to a sprawling mountain range that acts as a barrier, intercepting moisture from the oceans. Abundant precipitation, combined with glacial meltwater, converges into mighty rivers and makes this region the treasure chest of China's water resources. Take the Jinsha River, for instance, with its average annual runoff of a staggering 145 billion cubic meters. Its maximum flow can reach a mind-boggling 29,000 cubic meters per second. At this rate, you could fill up West Lake in just 8 minutes. Apart from this ample water supply, the significant elevation drop provides enormous gravitational potential energy. This southwest region straddles the first and second tiers of China's topography, and the rivers that originate in the western mountains rush relentlessly, unstoppable. Within the Jinsha River's 3,481 kilometers of length, the natural drop exceeds 5,000 meters. This rich water volume and colossal drop combine to create what we call hydropower resources. In China's southwest, the potential hydropower resource capacity theoretically reaches a whopping 490 million kilowatts, accounting for 70.6% of the nation's total. Converting these resources into electricity would be immensely beneficial. That's why over half of China's 13 major hydropower stations are located in the southwest. But how do you harness this energy from the raging rivers? Well, first, you need a dam. Despite the Jinsha River's impressive natural drop, it's not enough to generate electricity efficiently over short distances. So, engineers usually build a massive dam in the middle of the river to raise the water level further, enhancing the drop. But constructing a dam in the turbulent river isn't a walk in the park. Even before construction begins, engineers must divert the river to create a dry construction site, and then restore the original flow after the dam's completion. In 2014, the first superpower station downstream of the Jinsha River was completed, and it's called the Zhangjiaba Hydroelectric Station. This dam is a behemoth, with a crest length of about 900 meters, taking a leisurely 12-minute stroll to cross. Its maximum height reaches a towering 162 meters, equivalent to a nearly 60-story skyscraper. It's solid, like a heavyweight champion in a wrestling ring, firmly resisting the surging river with its massive weight. It's what we call a gravity dam, and it elevates the water level difference between upstream and downstream to a staggering 100 meters. However, such a colossal structure requires an enormous amount of construction materials. During its construction, a mind-blowing 14 million cubic meters of concrete were poured, enough to fill over 6,000 international standard swimming pools. The logistics alone for such a volume is a significant expense. So, are there other ways to construct these dams? Look at this one. It's like a graceful crane, spreading its wings and blocking the Jinsha River behind it. It's slender and elegant, earning the name Baihetan, which means White Crane Beach. Its maximum dam height reaches a towering 289 meters, akin to a 100-story skyscraper. However, its narrowest point on the crest is only 14 meters wide. Despite its slim profile, it can withstand a staggering 16.5 million tons of thrust, equivalent to the takeoff thrust of over 15 Long March 5 rockets. So, how do engineers pull this off? Maybe a change in perspective can provide the answer. From a bird's eye view, you can see that Baihetan Dam employs an arch structure, which we call an arch dam. This design efficiently transfers the force of the water's flow to the mountainous terrain on both sides. With the mountains sharing the load, arch dams don't require the immense bulk of gravity dams to remain stable. Although the dam is nearly twice the size of Zhangjiaba in terms of volume, it only required around 8 million cubic meters of concrete, less than half. Furthermore, arch dams, as statically determinate structures, boast high safety standards. They can even withstand over 10 times their designed load capacity. At the same time, China is continually building taller arch dams, claiming over half of the world's dams are taller than 200 meters. But not just any place can host such arch dams. They require extremely strict geological and topographical conditions, such as steep, narrow valleys and solid bedrock. Luckily, the numerous canyons in the southwest provide the perfect geographical environment for building arch dams. As a result, various types of arch dams have sprung up on this land, including the 240-meter-tall Ertan Dam, the 270-meter-tall Wudong Dam, and the world's tallest at 305 meters, the Jinping'ai Hydropower Station Dam. As these colossal dams and reservoirs gather in the southwest, even the mightiest rivers temporarily bow down to store their energy here. But to convert this energy, we also need a superpower plant. Dams are not just impenetrable water barriers, they're equipped with intricate networks of pipes beyond their visible spillways. These pipes lead to the heart of the power station. Hydroelectric generators direct the water through these pipes to the turbines. The impact causes the turbine blades to spin, converting the gravitational potential energy of the flowing water into mechanical energy. The turbine, in turn, drives the generator, converting mechanical energy into electrical energy, ultimately producing electricity. In this process, we're merely harnessing the power of the water, consuming no fuel, emitting no greenhouse gases like CO2, and keeping it a renewable and clean energy source. In places where the riverbed is wide, engineers can construct powerhouses directly in the middle or behind the dam to house these massive generator units. But what about narrow mountain valleys? Where do you put the equipment there? This is where we find the world's largest network of underground caverns, a labyrinth of 246 tunnels crisscrossing for a total length of 217 kilometers. The largest cavern stretches 438 meters long, 34 meters wide, and 88.7 meters high, big enough to comfortably park 13 Boeing 737 airplanes. These caverns house the world's most potent hydroelectric generator units, with individual capacities of 1 million kilowatts, entirely designed and built by Chinese engineers. Just one of these units running at full throttle for an hour can provide electricity for over 1,000 people for an entire year. Typically, the larger the capacity of the hydroelectric generator unit, the higher its efficiency. The 1 million kilowatt hydroelectric generator units at Baihetan Hydropower Station can achieve an astounding energy conversion efficiency of up to 96.7%, making sure every drop of water is utilized to the max. It's hard to believe that in the mid-1990s, China's domestically designed hydroelectric generator units had a maximum capacity of just 300,000 kilowatts. Today, from the 770,000 kilowatt Ziluodu to the 800,000 kilowatt Xiangjiaba, from the 850,000 kilowatt Wudong to the 1 million kilowatt Baihetan, these 4 superpower stations on the Jinsha River have witnessed the evolution of China's hydroelectric units. Once Baihetan Hydropower Station is fully operational, it will produce over 62 billion kilowatt hours of clean electricity annually. This energy will traverse the high mountains and deep valleys of the southwest, sent through various high-voltage transmission lines to regions nearly 2,000 kilometers away in East China, infusing fresh energy into this magnificent network of west-to-east power transmission. And thus, China has built these superpower stations in the world's most water-rich regions. Across the country, tens of thousands of hydroelectric power stations stand tall above rivers and operate tirelessly day and night, providing over 1 trillion kilowatt hours of clean electricity to the people every year, equivalent to saving 430 million tons of standard coal and reducing CO2 emissions by 1.12 billion tons. Of course, the road ahead is long, and considerations like ecological protection, sediment control, relocation of communities, and disaster monitoring need careful attention in hydroelectric development. But one thing is certain, in the journey to reduce carbon emissions and achieve carbon neutrality, hydroelectric power will play a crucial role. For millions of years, the rushing rivers have nurtured the land and civilization. Today, these mighty rivers are benefiting their people differently. From the 480 kilowatt Shalamba Hydroelectric Station to the 22.5 million kilowatt Three Gorges Hydropower Station, and now the world's largest Baihetan Hydropower Station, one dam after another, One power station after another has risen beneath the feet of generations of builders. This is why we can now use the gifts of this land to illuminate the homes of China, support the surging waves of modernization, and create a bright and hopeful tomorrow. The journey through China's megadams is one of awe and inspiration, a testament to Chinese ingenuity, innovation, and the relentless pursuit of progress. The Baihetan Hydropower Station is another testament to China's clean energy ambitions, a mega-project redefining our understanding of renewable energy. This gigantic power plant, with an installed capacity of 16,000 megawatts, generates over 620 billion kilowatt-hours of electricity annually. But the real story lies in the engineering marvel behind its construction. Let's start with the core, the turbines. Baihetan houses 16 massive 1,000 megawatt turbine generator units, the largest ever built. Transporting and installing these enormous units was a unique challenge, as conventional transportation methods were clearly insufficient. Transporting and assembling such massive components in rugged terrain was an engineering feat. Building the dam itself was no easy task, spanning the Jinxia River with a colossal structure 660 meters across. First, to ensure safety during construction, engineers built a series of temporary cofferdams to temporarily block the river, creating a relatively dry working environment. This not only facilitated construction but also significantly reduced risks and delays. Next came the arduous task of foundation excavation and pouring vast amounts of concrete. The dam stands taller than the Three Gorges Dam, posing more challenges in maintaining stability. A special cooling system ensured the concrete cured properly in the tropical climate. Another critical task was the flood discharge system, which not only had to manage floods effectively but also withstand enormous water pressure during flood seasons. Thus, a complex flood discharge system was installed, a series of massive openings and tunnels designed to release excess water quickly and safely. The Baihetan Hydropower Station is not just a power plant but a breathtaking testament to human capability to tame and harness natural forces. Its massive scale, innovative design, and incredible construction achievements make it a legend in the engineering world. Get ready for a thrilling adventure on China's Siju Bridge. This bridge is a dream come true for the residents of Siju Village, who long for a connection to the outside world. Located in an area prone to earthquakes and landslides, it had to be built to withstand these natural disasters. Engineers even launched the first cable across the valley with a rocket, a bold move that paid off. Today, the Siju Bridge stands 1,600 feet above the ground, offering breathtaking views and standing as a testament to human ingenuity. Finally, let's introduce China's epic transoceanic bridge, the Jiaozhou Bay Bridge. Supported by 5,200 piers and using 450,000 tons of steel, this bridge can withstand an 8.0 magnitude earthquake. This project shortened the distance between Qingdao and Huangdao by about 30 kilometers, reducing travel time by 20 to 30 minutes compared to the highway along the bay. The bridge is designed to withstand severe earthquakes, storms, and ship collisions. Its construction process took about 4 years and cost $2.5 billion, a massive figure. Upon completion, the bridge earned the title of the world's longest sea bridge. The previous record holder was the Lake Pontchartrain Causeway in Louisiana, USA, spanning 38.44 kilometers. The Jiaozhou Bay Bridge is renowned not only for its length but also for its stunning and semi-natural beauty, unparalleled globally. Though built over the sea, it has interchanges up to 3 stories high, comparable to those on land. Did you know? Building such interchanges on land is already challenging, let alone over the sea. This demonstrates the advanced level and development of China's bridge construction technology. This bridge holds significant importance not only in terms of transportation and economy but also attracts millions of tourists annually due to its unique design. Official estimates show that about 30,000 vehicles pass through the Jiaozhou Bay Bridge daily. Many tourists flock from around the world to witness the most beautiful transoceanic bridge. Many have spent an entire day driving on the sea just to enjoy the scenery. Driving on the transoceanic bridge for a long time is truly a wonderful experience. If you have the chance to visit China, make sure to see this bridge and enjoy the beautiful scenery. Building such a long and beautiful transoceanic bridge is no easy feat, but modern machines and advanced technologies were employed in the construction process. The development of China's bridge construction technology has now made significant leaps, building numerous large bridges with innovative structural designs and construction techniques, using highly complex materials and high-tech processes. Now, let's take a look at how Chinese engineers built these world record bridges. With the most advanced construction technologies, the speed and scale of new bridge constructions continue to increase. Statistics show that by 2024, China has built 1.033 million bridges, among which 8,816 are world-class large bridges. This figure reflects China's remarkable achievements in bridge construction and its world-leading position in engineering technology. These statistics not only demonstrate the scale of China's bridge construction, but also showcase the nation's strong capability and continuous progress in infrastructure development. Chinese engineers emphasize that these bridges are pathways to prosperity, which is why bridges connecting economic zones are given priority.
Nice.
Now, let's start exploring China's mega projects that have reshaped the country. Beipan River Bridge. The vertical height of the bridge deck above the Beipan River reaches an impressive 565.4 meters. The tips of the towers reach 750 meters above the valley floor, higher than 2 Eiffel Towers and the Statue of Liberty combined. Currently the world's tallest cable-stayed bridge with a steel truss, it proudly holds the title of the world's highest bridge. In terms of grandeur, it surpasses even the iconic San Francisco Golden Gate Bridge. The 20,000-ton steel bridge deck is the length of 5 Titanics. When China announced its plan to invest 1 billion yuan in the construction of the Beipan River Bridge, American experts predicted it would take China 300 years to complete this monumental project. To everyone's amazement, Chinese engineers defied expectations and completed the colossal undertaking at an unimaginable speed, leaving the once mocking American experts silenced.
Oh God, please, no! No!
In reality, it took only 3 years for China to successfully finish the Beipan River Bridge. One can only wonder how long it might have taken if the project were undertaken by the United States. Feel free to share your thoughts in the comments. The rugged terrain and extremely poor transportation conditions in the Guizhou region had a profound negative impact on the local population's economic development. Therefore, in 2013, China decided to construct a world record-breaking bridge at the intersection of Yunnan and Guizhou provinces to completely transform Guizhou's harsh transportation environment. However, this plan faced mockery from Western bridge expert Smith. With a height of 565 meters, equivalent to 200 floors, surpassing even the tallest U.S. structure, the World Trade Center at 412 meters, foreign media rushed to report on the seemingly impossible project. Smith, after inspecting the Beipanjiang Grand Canyon, asserted that even with American technology, it would take 300 years to complete, suggesting China would need at least 3,000 years. Despite the ridicule, Chinese engineers courageously faced the challenge, determined to make Beipanjiang the world's highest bridge. However, the engineering team was undeterred by external mockery and dedicated themselves wholeheartedly to the construction. situated in a canyon with a main bridge length of 1341 meters. Traditional bridge pier construction in the canyon was impossible. Considering wind risks, the construction team opted for cable-stayed bridge technology. During construction, Chinese engineers innovatively employed longitudinal movement and hanging assembly techniques for the first time, lifting and assembling the 12-meter, approximately 160-ton steel trusses in midair. Precision alignment of 27 mm diameter bolts was essential. Despite the fierce canyon winds, Chinese engineers overcame every challenge, demonstrating their ability to tackle any obstacle. To address challenges like impassable rivers for traditional ship transport of cut-off beams, engineers adopted new methods. Beams were disassembled into smaller pieces, transported to the site by trucks, and assembled like building blocks, accelerating the installation process, shortening the construction period, and reducing damage to the bridge piers. Additionally, for the steel cables lifting the bridge deck, China's engineering team used one of the strongest materials with a compressive strength exceeding 1860 MPa and a dynamic load yield strength reaching 250 MPa. This material greatly ensured the stability of the bridge under strong winds and water vapor erosion, guaranteeing the project's safety. We see the deck of the Beipan River Grand Bridge connected to its towers, with steel cables spanning 250 feet, enough to stretch from New York City to Washington, D.C. To construct this unprecedented architectural marvel, Chinese engineers had to tackle numerous challenging engineering feats. The bridge spans the isolated depths of the Guizhou Grand Canyon, making it an epic engineering endeavor. Between two iconic towers, it stretches over a mile-long deck. Supported by 250-foot steel cables, it carries an incredible 22,000 tons of weight. This bridge can arguably be deemed the most colossal bridge structure on this planet. Through this project, China not only showcased its strength, providing effective support for poverty alleviation projects in Guizhou and Yunnan, but also defeated foreign experts who once mocked China. In fact, even the United States, with its arrogant statements about China, couldn't guarantee the completion of the Beipan River Bridge. This bridge stands as a milestone in China's infrastructure development, serving as an irreplaceable transportation hub. In 2016, with a cost of 1 billion yuan and a construction time of 3 years, the Beipan River Bridge, standing at a height of 565.4 meters, successfully set a new Guinness World Record. China's achievement completely contradicted the initial mockery from the famous American bridge expert Smith, who claimed it would take at least 3,000 years to complete. Located in the central part of the Yunnan-Guizhou Plateau, overcoming steep terrain and complex geology, the Beipan River Bridge has shortened the travel time between Yunnan and Guizhou to just 1 hour, bringing new hope to this land and becoming a source of pride in China's bridge construction. The completion of the Beipan River Bridge signifies another miracle in the history of global engineering. Huangzhuan Overpass. The Huangzhuan Overpass is the most intricate overpass in the world. When viewed from above, one can see a dense network of roads. This overpass consists of 5 layers of structure, with as many as 20 ramps extending in 8 directions. These roads intertwine like roots, making it difficult for even seasoned drivers to find their way down if driving onto the overpass for the first time. It's no wonder it's been dubbed by foreigners as capable of making even navigation systems surrender. Three Gorges Dam. The Three Gorges Dam is the largest hydroelectric power project in the world today, serving as the largest hydroelectric power station and a major hub for clean energy production globally. The total construction volume of the main structure of the Three Gorges Water Control Project is beyond imagination, with 102.83 million cubic meters of excavation for the foundation, 27.94 million cubic meters of concrete foundation, 31.98 million cubic meters of earth and rock filling, 256,500 tons of metal structure installation, and the installation of 34 sets of units with a capacity of 22.5 million kilowatts for the hydropower station. Except for earth and rock filling, all other indicators rank first in the world. The Three Gorges project has three main benefits, namely flood control, power generation, and navigation, with flood control considered the core benefit of the project. The navigation ship lock of the Three Gorges project is 6.4 kilometers long in total, with the main part of the ship lock being 1.6 kilometers long. It consists of double lines of 5-tier ship locks, making it the largest of its kind in the world, and possesses the greatest water level drop among ship locks worldwide. When the Indian Prime Minister saw the Three Gorges Dam project, he instantly lost his composure. In order to surpass China, they hired Japanese experts at high salaries, vowing to build a dam even more impressive than the Three Gorges Dam. However, they ended up with a slap in the face. They invested 220 billion rupees and spent 42 years, finally completing the dam in Jharkhand. But that day also became its anniversary of doom, as the dam collapsed just 4 seconds after it was opened. So, for India to think it can surpass China is simply wishful thinking. China's Sky Eye. China's significant scientific infrastructure, the 500-meter aperture spherical radio telescope, known as the Eye of China and named FAST in English, lives up to its name with its fast and highly sensitive observation capabilities. Located in Pingtang County, Guizhou Province, the Eye of China has a diameter of over 500 meters, equivalent to the size of 30 standard football fields. It outperforms the previously most advanced Arecibo Observatory in the United States. Unfortunately, due to the lack of funding and maintenance by the US government, the Arecibo Observatory telescope collapsed completely on the morning of December 1, 2020, after years of neglect. With this, the era of the Arecibo Observatory telescope, once a superhero in the world of astronomy, has come to an end. It is now replaced by China's 500-meter aperture spherical radio telescope. For FAST, a foreign expert gave high praise, considering the telescope to be a powerful tool for astronomers and one of the most significant contributions made by Chinese scientists, playing a significant role in future astronomical endeavors worldwide. During operation, the 500-meter aperture spherical telescope has observed more pulsars than the total observed by European and American countries, and has even captured extremely rare astronomical phenomena. As a crucial instrument in the Chinese astronomical field, FAST has not only broken the constraints on the development of China's astronomical endeavors, but will also play an even more significant role in the future, achieving more splendid accomplishments. The National Stadium of China, also known as the Bird's Nest, is situated in the southern part of the central area of the Beijing Olympic Park. It served as the main stadium for the 2008 Beijing Olympics, witnessing an unparalleled Summer Olympics. Covering a total area of 21 hectares, the main structure is an elliptical nest-shaped steel truss, 333 meters long from north to south, 296 meters wide from east to west, and reaching a maximum height of 69 meters. The stadium has approximately 91,000 seats. Construction commenced in December 2003 and was completed in June 2008, earning it the title of one of the 10 architectural wonders of the world in 2007. It also hosted the opening and closing ceremonies of the Beijing Winter Olympics, making it the first venue in history to host both the Summer and Winter Olympics opening and closing ceremonies. The bird's nest has become an iconic symbol representing China, imbued with a more sacred and profound significance, marking a milestone in the history of world architecture and serving as a historical witness to the architectural development of China and the world in the 21st century. The Canton Tower, located at the intersection of the new central axis of Guangzhou City and the Pearl River landscape axis, boasts a total height of 600 meters, with the main tower standing at 450 meters and the antenna reaching 150 meters. The outer framework consists of 24 steel columns and 46 steel elliptical rings intersecting to create a unique hollow and open beauty, seemingly twisting and transforming in three-dimensional space. As the world's tallest building with the slimmest waist and the most difficult construction began in November 2005 and was completed in September 2009. The Canton Tower is a classic architectural masterpiece constructed from over 10,000 steel components of varying sizes and angles, creating a series of world records in architecture, including the world's tallest outdoor observation deck and the world's highest thrilling descent. At the top of the tower is the world's highest horizontal Ferris wheel and 16 crystal sightseeing capsules, offering spectacular views of the Pearl River and the dazzling night scenery of Guangzhou. Beijing Daxing International Airport is located between Daxing District of Beijing and Guoliang District of Hebei Province, at the core area of the Beijing-Tianjin-Hebei region, serving as a super-large international aviation hub. Designed and constructed to accommodate a passenger throughput of 100 million and 800,000 aircraft movements annually, the airport is built in two phases. Phase 1 features 4 runways covering an area of 27 square kilometers, with a designed annual cargo throughput of 2 million tons and a passenger volume of 72 million. By 2040, the airport will add 2 more runways, bringing the total to 6, covering an area of 68 square kilometers, with an annual cargo throughput of 4 million tons and a passenger volume exceeding 100 million. The terminal covers an area of 1.43 million square meters, designed with the passenger experience in mind, resembling a spreading phoenix, making it the world's largest airport terminal with 137 jet bridges. Beijing Daxing International Airport officially commenced operations in September 2019, hailed as the first of the new 7 wonders of the world. The journey through China's mega-projects is one of awe and inspiration, a testament to human ingenuity, innovation, and the relentless pursuit of progress. Each of China's major projects showcases the remarkable feats that can be achieved when vision, technology, and sheer determination come together. The world's largest radio telescope, China's FAST, in the majestic mountains of Guizhou Province, China, lies a hidden eye that peers into the universe. This is the world's largest radio telescope, known as the 500-meter aperture spherical radio telescope, which began construction on March 25, 2011, and miraculously rose in just 5 years. Through the diligent efforts and superb skills of countless researchers, it was officially unveiled on January 11, 2020, revealing its powerful capabilities to the world. The size of this eye is staggering. The area of just its reflecting surface is equivalent to 321 acres of farmland, resembling a giant silver dish lying quietly among the mountains, capturing mysterious signals from the universe. Its sensitivity is so high that it is astonishing. Compared to the world's second-largest Arecibo observatory, its sensitivity is more than 2.5 times higher. This means that through it, humans can see farther and delve deeper into the mysteries of the universe. The operational opening of FAST is undoubtedly a major breakthrough for humanity in the exploration of the universe. It is like a key that opens the door to the depths of the universe for us. With its help, humans can gain a more comprehensive understanding of the composition of the universe, conduct deeper research into the evolution of galaxies, and more accurately search for the existence of extraterrestrial life. Its existence greatly broadens humanity's view in the universe, allowing us to better understand ourselves and the world. FAST is not just a telescope but also a symbol of human wisdom and courage. It witnesses China's rise in the field of science and technology, demonstrating the firm determination and strong capabilities of the Chinese people in exploring unknown territories. In the days to come, it is believed that FAST will continue to reveal more mysteries of the universe, promoting the progress and development of human civilization. Have you ever wondered why the United States, known for its technological advancements, hasn't embraced the wonders of high-speed rail like other countries? Well, get ready to uncover the secrets, untangle the complexities, and discover the untapped potential of high-speed rail in America. Prepare to pull back the curtain on the mysteries enveloping America's high-speed rail predicament, and let's dare to envision a future where swift, seamless transportation revolutionizes the American travel experience. It's common knowledge that China boasts the world's fastest and largest high-speed rail network, with over 19,000 miles of tracks. Chinese practically built it overnight, leaving American engineers scratching their heads and wondering if they had a secret formula for speed and efficiency. Meanwhile, Japan's bullet trains have been zooming at nearly 200 miles per hour since the swinging 60s, without a single casualty. It's like they've been racing through time while America's been stuck at the starting line. It is well known that France introduced its high-speed TGV train back in 1981. Europe didn't waste any time jumping on board the high-speed train revolution. In stark contrast, the United States seems to be caught in a leisurely pursuit, endlessly hunting for the elusive path to high-speed rail development. Isn't it ironic that America was once the trailblazer in rail travel? Back in the day, the United States had a railway system that crisscrossed the entire nation. Everything was on track, except for those troublemakers from the auto and oil industries who believed cars were the future. Because the United States developed a strong car culture, especially after World War II. Hence, they might oppose or lobby against high-speed rail initiatives, viewing them as potential competition. In the 1950s, President Dwight Eisenhower decided it was time for America to hit the open road. He signed a bill that allocated a whopping $25 billion to build highways, creating what we know today as the National Interstate System. Unfortunately, rail got left behind in the dust as America revved up its engines. The automobile became the embodiment of the American dream, freedom on wheels. America evolved into a car culture, and escaping from that traffic jam has proven to be quite the challenge. Not only does the nation have a deep-rooted car obsession, but it also contends with powerful oil lobbies, car manufacturing lobbies, and aviation lobbies throwing their weight around in the American political system. They view high-speed rail as competition, and they're not about to relinquish the steering wheel to this burgeoning industry. They've managed to shape the narrative, ensuring that rail remains an afterthought while cars reign supreme. It's akin to a convoluted game of who wants to be the transportation titan. If we compare car ownership statistics, the numbers don't lie. In the United States, there are 850 cars per thousand American inhabitants on average, while in China, it's a modest 250 cars. Somewhere along the line, America shifted from being rail-served to auto-dependent. By the 1960s, America was knee-deep in the car culture, and there was no turning back. But now, America's transportation ecosystem is reaching a tipping point. Highways are bursting at the seams, airports are feeling the squeeze, and the options are dwindling. So, the United States needs to build high-speed rail to change this situation. Imagine a world where air and car travel is replaced by electrified high-speed rail, a greener, more pleasant way of getting around. When Spain's high-speed rail between Madrid and Barcelona came to life, air travel between the cities took a nosedive. People happily abandoned the cramped airplane seats and embraced the convenience of high-speed rail. It turns out that when the rail is efficient and speedy, it wins hearts and minds.
Nice.
If your trip is under 3 or 4 hours, rail dominates the market share, and aviation takes a back seat. So, it seems America is finally waking up to the idea that rail is worth the investment in transportation infrastructure. Recent surveys indicate that 63% of Americans are eager to join the high-speed rail movement, particularly the younger generation, which enthusiastically supports a swifter and more sustainable mode of travel. The time has arrived for the United States to close the gap with the global community, establishing a contemporary, efficient rail network capable of competing internationally. For the United States, overcoming funding challenges remains pivotal, as America hasn't fully committed to high-speed rail like China. A substantial financial boost is required to construct the necessary infrastructure, upgrade existing tracks, and procure high-speed trains. Additionally, the intricacies of the political landscape cannot be ignored. Refocusing priorities is imperative to realign with rail development, countering the considerable influence of special interest groups. So the United States still has a considerable journey ahead if it intends to establish a fully developed high-speed rail network comparable to China's. This endeavor demands a substantial investment in constructing new tracks, enhancing existing rail lines, and establishing modern stations. The United States presently falls short in possessing the comprehensive infrastructure essential for a sophisticated high-speed rail network, infrastructure that numerous other nations have either long possessed or swiftly developed. Furthermore, the creation of high-speed rail systems necessitates substantial funding, and procuring unwavering financial support from both government and private sectors can present a formidable challenge. Fiscal constraints and competing priorities have frequently acted as stumbling blocks, often thwarting ambitious rail projects on a grand scale within the United States. But here's the thrilling development: an increasing number of people in the United States are fervently advocating for the establishment of high-speed rail networks. The benefits of high-speed rail in terms of efficiency, environmental impact, and reducing congestion are too compelling to ignore. Cities and states across the country are starting to realize this, and public opinion is shifting faster than a Ferrari on a racetrack. The United States might just find itself on track to a brighter, faster future of rail travel. So, secure your tickets and embark on the journey, for with unwavering determination and a united endeavor, America has the potential to engage in overdrive and embrace the high-speed rail era. As we come to the end of this exhilarating journey, we hope you've gained valuable insights into the complexities surrounding high-speed rail in America. Qatar is the land where dreams are transformed into reality through visionary architecture and engineering marvels. Among the numerous projects that have caught the world's attention is the Doha New Shark Crossing, an iconic and beautiful bridge set to redefine the Middle East's skyline. Designed by the renowned Spanish architect Santiago Calatrava, the Doha New Shark Crossing is a breathtaking masterpiece that seamlessly combines form, function, and artistic elegance. With an estimated budget of $12 billion, this mega project encompasses 3 bridges interconnected by subsea tunnels, creating a seamless and efficient transportation network. The 3 bridges, ranging in spans from 600 meters to 1,310 meters, serve as magnificent conduits connecting various significant districts of Doha. They link the New Hamad International Airport with the cultural district of Qatari in the north and the bustling commercial district of West Bay. The crossing not only facilitates smooth and rapid traffic movement but also represents a powerful symbol of unity, bridging the gap between different aspects of the city's vibrant life. This ambitious engineering marvel is set to handle an impressive flow of 6,000 vehicles per hour, alleviating the burden on commuters along the Corniche and providing much-needed relief to the city's transport infrastructure. The Doha New Shark Crossing is poised to become a vital lifeline for the city, streamlining the movement of people and goods and transforming the way residents and visitors navigate Qatar's capital. What sets the Doha New Shark Crossing apart is its dual purpose as both an essential transportation hub and a captivating attraction. As you traverse the underwater tunnels that connect the bridges, you'll embark on a mesmerizing journey that blurs the line between art and engineering. Every element of this grand structure has been meticulously designed to create an immersive experience that celebrates the fusion of beauty and functionality. However, it's important to note that the construction of the Doha New Shark Crossing has faced its fair share of challenges and setbacks. The project was temporarily put on hold for reasons that remain unclear, leaving many to speculate about its future. Yet, amidst these uncertainties, the indomitable spirit of Qatar prevails. The Qatari government's commitment to progress is unwavering. While the project's timeline may have been affected by unforeseen circumstances, the dream of witnessing the Doha New Shark Crossing rise above the waters and grace the city's skyline is still very much alive. The megastructure's construction may resume after 2023, rekindling hope that this monumental undertaking will become a reality. When the time comes for the Doha New Shark Crossing to be undertaken, it will undoubtedly be one of the most significant mega construction projects in the world. Qatar's dedication to excellence, coupled with Santiago Calatrava's visionary design, will ensure that this architectural marvel leaves an indelible mark on the city's landscape. As we eagerly anticipate the resumption of the Doha New Shark Crossing, let us acknowledge that great achievements often require time and patience. The completion of this iconic bridge will be a testament to perseverance, meticulous craftsmanship, and unwavering commitment to excellence that define Qatar. So, brace yourself for a future where the Doha New Shark Crossing stands tall as a beacon of architectural grandeur. Get ready to witness the convergence of artistry and engineering as Qatar solidifies its position as a global leader in groundbreaking infrastructure. The journey may have encountered temporary detours, but the destination remains unchanged, a future where the Doha New Shark Crossing becomes a symbol of Qatar's unwavering spirit and its relentless pursuit of progress. In recent years, Qatar has reaffirmed its commitment to propel the Doha New Shark Crossing project forward. The Qatari government has strategically realigned its priorities, recognizing the need to address the demands of a rapidly growing population and ensure sustainable development. As a result, non-essential mega-projects, including the Shark Crossing, were temporarily postponed. However, this temporary pause was not an end, but rather a strategic recalibration. In December 2019, Qatar's Public Works Authority breathed new life into the project, reigniting the flames of anticipation. The government invited local contractors to participate in the revival of this architectural wonder, fostering collaboration and unity within the construction industry. This ambitious undertaking has become a catalyst for international partnerships and alliances, uniting the expertise of local contractors with global engineering firms. It signifies Qatar's commitment to harnessing the best minds and resources from around the world to ensure the successful realization of the Doha New Shark Crossing. While the precise timeline for the project's completion remains uncertain, one thing is clear: Qatar's dedication to progress is resolute. The nation has allocated a staggering $140 billion budget dedicated to the completion of its mega projects, highlighting the unwavering support and financial investment in turning dreams into tangible realities. As we eagerly await the resumption of construction, it's essential to acknowledge the magnitude of this endeavor. The completion of the Doha New Shark Crossing will not be rushed, as it demands meticulous attention to detail, the highest standards of craftsmanship, and unwavering commitment to safety and quality. It is a testament to Qatar's uncompromising pursuit of excellence. Beyond its utilitarian purpose, the Doha New Shark Crossing represents a gateway to a brighter future for Qatar. It signifies the nation's ambition to become a global hub of culture, commerce, and innovation. The completion of this architectural marvel will attract investment, stimulate economic growth, and serve as a catalyst for the nation's continued progress. As we look ahead to the moment when the Doha New Shark Crossing emerges from its cocoon of construction, we envision a transformed cityscape. Its majestic silhouette will grace the azure waters, captivating the imagination and leaving an indelible mark on the collective consciousness. Locals and visitors alike will marvel at its graceful curves and be reminded that dreams, when nurtured with perseverance, can become extraordinary realities. In conclusion, the Doha New Shark Crossing project represents Qatar's unwavering dedication to progress, innovation, and the pursuit of architectural grandeur. While the construction may have encountered temporary setbacks, Qatar's commitment remains steadfast. The completion of this monumental project will stand as a testament to the nation's enduring spirit and its determination to shape a future where brilliance knows no bounds. Prepare to be captivated. Brace yourself for a new era of architectural splendor, seamless connectivity, and limitless possibilities. The Doha New Shark Crossing beckons, ready to etch its name in the annals of history as a symbol of Qatar's unwavering spirit and its boundless quest for a brighter tomorrow. Apart from Egypt, China is also constructing the world's longest artificial canal, the Pinglu Canal. Unfolding quietly across the vast Chinese land is an unprecedented feat, the the Pinglu Canal, which is hailed as the Water Great Wall of China's new era. With its unique grandeur and determination, this artificial canal showcases the excellence and brilliance of Chinese engineering to the world. The Pinglu Canal is a magnificent waterway connecting the main stream of the Xijiang River with the Bibu Gulf. It stretches slowly from the Pingtang estuary in the Shijin Reservoir area of Hangzhou, Nanning, in Guangxi, crosses the beautiful mountains and rivers of Lingshan County, Qinzhou, and finally merges into the vast Bibu Gulf. This is not merely the construction of a canal, but a heartfelt response to the Chinese nation's millennia-old dream of connecting rivers and seas and pursuing maritime strength. Entering the construction site of the Pinglu Canal, one is greeted with scenes of awe-inspiring work. Thousands of workers are toiling tirelessly, and large machinery roars continuously. They carve mountains, dredge river channels, and every inch of land bears witness to their hard work and ingenuity. Here, time seems to be empowered, with each day witnessing the miraculous growth of the canal. The construction of the Pinglu Canal is a concentrated display of China's engineering and technological prowess. From high-precision surveying to intelligent construction, from eco-friendly dredging to ecological restoration technologies, a series of high-tech methods are being employed, not only improving construction efficiency but also ensuring the project's green sustainability. The use of heavy-duty self-propelled cutter suction dredgers, such as the Tianjing, in the estuary section has propelled China's dredging technology to the forefront of the world. Madao Junction, Qishir Junction, Qingnian Junction. These keynote projects along the canal are like dazzling pearls embedded in the grand blueprint of the Pinglu Canal. Workers battle day and night at these nodes, erecting steel bars and pouring concrete, forging one engineering marvel after another with their sweat and wisdom. The completion of these node projects will not only greatly enhance the canal's navigability but also serve as indelible monuments on the Pinglu Canal. The completion of the Pinglu Canal will open the shortest, most economical, and most convenient sea route for southwest China. At that time, goods from the southwest region will be able to reach the Bibu Gulf directly via this canal and then make their way to the world. This will significantly boost the competitiveness and openness of the regional economy and inject new strong momentum into the development of cities along the route. The future Pinglu Canal is destined to become a new symbol of China's maritime strength and open development. On this land filled with hope, the Pinglu Canal tells a story of dreams, courage, and wisdom in its unique way. Let us look forward to the early navigation of this artificial canal and witness the infinite possibilities it will bring to China and the world. We head to the Longjiang Suspension Bridge in Yunnan, China. This bridge connects the cities of Baoshan and Tingchong and stands at a height of 300 meters, equivalent to the height of a 100-story building. The bridge is located in a seismic zone with a history of strong earthquakes. To ensure the bridge's safety, engineers employed advanced seismic technologies and materials, but you can imagine the feeling of experiencing an earthquake on a bridge 300 meters high. It's bound to be hair-raising. Yet, that's just the beginning. We'll soon see even higher and more dangerous bridges. The Siju Bridge spans the Sida River, linking Inchi-Tujia and Miao Autonomous Prefecture in Hubei Province with Fingjie County in Chongqing City, serving as a vital connection between China's central and western regions. It stretches approximately 2.5 kilometers and soars to a height of 560 meters, surpassing the Empire State Building in height. Constructing this bridge posed an immense challenge due to its location nestled between two towering mountains, spanning a deep and precipitous valley. Engineers even used rockets to launch the first cable across. After 3 years of grueling efforts, this bridge was finally completed. Driving on this bridge allows you to enjoy magnificent landscapes and a thrilling experience. But this is not the world's highest bridge. That title belongs to another Chinese bridge. It is the Beipanjiang Bridge. The bridge has a total length of 1,314.4 meters and is part of the Hangrui Expressway. It starts from Duj Town in Yunnan and reaches Laolong Village in Guizhou. In between, it spans the Nizhu River Grand Canyon, earning it the name Nizhu River Bridge. The completion of the Beipanjiang Bridge marked the full opening of the 3,404-kilometer-long Hangrui Expressway. What sets it apart is its height above the river, standing at a staggering 565.4 meters, equivalent to the height of a 200-story building. In the world of bridges, it is considered the tallest. If a person were to fall from the bridge, it would take over 10 seconds to reach the ground, a terrifying prospect for anyone. Beipanjiang Bridge claimed the top spot in the world's highest bridge competition, setting a Guinness World Record in 2018. However, China didn't undertake the construction of this bridge for awards. It was done to facilitate local travel. The distance between Duj Town and Puli Township may be relatively short, but the challenging, mountainous terrain and absence of a direct road turn it into a 4-hour journey, requiring travelers to traverse 3 mountain ridges and cover around 40 kilometers of mountain roads. However, with the completion of the bridge, the journey was reduced to just 1 or 2 minutes, greatly enhancing the convenience of travel between the two sides and promoting economic development in the region. Why was the bridge constructed at such a high relative altitude of 565.4 meters? The area where Beipanjiang Bridge is located, within the Yungui Plateau, features a karst landscape formed by the dissolution and deposition of soluble rock by underground and surface water. The fragile mountain structure in this region doesn't lend itself well to bridge construction. After a year of surveying and exploration, Chinese engineers determined that 565.4 meters was the optimal height to avoid caves and fissures. When planning the Beipanjiang Bridge, American engineers claimed that it would take China 3,000 years to complete. However, the bridge's construction began in 2013, and it was operational by the end of 2016, taking only 4 years. The bridge is made up of a pair of massive concrete towers. The tallest is 269 meters high. The 20,000-ton steel bridge deck is the length of 5 Titanic. One World Trade Center in New York could fit underneath. The deck is attached to the towers with 400 kilometers of cables, enough to stretch from London to Amsterdam. The Beipanjiang Bridge stretches 1.3 kilometers across the ravine. The tips of the towers reach 750 meters above the valley floor, higher than 2 Eiffel Towers and the Statue of Liberty combined. During the construction of the Beipanjiang Bridge, Chinese engineers encountered numerous incredible difficulties and challenges. The first was the terrain, as the Beipanjiang Canyon had steep terrain and complex geology, making construction extremely difficult. The second challenge was extreme weather. Constructing a bridge in the southwestern region entailed addressing recurrent geological hazards, in addition to contending with severe weather conditions such as strong winds, dense fog, heavy rain, and freezing temperatures, which placed high demands on the bridge's ability to withstand these conditions. The primary question was what type of bridge to construct. Conventional beam bridges, arch bridges, and concrete cable-stayed bridges couldn't span the 670 meters of the Beipanjiang Canyon. Designers had to choose between steel truss bridges, cable-stayed bridges, and steel truss girder suspension bridges. Due to the fragile cliff slopes of the karst region, which couldn't support the load of a suspension bridge, a cable-stayed bridge was ultimately chosen. To manage economic costs and environmental impacts, Chinese engineers designed the Beipanjiang Bridge as a double-tower cable-stayed bridge with a span of 720 meters. After the promising blueprint was created, the real challenges began. The U-shaped Nizhu River Canyon extended over 500 meters deep, making it impossible to transport the bridge sections, each weighing hundreds of tons, to the construction site. As a solution, designers divided each section into smaller units of around 10 tons and used reassembling and cantilever launching techniques. Furthermore, Chinese engineers had to use 224 strands of 15.2 millimeter diameter cables to support the weight of the entire bridge, a seemingly impossible task that was achieved with galvanized steel wire boasting a tensile strength of up to 1770 megapascals. To counteract corrosion of the cable stays from extreme weather, Chinese engineers added layers of galvanization, grease, and HDPE both inside and outside the stays, significantly extending their lifespan. On September 10, 2016, after overcoming numerous challenges, the Beipanjiang Bridge was officially completed. Would you dare to drive on this bridge? If you find this terrifying, stay tuned for even more spine-chilling bridges to come. The Jinshajiang Bridge, which crosses the Jinsha River in Yunnan. The main tower is 228 meters tall, with a vertical height of 479 meters, which is equivalent to the height of a 170-story building. The height from the bridge deck to the valley bottom is 335 meters, making it the second highest bridge in the world, surpassed only by the Beipan River Bridge. The Jinsha River Bridge is currently the world's largest cable-stayed bridge spanning a mountainous gorge, with a length of 1,386 meters, consisting of 128 steel truss segments. Each individual steel truss segment weighs a staggering 175 tons, which is equivalent to the weight of over 100 family cars. The bridge's 2 main cables are composed of 42,000 high-strength galvanized steel wires, with a total length of 87,000 kilometers, enough to encircle the Earth twice. When it comes to the world of bridges, China's achievements are not just bragging. China's bridge construction technology is truly incredible. Next, we visit the Lijiang Bridge, a giant bridge that stretches 798 meters across a treacherous mountain valley. While its length may not compare to some of the other super bridges in this video, the Luoji River Bridge is considered an engineering marvel. It holds the record as the world's longest single-tower suspension bridge, distinguishing itself from bridges of similar length with its sole tower, while the remaining structure is supported by cables from a distance. This bridge appears as if it's defying gravity, hanging in midair without visible support. Furthermore, This bridge was constructed in challenging terrain, extending from a 156-meter-tall tower to an anchor point at the far end of a tunnel, all on a steep slope with a 54-degree incline, setting the world record for the steepest tunnel anchor point. Despite its complexity, this bridge plays a crucial role in remote areas, becoming a key component of the 190-kilometer-long U2 expressway that connects Yunnan to major centers like Shanghai. Previously, navigating this valley took over an hour, but the Zhejiang Bridge reduced that time to just 2 minutes, allowing vehicles to travel at speeds of up to 80 kilometers per hour on the 4-lane bridge. This complex megaproject started in 2019 and was completed in 3 years. This bridge has significantly improved the underdeveloped infrastructure in the mountainous regions of China, promoting economic and transportation connections in the surrounding areas. It has played a crucial role in advancing tourism and economic development in the central Yunnan region. Next, we arrive at the Kong-Zhuhai-Macau Bridge, located between the Chinese provinces of Guangdong and Hong Kong and crossing the South China Sea. It holds the record as the world's longest sea-crossing bridge, stretching 55 kilometers and curving like a dragon above the sea. This bridge not only connects the major cities of Hong Kong, Zhuhai, and Macau, but also promotes economic and cultural exchanges. However, its construction has been fraught with controversy and risks. During construction, nearly 20 workers lost their lives, and there was a scandal involving falsification of concrete quality. Additionally, American engineers questioned whether this bridge could withstand the impact of strong winds and huge waves. Although these allegations were officially denied, the safety of this bridge remains a subject of debate. Our journey is not over yet. We're about to show you a bridge that is nothing short of breathtaking. The Qishui River Bridge, another super bridge constrained by extreme geographical conditions, spans over 2,000 meters, connecting the provinces of Sichuan and Guizhou, with a peak height of approximately 350 meters. Constructing this bridge posed a major challenge due to the limited access to the construction site on the Sichuan side, where cliffs made it impractical for most heavy equipment traditionally employed in bridge construction to reach the area. Thus, engineers decided to build the bridge deck off-site and later transport it in 3 segments to the gorge. They used 158 cables to support the bridge deck, ensuring its proper placement using 3D visualization technology. The construction budget for this bridge was just $147 million, far lower than some of the astonishing super bridges we'll mention shortly. Then there's the Guoliang River Bridge, a cable-stayed steel box girder bridge located above the Guoliang River in Guizhou. Completed in 2017, it spans 1,080 meters with a vertical height from the bridge deck to the valley floor of 370 meters, equivalent to 120 stories, making it the world's 8th highest bridge. Next, we visit the Guozigou Bridge in Xinjiang, which is Xinjiang's first cable-stayed and highest bridge. It is the largest and most important bridge in Xinjiang, as well as China's first road steel truss cable-stayed bridge, considered a miracle of infrastructure construction in Xinjiang. The Guozigou Bridge spans approximately 700 meters, with the bridge deck height above the valley floor of about 200 meters. The entire main bridge is constructed using steel truss technology, with 17,000 tons of specialized bridge steel and high-strength bolt connections instead of traditional welding. Precision during installation had to be maintained within 2 millimeters, costing about $3.4 million per meter, with a total cost of $2.39 billion. In constructing the Guozigou Bridge, groundbreaking technologies were applied, such as large-volume concrete temperature control, tower and beam asynchronous construction processes, hydraulic jacking, and self-moving templates, establishing valuable experience in constructing highways in mountainous areas. The Guozigou Bridge boasts a spectacular and unique design. Its S-shaped structure winds through the valley, surrounded by towering peaks and colorful flowers. Driving across this bridge feels like being in a painting. Finally, we arrive at the Aizhai Bridge, a cable-stayed steel box girder bridge located above the Aizhai River in Hunan. Completed in 2016, It stretches 1,176 meters with a vertical height from the bridge deck to the valley floor of 336 meters, ranking it as the world's 9th highest bridge, following the Beipanjiang Bridge, the Jinshajiang Bridge, and the Balu River Bridge. The long dragon-like main span resembles a great sword piercing the clouds, and it appears as a rainbow bridge, connecting the picturesque landscapes on both sides of the valley. The two towering 206-meter-tall main towers serve as the guardians of the bridge, especially dazzling at night. The cable length and height of the bridge deck above the ground also reach the world's peak. These accomplishments showcase the unwavering spirit of Chinese engineers and their relentless pursuit of the unknown. The Aizhai Bridge goes beyond human imagination, incorporating elements of harmony between people and nature, tradition and modernity. It embodies the courage of Chinese engineers in innovation and conveys respect for nature. It will undoubtedly become a lasting human miracle, inspiring future generations to stay true to their original aspirations and promote a positive cycle of harmonious development with nature. Standing on the observation deck at 200 meters high, you can not only witness the magnificent landscapes but also contemplate the harmonious coexistence of humans and nature. These are the most hair-raising bridges in China that we've shared with you. China's bridge projects are undeniably magnificent spectacles, transforming not only the country's domestic transportation and economic landscape but also showcasing China's extraordinary strength in bridge construction technology and innovation. These bridges are not just transportation facilities. They symbolize the relentless pursuit and innovation of the Chinese people, symbolizing the unyielding spirit of exploration in the face of challenging projects. China's bridge construction not only brings invaluable experience domestically but also inspires other countries to actively catch up with China's leading position in infrastructure development. Chinese engineers continue to break technological barriers by building enormous transportation bridges. These bridges are crucial elements of China's vast road network, enabling efficient and rapid transportation. It's worth mentioning that many of the world's most challenging and record-breaking bridges were designed and constructed by Chinese engineers. China's commitment to infrastructure development has created a miracle that impacts the lives of over 1 billion Chinese citizens and drives domestic economic growth. These cases demonstrate the remarkable achievements China has made in bridge construction in recent years, garnering worldwide attention and setting a positive example for other countries. The extraordinary capabilities of China in bridge construction have convinced many Americans that China is a developed country. Today, as we traverse China's extensive road and rail networks, it's almost certain that we'll encounter not just one, but a multitude of bridges. These structures proudly stand amidst towering mountains, span overflowing rivers, and bridge straits and bays, intricately connecting the vast and intricate terrain of China. Taking a journey through the annals of China's bridge development over the past century reveals an awe-inspiring evolution. From the Qiantang River Bridge to the Shanghai-Nanpu Bridge, and from humble beam bridges to robust truss bridges, graceful arch bridges, and onward to majestic cable-stayed bridges and suspension bridges, we arrive at the grandeur of kilometer-spanning superstructures over the seas. This progression showcases how China's modern bridges have transformed from mere aspirations into global benchmarks, shifting from playing catch-up to setting the pace. The Beipanjiang Bridge serves as the epitome of this remarkable progress. Soaring 2,000 feet above the tumultuous Beipanjiang, it claims the title of the world's highest bridge. This groundbreaking project required 3 years of dedicated construction and a staggering $147 million investment. Substantial research grants, totaling millions of dollars, were instrumental in realizing this towering marvel. The creation of the Beipanjiang Bridge brought about a revolution in travel within China's Guizhou province, renowned for its challenging, rocky terrain that demands the construction of numerous tall bridges. Notably, the bridge outperformed China's high-speed rail in the region, reducing valley crossing travel times from 3 hours to a mere 5 minutes. China boasts a reputation for its towering bridges, with over 250 bridges exceeding 100 meters in height, more than any other nation in the world. Among these engineering marvels is the Sidu River Bridge, which once held the record for the world's highest bridge before the Beipanjiang Bridge's completion. The Beipanjiang Bridge unquestionably stands as a remarkable engineering feat located in China's Guizhou province. This bridge is renowned for its record-breaking height and innovative design. Soaring to an astounding height of 565 meters above the Beipan River, equivalent to a 200-story skyscraper, it proudly holds the title of the world's highest bridge when measured from the deck to the ground. Situated on the border between Guizhou and Yunnan provinces in southern China, the bridge plays a pivotal role in connecting these challenging terrains. The construction of the bridge was an ambitious undertaking, with a substantial price tag of approximately $147 million. When completed in 2016, it officially set a world record for its height, earning recognition from the Guinness World Records in 2018. This cable-stayed bridge features 4 lanes and boasts the world's second longest span of steel truss cable. Its innovative design and engineering solutions were imperative to overcome the rugged terrain and the need to withstand strong winds in the deep valley. The Beipanjiang Bridge has had a profound impact on transportation in the region, significantly reducing travel times between previously inaccessible areas. For example, it transformed the journey between Yunnan's Zhenhui City and Guizhou's Chuxi-Cheng County from a 5-hour ordeal into a mere 1-hour commute. The first bridge of the Beipan River is not only a vital transportation route, but also a captivating scenic attraction. Standing on the bridge, you can overlook the rushing waters of the Beipan River, feel the gentle breeze caused by its turbulent currents, and experience the power of nature. The bridge's unique design gives you a sensation of floating above the river as if strolling through the clouds. With its distinctive design and robust structure, this bridge has created opportunities for human success and prosperity, allowing people to deeply appreciate the harmonious coexistence of humanity and nature in this exquisite and magnificent engineering marvel. Furthermore, the bridge has spurred economic growth by increasing accessibility and attracting tourists to the area. It has enhanced regional integration, enabling people to move more freely. China is renowned for its extensive portfolio of towering bridges, with the Beipanjiang Bridge being a prime example. China leads the world in bridge construction and engineering, boasting several of the world's highest bridges. While the Beipanjiang Bridge currently holds the title of the world's highest, future projects may surpass it. Nevertheless, China's unwavering commitment to infrastructure development ensures its continued leadership in the construction of tall bridges. The Beipanjiang Bridge stands as a testament to China's engineering prowess and dedication to infrastructure development. Its completion has significantly improved transportation and connectivity in southern China, solidifying its status as an iconic symbol of innovative engineering. Height of the world's 20 mega bridges that exceed 300 meters from deck to water, all are in China. So it's not likely that the Beipanjiang Bridge will lose its title as the highest bridge anytime soon, and if it did, it would probably lose it to another. Chinese engineers' creation of the bridge construction not only made commuting easier but broke some records. Themselves look good, they also created one of the coolest and most breathtaking man-made structures in the world that seemed to blend perfectly with its surroundings. Worth it, the Beipanjiang Bridge might be the highest in the world, but it's nowhere near the most expensive. The title belongs to Hong Kong-Zhuhai-Macau Bridge, which costs $20 billion. The Hong Kong-Zhuhai-Macau Bridge is a milestone in the history of Chinese engineering construction, boasting the longest span, the highest investment, and the most challenging construction complexity in the country's history. The total length of the bridge and tunnel system is 55 kilometers, designed for a speed of 100 kilometers per hour, with a total project investment of 126.9 billion yuan. Its completion marked another significant achievement in China's bridge building history, earning it the distinction of being one of the 7 wonders of the modern world. The main structure of the bridge is approximately 29.6 kilometers in length, consisting of a combination of bridges, artificial islands, and tunnels. It comprises a 5.3-kilometer tunnel and a 22.9-kilometer steel structure bridge. 2 artificial islands are connected by underwater immersed tube tunnels, and these islands are further linked to the mainland by bridges. The main bridge alone required a staggering 420,000 tons of steel, equivalent to the weight of 60 Eiffel Towers. The entire construction of the bridge followed a modular approach, where all components, regardless of size, including the towering bridge piers, bridge decks, and 100-meter-high bridge towers, were manufactured as complete units in onshore factories and then transported to the sea for assembly, akin to assembling building blocks. This method ensured precision in construction and minimized the environmental impact of the project. The Hong Kong-Zhuhai-Macau Bridge is not merely a bridge but a testament to human courage and ingenuity. It bears witness to technological breakthroughs and the miracle of human cooperation. Whether you journey across the bridge towards the future or take a leisurely stroll upon it, this bridge will forever stand as an eternal symbol connecting humanity with nature. In the years to come, as you walk upon the Hong Kong-Zhuhai-Macau Bridge once more, you may reminisce about its construction journey and the profound human wisdom and courage it embodies. Regardless of where you are, this bridge will forever link your heart with the magnificent scenery, leaving an indelible mark of beauty. Next, let's take a look at another epic bridge in China, the Yachi Bridge. This bridge boasts a deck height of 434 meters, ranking 5th on the list of the world's tallest bridges. It is also the world's largest cross-border steel truss cable-stayed bridge, constructed with intersecting red steel materials. The main span between the towers reaches 800 meters, making it the world's longest mountainous cable-stayed bridge, reducing the travel time from Guoliang to Tianxi from 2 hours to just 50 minutes. The Balan River Bridge is the world's first kilometer-class cross-border mountain canyon suspension bridge, with a main span of 1,088 meters. Its completion has shortened the travel time from Huangguoshu Waterfall to Guoliang County from 30 minutes to just 5 minutes. The Hejiang Special Bridge, with its towering 195-meter pier number 11, holds the record for the world's tallest concrete continuous steel truss bridge pier. However, among all the bridges in China, the true champion of bridge structure height is the Pingtang Special Bridge, with its central tower reaching a height of 332 meters, setting a new world record for cable-stayed bridge tower height. This bridge opened to traffic in December 2019, reducing the travel time from Pingtang to Luodian from 2.5 hours to just 1 hour, making it a vital transportation route in Guizhou. Chinese bridges, much like high-speed railways and aerospace endeavors, have become a shining hallmark and powerful symbol of China. They are displaying their majestic grandeur and boundless vitality to the world, spanning across oceans and leading towards the future. Today we've explored the awe-inspiring China's mega bridges. Each of these bridges showcases the remarkable feats that can be achieved when vision, technology, and sheer determination come together. When you first enter an underwater tunnel and make your way to the other side safely, it's hard not to feel a sense of awe and wonder. After all, the ocean exerts tremendous pressure at great depths, and even iron blocks can be flattened under such extreme conditions. So, the technology used to build underwater tunnels must be truly remarkable, right? Surprisingly, constructing these tunnels does not necessarily require highly advanced technology. It's all about perspective and understanding the methods employed in tunnel excavation. Let's explore the two main methods used for constructing underwater tunnels. The first method is known as shield tunneling. As the name suggests, this method involves using a shield machine to excavate under the seabed. Imagine a giant iron block resembling a massive drilling head, rotating slowly to excavate the underwater rock and gradually moving forward. These shield machines are unified structures that simultaneously excavate the rock walls and transport the debris to the surface through a conveyor belt system. In essence, they excavate, transport, and advance, all in one continuous operation. However, the shield tunneling method has one major drawback: it is relatively slow. Due to the complexity of the underwater environment and the need for careful navigation, shield tunneling progresses at a slower pace compared to land-based tunneling. Making a few meters of progress in a day is considered good progress in underwater tunnel construction. Moreover, the complex underwater conditions demand great caution, as any mishap can quickly escalate into a critical situation. When the shield machine encounters hard rock formations that impede its progress, explosives may be required to clear the obstacle. However, the clearing process follows traditional land-based methods of digging holes, blasting rocks, and creating a passage. Once the obstruction is cleared, the shield machine can resume excavation and move forward. On the other hand, the second method, known as the cut-and-cover method or specifically the immersed tube method, offers a simpler and more direct approach. In the immersed tube method, large tubes are prefabricated on land and then submerged along a predetermined underwater route. These tubes, usually constructed in sections, are sealed with watertight bulkheads at both ends. Some water inlet ports are also incorporated to facilitate subsequent water drainage during the sinking process. The tubes are then towed by ships to the designated location and carefully positioned into the excavated trench at the crossing point of the tunnel. Once all the tubes are in place, the ends of each tunnel section are connected, and the internal bulkheads are removed. The water is then drained from the tubes, and they are finally removed, completing the construction of the underwater tunnel. The immersed tube method is considered the fastest construction method for underwater tunnels. It offers strong seismic resistance, minimal environmental impact, and a relatively safe construction process. Notable projects such as the Hong Kong-Zhuhai-Macau Bridge submarine tunnel in China and the Hong Kong Cross Harbor Tunnel have been successfully constructed using this method. However, like any construction technique, the immersed tube method has its drawbacks. One notable challenge is the complexity of drainage and the risk of accidents. Since the tunnel structure is exposed underwater, proper waterproof measures must be implemented to prevent water leakage. Moreover, the tunnel's exposure to the marine environment makes it more susceptible to damage from ship anchors and potential shipwrecks. Although the construction process itself may seem relatively simple, it presents significant challenges in terms of technical expertise and knowledge. For instance, blasting hard rocks underwater requires specialized skills and expertise. It is not as simple as placing explosives and detonating them. Highly trained engineers with postgraduate degrees specializing in this field conduct comprehensive discussions and research seeking the input of blasting experts to determine the appropriate use and quantity of explosives. The consequences of misjudgment can be catastrophic, resulting in not only casualties but also the failure of a multi-billion-dollar tunnel project. Additionally, before commencing the construction of an underwater tunnel, specialized engineers must thoroughly understand the geological conditions along the entire route. This necessitates extensive geological surveys and analyses, examining each position along the construction route. Furthermore, contingency plans must be developed to ensure that construction can continue, bypassing any difficulties encountered along the way. In conclusion, the construction of underwater tunnels can be considered both difficult and not difficult, depending on the perspective. From a technical and knowledge standpoint, it is undoubtedly challenging and may be hard for ordinary people to grasp fully. However, when we consider the construction methods and the expertise involved, it becomes evident that underwater tunnel construction is a complex endeavor requiring meticulous planning and execution. So, have you gained a better understanding of how underwater tunnels are built? We would love to hear your thoughts and insights in the comment section below. We all know that the plank path is a remarkable invention in ancient Chinese transportation history. In order to traverse deep mountain valleys, people ingeniously carved rhombic holes into cliffs isolated by rivers, inserting stone or wooden stakes into these holes. Planks or stones were then horizontally laid, providing walkways. In this video, we'll explore how these thrilling cliffside pathways were created. First, let's talk about the plank path workers in China. They are a group of warriors who bravely construct pedestrian pathways on cliffs, using their hands and wisdom to open up paths for transportation and tourism in mountainous areas. Their working environment is extremely harsh, facing significant risks during the construction process. Yet, the outcomes of their labor are truly astonishing. They are not only miracles of China's infrastructure, but also a source of pride for the Chinese people. Each plank path they build is an engineering marvel. They not only provide convenience for transportation and tourism in mountainous areas, but also add charm to the local scenery. The construction of a plank path is a challenging and arduous task. Workers not only face harsh natural conditions, but also bear enormous safety risks. Without safety protection measures, workers stand on scaffolding near cliffs during plank path construction, risking the danger of falling into the abyss. They walk on toughened glass, facing the risk of severe injury or death if the glass breaks or slips. When constructing steel pipe frameworks, the risk of pipes loosening or breaking poses a threat of piercing or injuring workers. While laying wooden planks or concrete, the possibility of boards or concrete falling could result in self-injury or harm to colleagues. Throughout the construction process, workers must remain vigilant against natural disasters such as landslides, falling rocks, lightning, and more. Along the plank path on the cliffs, workers shuttle back and forth, seldom speaking. They concentrate on their work and the path beneath their feet. Workers are pushing mixed soil on a narrow cement plank path, slightly over 2 meters wide, a sight-inducing anxious perspiration. Due to the unique geographical location, the mountain road can only reach the parking lot at the foot, about 400 meters away from the construction site. To build the plank path, the construction team managed to provide water and electricity without conventional access to such resources. Cement and sand needed for the project were manually transported by workers in buckets suspended on ropes. However, workers on the plank path lack safety guarantees while working on cliffs hundreds of meters high. They have no safety ropes, only rudimentary tools such as wooden boards, hand carts, and rusty scaffolding. During plank path construction, finding a reasonable plank path route based on the terrain and topography is crucial. Workers stand on scaffolding near cliffs without safety protection measures, which is just the first step in road construction. Plank path workers build steel pipe frameworks and lay wooden planks or concrete, forming a stable pedestrian pathway on the cliffs. The construction of plank path requires advanced skills and rich experience, as every terrain and wind direction is different, requiring design and construction based on the actual conditions. Plank path workers usually do not use safety ropes because they would affect their flexibility and efficiency. They rely on their own balance and agility to shuttle in high altitudes. They work from 6 a.m. to 5 p.m. daily, each assigned specific tasks, earning around 300 to 400 yuan per day. The work ethic of plank path workers is admirable. They face difficulties without fear or hesitation, pursue excellence without negligence, shoulder social responsibilities without greed or selfishness. They are a group of people with noble character and lofty ideals. With their sweat and lives, they contribute to China's development and the happiness of its people. They are the plank path workers of China. Now, let's experience another even more thrilling cliffside road. This cliffside road is renowned as one of the world's most treacherous highways, constructed in the 1970s. With a total length of 1,500 meters, height of 5 meters, and width of 4 meters. To ensure visibility for drivers, workers carved out 30 windows of various sizes on the rock face, offering a view through which one can witness the sheer cliffs below. What is truly astonishing is that this road is hailed as the 9th wonder of the world because it was manually chiseled by 13 farmers over 5 years, without the use of any mechanical equipment. During the construction, villagers went to great lengths, breaking 4,000 hammers and consuming 12 tons of steel drills. With sheer determination and bare hands, the entire village carved out this breathtaking passage amidst the mountains. Today, this cliff-hanging road stands as a symbol of Guoliang Village and serves as the primary attraction in the 4A-rated scenic area of Mount Wanxian in China. Every year, numerous tourists flock to witness it firsthand. Are you interested in experiencing it yourself? Okay, let's go! Finally, let's explore together the houses perched on the cliffs at the foot of the mountain. This place seems like a real-life martial arts world, with every scene breathtaking. Wanxian Valley is located in a remote mountainous area in China, surrounded by magnificent mountains, lush forests, and clear streams. The beauty and tranquility of this place are awe-inspiring as if it were an isolated paradise. However, the most remarkable are those houses on the cliff edges, appearing as a perfect integration of humanity and nature. Constructed by local villagers, these houses employ ancient building techniques and materials. Most of them are wooden structures, harmoniously coexisting with the surrounding environment. Built against the mountains, wooden ladders and paths on the cliffs lead to different residences, each step providing an intimate encounter with nature. Looking out from the windows of these houses, you'll be greeted with picturesque landscapes, mountains, waterfalls, and swirling clouds, creating a sense of being in a fairyland. Wanxian Valley is a place that captures the imagination, pushing the harmony between humanity and nature to the extreme. Token Stone Road. This is one of the most dangerous roads in China. Viewed from a distance, it appears as if nestled between two mountain peaks, resembling a colossal token with mountain peaks that seem to have been cut and split like a blade, hence its name, Token Stone Road. Due to significant changes in terrain, it was designed in a Z shape, making it meander and twist. What is astonishing is that this 453-meter-long Z road has a total of 18 hairpin turns, with the first 6 being extremely steep slopes, the steepest reaching up to 70 degrees. Even more unbelievable is that, unlike typical winding mountain roads with more space between turns, the bends on Token Stone Road are very close, with only 20 to 30 meters between each one. Over the years, numerous cars and motorcycles have come to a halt on Token Stone Road due to malfunctions, and some vehicles have even come perilously close to tumbling off the cliffs, turning into shattered bones. Even seasoned drivers who have conquered 108 hairpin turns on Mount Everest in 72 on the Nujiang River hesitate when faced with Token Stone Road. Therefore, Token Stone Road can be described as one of the most perilous roads in China. Driving a car on this road tests our driving skills and challenges our courage and bravery. It can be said that driving a car on this road is extremely difficult. Kunshan Cliff-Hanging Road. This is one of the most distinctive roads, a daring route carved into the sheer cliffs. Traffic experts describe it as a remarkably challenging endeavor, rarely seen in the history of road construction in China. To facilitate construction and allow natural light after opening, the cliff-hanging road closely adheres to the rock, with side windows spaced every 10 meters. The Kunshan Cliff-Hanging Road spans a thrilling 7.5 kilometers, skillfully chiseled into the rock face. It's a breathtaking marvel, dubbed the Heavenly Road on the cliff, and proudly stands as one of the world's most beautiful cliff-hanging roads. Peering down from these side windows reveals an abyss of unfathomable depth, enough to send shivers down your spine and make you hesitate to take a deep breath. From a distance, this line of side windows resembles the windows on a train, gracefully outlining the tunnel's path. It's a sight to behold, a masterpiece that can truly be considered one of the wonders of the world. Guoliang Cave. In the Hui County section of the Taihang Mountains in China Province, there is a hanging road known as Guoliang Cave, renowned as one of the world's 10 most dangerous roads and one of the 18 most unique roads globally. It is perched on cliffs with a bottomless abyss beside it. People marvel at the construction of this cliffside corridor. To understand the origin of Guoliang Cave, we must delve into the history of Guoliang Village. Situated in an isolated mountainous region on the Taihang Mountains, the village is positioned 1,700 meters above ground, surrounded by mountains on 3 sides and a cliff on the 4th, almost a land of impossibility. For over 600 years, the only passage connecting Guoliang Village to the outside world has been this cliff-hugging trail, narrow enough for only one person to traverse at a time. Each day, one must navigate a total of 720 steps to travel back and forth. All the resources and goods essential for production and daily life rely entirely on manual labor for transportation. Walking along such a path is not only arduous but also perilous. In case of illness, villagers couldn't leave the village, effectively confining generations within. In 1972, under the leadership of village chief Shin Mingxin, the villagers of Guoliang decided to tunnel through the cliff to establish better access to the outside world. Funding the project by selling goats and yams, they selected 13 young men, referred to as the 13 heroes, to lead the road construction. These young men, facing daily meal costs of just 1 jiao, invested all village incomes in explosives and detonators, while the rest of the villagers, including the elderly and children as young as 8, cleaned the dug rock pieces. The cliff surrounding Guoliang Village was composed of sedimentary rock with a hardness of 8.3, compared to the hardness of diamond, which is 10. During construction, a steel bar had to be requenched for every 10 centimeters, leading to the use of 12 tons of steel bars and the breakage of over 4,000 hammers. Despite the lack of electricity and machinery, the villagers, relying solely on their hands, spent 5 years carving a cave with dimensions of 5 meters in height, 4 meters in width, and a length of 1,200 meters. Today, Guoliang Cave has transformed into a local scenic spot. Driving along the cave, one cannot help but be moved by the unwavering efforts of the villagers of Guoliang Village, impressed by their persistence and deserving of our respect. So, fellow thrill seekers, as you cruise along this once impossible road, tip your hat to the gutsy villagers of Guoliang and ask yourself, do I dare to challenge? Brace yourself for the adventure of a lifetime.